Hello everyone and welcome to this session on AWS DevOps Full Course. Before we begin with this session, please subscribe to our channel and hit the bell icon for more updates from us. Cloud computing and DevOps has brought us about a plethora of changes in how IT teams function. From lesser downtime and scalability on demand to automation of testing and quicker software release, the world of software development is completely changed. AWS is one of the largest cloud service providers, and it provided many different services to fulfill the need of deploying an end-to-end CI/CD pipeline. So let's check out the agenda for today's session.
Now, what is the cloud computing? We all know cloud computing is when you use a computer server, which is being hosted on a different premises. This server needs to be accessed over the internet by using some web-based tools for personal and business use cases. So in cloud computing, the concept is that the storage, the application, the networking components, the infrastructure that we access or that we manage is not locally there. It's there in a different data center, which you may or may not own, but you access those resources over the internet. Virtualization. Now, what is virtualization, by the way? Virtualization is a concept that empowers cloud computing. Now, I came across a virtualization in 2010. I was working in Cisco, and I was for Cisco support and Cisco networking infrastructure management. I was there. So we were working on Cisco UC servers, and we came across this virtualization where upon the hypervisor, we used to deploy different virtual machines, the CUCMs and Cisco Unified Call Managers. So virtualization is a concept where on a same physical server, you can deploy multiple virtual machines. Fine. So it's a concept, it's a creation of virtual version of something, whether it's an OS, server, storage device, or networking resources. So basically, virtualization means that on a single physical machine, you can deploy multiple applications that are supported by multiple operating systems. Fine. Now, what is cloud computing? Cloud computing means that it is a cocktail of virtualization plus internet or intranet. So you virtualize your entire environment and you offer that environment. So for example, Amazon Web Services, it's a cloud computing service provider. It has virtualized the entire environment and offered to you over the internet or intranet. You can have your private network going to the AWS, or you can use internet. So everything that you see on AWS, it is virtual in nature. What do you mean by virtual in nature? If I deploy anything through this page, I can see that what's going on, but I cannot see the exactly physical hardware behind the scenes. If I today, for example, go to the EC2 and start deploying my EC2 instances, I cannot see that on which physical server it's running. So it's virtual in nature. At the back end, of course, physical servers are running. It is the rack of servers are mounted. So I can access those resources over the internet or intranet. And also, this entire thing is virtual in nature. Fine. So that's about the cloud computing. Now, what are the advantages? Now, today, the stage is that even the big corporations like General Electric or maybe NASA or big companies that are going towards the cloud computing platform, because when I started 8 or 9 years ago on this cloud computing platform, small to medium-sized enterprises, they preferred cloud computing domain because it was cheap in nature. It was cheaper option. But now the big corporations are going towards cloud computing. The very first advantage is that there's no upfront investment. You don't have to invest heavily into setting up your data centers. It is scalable in nature. You can get as much as you want, or you can shrink down the number of resources. So you can get a new server. It is just, you just do some few simple clicks and you get a complete server deployed. And it gives you very high availability solutions without any extra effort. So without even paying a single penny upfront, you start deploying the resources on the fly. Fine. So this is the advantage that you get over the on-premises. Now, these are different models that we have in cloud computing. Infrastructure as a service. For example, the networking components we use, it as a part of the infrastructure is given to you as a service. PaaS, platform as a service, which is used by developers to get a platform on the fly, like Elastic Beanstalk. Software as a service, which means that you get a software as you sign up for that software as an end user, like Google Drive or Google Docs. So it is software as a service. For example, today you subscribe to Ola app on your cell phone. It is software as a service. You sign up for Ola and you start using that software on the fly. It is a software as a service, right? All right, so these are some of the models you can just go through. I'll not go in detail because it's just a very basic thing. Now, there are multiple cloud providers in this market. It's a very tight competition nowadays. Amazon Web Services on the top right now. It's been top since 2006. It's still on the top. It's a leader in the industry, followed by Microsoft Azure, Google Cloud Platform. We have Salesforce, DigitalOcean, and so on. There's so many cloud providers in the market, but these are the top in the entire list. Now, the company can go with any one of these three. Now, people ask me this very common question: which one should I go for? So I give the answer. Today, you want to buy BMW or Mercedes or Audi. It's your preference. All these are luxurious brands. So what I'm saying is that all these three providers are one of the best in the industry. Whichever suits you the best, you go for that. But as now in the competition, AWS is leading ahead. Now, why it is leading ahead? Because it started it was the very first cloud service provider that started. Microsoft Azure started, I think 6 or 7 years after it was started, and then GCP started. So AWS got the first move advantage. So in the industry, whichever competitor starts the service the first gets an extra edge. Fine. Also, AWS is very innovative in releasing new versions of the services very frequently. Fine. So AWS is one of the biggest cloud service provider, followed by Microsoft Azure, and then we have the GCP, that stand for Google Cloud Platform. Fine. Now, what is AWS? AWS is the on-demand cloud computing services to businesses and individuals. It's on-demand. Now, what do you mean by on-demand? The thing is that there's no upfront commitment you have with any provider. You sign up and start using it. It's a subsidiary company of Amazon.com. We all know what is that. This is the biggest e-commerce platform on this planet, which also specializes the Amazon Web Services in providing the infrastructure as a service. Now you can use this platform to help the business scale and grow. And you can use different services like compute, content delivery, database storage, and other functionalities. Okay. So the thing is, AWS has rich of different on-demand services to provide, and there are different categories of services, like we have compute, networking, storage, database, analytics, machine learning, and so on, even the access management. So AWS has created different containers of services, that multiple services under compute, networking, storage, and databases. Fine. Now, the thing is, let's do one thing. Let's go back to the AWS. And I don't like going through the slides very often. Let's look on this page. See, the thing is that as a solutions architect in the future, you'll be using this page a lot, the most, to deploy, manage your infrastructure on the Amazon Web Services platform. Now, the thing is, if you go to all the services, you can see that these are different categories of services that you can access, and that's okay. You can leverage these services on the fly. But at the right-hand corner, you will see that it shows you the display name of the account. I'm just let me just change my account information. I can do it afterwards. So the thing is, if I go to my account, basically the thing is that this account that I'm using right now, this is a root account. right? This is a business account as right now. And I can, if I set the account name, I can put that, for example, let me just sign in real quick. Now you will see this is a root account. Now root account is the one that you sign up using a credit card or debit card. A root account is the account that you sign up using a payment information. So payment information is included at the time when you sign up. That's called the root user. Root user gives access to multiple IAM users. Fine. So root user is a parent, IAM user is a child. We'll discuss that afterwards. So whenever a company or an individual signs up with AWS using a payment method, whether it's a credit or debit card, that account becomes the root account. Okay. Now mine is a root account and it's a business account. It's not a free account that I'm using right now. It's a business account. And let me sign in real quick in front of you. All right. So I just signed in front of you, and I can change, for example, my account name. For example, I can just type in, for example, Intellipaat, something like that, and click on Save Changes. So the thing is that the account name is not that much important. The main thing that every root account has a unique account ID. So when, for example, you contact the support team at the backend. So you have AWS contact team behind the scenes. You want to open a ticket with them. They will recognize you using your account ID, because account names can be same, but the account ID is unique. Fine. Now the thing is, if I show you if I go to support and go to support center, I can see my account information over here, and also what are the support options that I have. So for example, in a business account, you also need to open tickets with AWS, just in case if you have some issues out there. Now you can see that I have a business plan because sometimes I use this account to deploy huge infrastructures. So this is my business account, and I can get some support from them. In a free account, the support is very limited in nature, but that's fine. You don't have to get support in a free account. So the thing is, you can see your account information, you can sign out from here, but the main thing I want to show you is this one. On the right-hand side, these are the regions. Can you see that? We have US East North Virginia, US East Ohio, West California, West Oregon, Africa, Cape Town, Hong Kong, Mumbai, Osaka, Seoul, Singapore, Sydney, Tokyo, Canada Central, Frankfurt, Ireland, London, Milan, Paris, Stockholm, Bahrain. So in South America, we also have a region. What are these? These are the point of presence. This is where AWS has its own infrastructure running. Fine. This is where the infrastructure, AWS owns its own data centers over there. Fine. See, the thing is that you might be seeing this web page, but at the back end, a huge infrastructure is running across the globe. And they have set up this infrastructure in the form of regions. Now, see, as of now, they have 24 launched regions. What is a region? It's a geographical location. It's a piece of land on the globe where AWS is running its data centers in the form of availability zones. Okay, I'll get into the technical information afterwards. But if you see the map, the blue dots represent the existing regions. For example, this is on the west coast of US. These regions are on the east coast in India. So the one that is India, Mumbai. So the one that is showing you as the blue dots, the blue circles are the existing. Orange ones are the upcoming, which are planned, which you will see soon, maybe in a few months or maybe in a year. So as of now, they have 24 geographic regions. So that they're planning to set up more in Australia, India, Indonesia, Israel, New Zealand, Spain, Switzerland, and UAE. So you will see that they'll expand to other regions. So the thing is, if you just go at the top right-hand corner, let me just go back one more time. Each region, so as a solutions architect, you have to understand that each region is a separate piece of infrastructure. For example, right now, the dashboard that I'm signed in is in Mumbai. You can see that the URL is different, AP South 1. If I change to, for example, let's go to Virginia, you will see the link will change. US East 1. But why? Well, let's go to Stockholm. You will see that at the top, the link will change. See, one thing that you have to understand is that each region is a separate entity. It's a separate entity. It is a separate set of infrastructure which is being managed as a whole. I would say that if anything that I deploy in the Stockholm will be completely isolated if I deploy anything in Singapore. If I deploy anything in Stockholm, the resources will be contained in Stockholm, and the resources that I deploy in Singapore will be contained in Singapore. Every region is unique. It is separate and isolated from other regions. Yes, there can be internal dialogue, or the data can be synced. The data can be copied over. That's absolutely possible. The thing you have to understand is that each region is a separate entity. Now let's do one thing. Let's go to Mumbai, and if you want to access Mumbai resources, you have to switch back and forth. Or maybe for example, I want to access Stockholm. I have to switch back and forth between different regions so that I can access the resources in that specific region. Fine. So each region is a separate infrastructure. It has a unique identity. And if you deploy anything in one region, then or different regions, then you have to switch back and forth between different pages to access the resources relevant to that region itself. Okay. Now, so what is a region? Again, I'm saying one more time, it's a piece of land on the globe. It's a geographical location. It is a particular location where Amazon Web Services is running its data centers or cluster of data centers in the form of availability zones. Fine. For example, right now, the region I am in is in Mumbai. Fine. So I go to so guys, I'll take all the questions at one single lot once I'm through with the concept. So let's go to the EC2. Now, EC2 is a service through which we can deploy some virtual machines. Fine. Let's go to the EC2. Let's do one thing. Let's understand exactly that how this functions, how exactly you can access the resources or data centers. So I go to EC2 dashboard. Why I'm going to EC2 dashboard is that, okay, let me just go back to Mumbai one more time. Okay, let's go to Stockholm. So let's suppose we are in Stockholm. I'm going to deploy my virtual machines in Stockholm, the instances. Now you will see that in Stockholm, these are the 3 availability zones. And they have been termed very differently. Now, how this functions? See, the thing is, let me do one thing. Let me just bring down my iPad screen. Just allow me a few seconds over here, and let me just try to explain the concepts using the whiteboard. Because what I find is that explain the concepts using whiteboard is a bit more easier. Fine. Let me discuss the concepts with you right now. So right now, the things that we are going to discuss is the AWS global infrastructure. So just in case if you have some visibility issues, if not able to view the screen, just let me know. So the thing is, right now, we're going to discuss the AWS in the global infrastructure. Let's imagine one thing. So this is what we're going to discuss right now. This is the global infrastructure. Now, let's imagine that this circle that I've just created in front of you, this circle, yeah, this circle represents Stockholm region. So for example, this is Stockholm. So this is the region of Stockholm. So I'm saying, okay, this is my region of Stockholm. Now, the thing is that AWS has denoted a special name to each region. For example, Stockholm is represented as EU North 1. Let me see that. Yeah. So they say that EU North 1 is our Stockholm region. This is what we have, EU North 1. This is the region of Stockholm. This is the region of Stockholm. Now, in this region of Stockholm, which is represented by a special term EU North 1, we have 3 availability zones. So what are these availability zones? These are the data centers. Fine. So these are 3 availability zones that we have. Fine. So let's label them as, for example, so this is, for example, this is EU North 1A, EU North 1B, EU North 1C. So what are these? These are your availability zones. So what are the availability zones? These are the data centers or a cluster of data centers. In the short form, we label them as AZs. Fine. Now, these are the 3 availability zones in the region of Stockholm. So if you go back to this thing, EU North 1A, which is this one, the top one, EU North 1B, and EU North 1C. So EU North 1 is the region. So EU North 1A, EU North 1B, and EU North 1C are the 3 availability zones. And these availability zones are connected together with high-speed fiber optic cables so that you can synchronize your application and your workloads across these different availability zones located in the confinement of a region. So Stockholm is represented by EU North 1. So EU North 1A, EU North 1B, EU North 1C are the 3 different availability zones located in the region of Stockholm. Fine. So what is availability zone? It's a data center. Basically, we call one AZ as a one data center, but sometimes an availability zone can consist of multiple data centers. But generally, we assume that a single availability zone represents a single data center. Now, each region will have at least 2 different data centers for the redundancy purposes. For example, I'm just giving you one example. What if this availability zone goes down? You can use this one. What if this goes down? You can use this one. What if this goes down? In that case, you can also use a different region. As an architect, you have to understand that what are the processes and strategies you can incorporate, or you can use those processes and strategies to make your application more redundant, highly available, so that if a data center goes down, I would say availability zone goes down, or the entire region goes down, then how you can make sure that there's a continuity of your application. Your application never goes down. It's up and running. Maybe it is served from one region or a different region. Fine. So this is how an infrastructure looks like. Okay, let's take 2 more examples so that we can have better clarity of this concept. Let's take another example. Let me just go back let's go to Mumbai. Now, Mumbai is in Asia Pacific. It's in India region. Now, Mumbai is denoted by, if you see at the top right corner, it is denoted by the AP South 1. AP South 1 is the Mumbai region, which consists of 3 availability zones: AP South 1A, AP South 1B, and AP South 1C. So AP South 1A, 1B, 1C are located in which region? AP South 1, which is the Mumbai region. Let's take one more example. Let's go to, for example, Virginia. Now, Virginia is the very first region they started with. This is the oldest and the first region. And if you see Virginia, it is denoted by US East 1. And if you start looking into its availability zones, it's US East 1A, 1B, 1C, D, E, F. Fine. So that's how you can choose from the region and the availability zones from the list. So what is an availability zone? See, availability zone, one availability zone, generally we assume as a one data center. So this is the first availability zone, second availability zone, third availability zone, fourth availability zone, fifth and sixth. Sometimes one availability zone can also have 1 or 2 different data centers. But just for the ease of understanding, we assume that an availability zone is a single in-house facility. It's a data center which consists of a rack of servers, and each region consists of at least 2 different data centers or availability zones to give you high amount of redundancy and availability, so that if few of them they are they go down for any reason. See, the thing is that the natural disaster is not in the hands of a human being, whether it's a calamity, it's a heavy rainfalls, fires, and floods. So if one data center goes down or two data centers go down, at least you can leverage your data and services from other data centers. There's an average distance of 60 kilometers between different data centers. Between two data centers, there's an average distance of 50 to 60 kilometers between two different availability zones or data centers on an average. Fine. So that's how you can leverage the regions and availability zones on this page. Fine. Now, again, I'm saying you have to treat each region as a separate infrastructure. If you deploy anything in North Virginia, it will not show up in Hong Kong. If you deploy anything in Hong Kong, it will not show up in Canada. Fine. Each region is a separate infrastructure. You have to switch back and forth between different pages to access the services and resources in that specific region of your choice. And you deploy your databases, your web applications in different availability zones. Fine. Or data centers. You pick the data center. You have the option to pick the data center of your choice, the availability zone of your choice, and you can start deploying your applications on the fly in that specific availability zone or the data center. Fine. Now, these are the two main pieces of the infrastructure. We have multiple pieces which are optional. For example, if you go to the infrastructure, you also have local zones. Now, what are the local zones? Local zone is a fair new concept, still not being used too much. Basically, local zone is nothing but it's the extension of a region. For example, if I just go to Virginia, let me just go back to Virginia. It's not available anywhere. I can click on enable additional zones. And these are the local zones for Virginia. Local zones means that I can scatter my resources, for example, in Boston, Chicago, Dallas, Houston, Kansas City 2, Miami, Minneapolis, Philadelphia, right? So this is the extension of the region. For example, today you want to deploy your resources in North Virginia, but your main user base is in Chicago. You will say, okay, let me deploy my services in Chicago, because for example, you want to deploy an in-house customer management service application, a CMS application. Your office base is in Chicago. So you're saying, okay, let me pick Chicago, because if I deploy the services in Chicago, then the people who sit in Chicago will be able to access the services much faster, because the data center is in Chicago. The data centers are in Chicago. So in that case, I can deploy my services in Chicago. Maybe you have your in-house application to be deployed for people in Boston. You can use Boston as a local zone and start deploying the services. Local zone, as I said before, it's a fair new concept, still not used that much because it's not available in every region. But it's the extension of the region so that you can scatter your resources in different parts of that specific geographical location. Fine. So don't put too much stress upon that. It's a fair new concept. The main thing that you have to understand is the region and the availability zone. Wavelength zones are used for 5G applications, 5G compatible applications. You will not use that. Fine. We also have edge locations that we'll discuss afterwards. But the main thing that you have to focus on is the regions and availability zones. Fine. Now, one thing that you have to keep in mind is that not every service is available in every region. Fine. Most of the services are available, and also the pricing is different. The things, for example, today I deploy, I consume 1 GB of data, or for example, I deploy a web server in Virginia. The cost per hour will be different compared to the server that I deploy in Singapore. The web server that I deploy in Singapore will be different from the one that I deploy in Paris or Stockholm. Now, why the cost is different? Because the cost of infrastructure is different in different parts of the globe. The cost of the electricity, labor, because they have to lease out the entire space. So electricity, labor, backup. So the cost of infrastructure is different in different regions. So in that case, you have to pay different prices for the same resource based on the region that you have chosen. For example, Singapore is a costly region from what I understand, because Singapore, it is one of the costliest of the based on geographical location. The cost of the land is very high. Even the labor is very high. Like London is very costly. The thing is that the cost of land, infrastructure, labor, electricity. So the cost of the infrastructure, the input that AWS is putting in as a monetary input. So based on that, the cost of the region would be higher for some region. For some region, it would be moderate. For some region, it would be lesser. But that would be very minimal if you see if you go by a single resource. But yes, so this thing you have to understand, the cost of the infrastructure will change based on the region of your choice. So once you start deploying your entire infrastructure as an architect, you have to pick that which region is under your budget.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Because, for example, we want to deploy 1,000 servers in London. And if you deploy the same 1,000 servers in Mumbai, Mumbai will be cheaper as compared to London. I'm just giving you one example. Fine. So the cost of infrastructure will change based on the region that you have chosen and you have deployed your resources into. It will make a huge difference in that case. Fine. That's about the regions and the availability zones. All right. Yeah, that's it. It all depends upon company to company. Or what they can say is that they can pick the cheaper. They can go with weighted routing. They can say, okay, 50% of the traffic is sent to Singapore, 50% of the traffic is sent to Mumbai. So they can scatter the resources half between a costly region and the cheaper region. They load balance the traffic. So they will say 70% of the traffic will be sent to cheaper region, 20% will be sent, 30% will be sent to the costly region. So there can be different strategies out there based on each choice, preference, and priority. Kaushik is asking, one service available in zone A, is it available in zone B? Yes. I'm talking about the data center. See, the services are available based on the regions, not the availability zones. So in every availability zone, so if you go with the region, if you have 3 availability zones, all the services are available in all the zones. Local zone will have high priority for that region compared to other zones. Let's not, okay, whenever you go with the local region, whenever you go with the local zones, for example, let me just go back to this AWS page. Let me just go back to the EC2 page real quick so that we can discuss that concept. See, the thing is that it's not about the fight between availability zones and local zones. Don't confuse these two things. One thing that you have to understand, a local zone is the extension of the region. Fine. Data availability zone is the part of the region. Local zone is the extension of the region. It's not about the priority or what's the importance that been given to us. It's all about the requirement. Fine. See, the thing is, if I deploy my services in North Virginia region, then my as per the geographical location, these 6 data centers are in North Virginia. If I go with geographical location and I choose all the 6 availability zones in North Virginia, then my services will be restricted in that specific geographical space. What if I want to go further and deploy the services in Boston, maybe in Chicago, maybe in Houston? Fine. So I want to scale out. I want to outreach to other location. So there's no competition between that or priority that availability zone will get more preference or which local zone will get the preference. It all depends upon it how you have architected your application. Fine. So if you architect your application to be deployed in North Virginia, it will use any of the 6 availability zones. If you architect your applications to be deployed in Miami, it will use the data center or data centers in Miami. So a local zone is nothing but it's the extension of the region. Karthik is asking, redundancy for regions or only for AZ? you can achieve you can make the things redundant across AZs, across regions. All but local will be a bit faster compared to other location. Geographical space, for example, fine. And you have 250 users in Minneapolis, and you want to make sure that they can get a faster access to your application and services. For example, you want to deploy a customer management software for 250 employees in Minneapolis. Now, you specifically choose this local zone so that the people in Minneapolis can get a faster access to your application, your customer management software that you have deployed in this region. Yeah, of course, it will be faster. That's why we have used that. It has done it. See, the thing is that even though you're using one of the best infrastructures out there, things will go down. Fine. For example, I was using Frankfurt 2 weeks back. It was down for some reason. So things can go down, and it is inevitable. It is inevitable. For example, I can tell you the example of Mumbai. In Mumbai, we have so many heavy rainfalls, right? And there are floods coming in. Even today in Delhi, there was I was coming back from in North India. There was so much of rain, there were floods out there. So the natural calamity is not in the hands of a human being. So even if you have the best infrastructure out there, the things will go down. So I've seen availability zone going down many times in my career with it on AWS, or I've seen the entire region going down. I think 2 years back, the entire AWS went down. So the thing is that availability zone will go down, and that's why we are here. We have to architect the application in such a way that if the availability zone goes down for any reason, it will go down because it is inevitable. It can be a technical glitch, it can be a human error, it can be a natural calamity, anything. So yes, I've seen that it has gone down many times. It will go down for you as well. So as an architect, you have to cleverly plan the infrastructure so that if something goes down, you have the backup plan. If I give you the brief overview of this question, basically what we do is that we, as a basic plan, we go with horizontal scaling. So we have multiple instances, multiple virtual machines running the same application. For example, I deploy 10 virtual machines with the same application running upon them, and I bind them with a single domain. I scatter those 10 different application servers across 2 different availability zones, or maybe I scatter them across 2 different regions. Now for that, we have to use some services like auto scaling, elastic beanstalk, load balancer, Route 53, global accelerator, right? So the answer is that we have to use some services and some tools, some strategies and processes to make it happen. And that's why we are here, to understand that concept. Can we create a virtual data center for backup? See, these are the virtual data centers only. They're already there. You can't create anything special over here. See, these are the virtual data centers only, right? There's nothing new you can create. You can use the one that already exists. Okay, fine. So what is this identity and access management all about? Let's discuss this concept. See, in your organization where you work right now, maybe in ISRO, maybe in NASA, Accenture, Wipro, HCL, wherever you're working right now, you have an identity over there. As an employee of that organization, you are given an ID card. You have a job profile. You have the roles and responsibilities being linked to you. And based on your job profile, you are being given some types of access. Fine. So similarly in AWS, when you start working for any company and start leveraging their services on AWS, for example, you work for Wipro. Wipro has its infrastructure or its client infrastructure on AWS. So use their account to manage infrastructure. Now you as an employee, for example, so you're from IT, you are from IT team or software team or testing team. So you're from IT software background. You as a professional from IT software background, you'll be working with Wipro or its client to deploy and manage their infrastructure on AWS. Now these companies will create IAM accounts. They will create some accounts for you, and based on your identity, whether you're a developer, a testing professional, a system administrator, a database administrator, whosoever you are, you'll get some access. And that's what is called the identity and access management. You're given an identity based upon which you're giving some access. And the management of these two things is called the identity and access management. So IAM is a web service that helps you to securely control access to the resources. So the identity and access management is kind of a web service that will help you to get access to the resources. Use IAM to control who is authenticated, which means that who is signed in and what type of permissions you get. So for example, you are a developer and you develop and deploy the applications on AWS platform. For example, you develop Node.js applications and you deploy it on AWS. Now you as a developer, you are authenticated. So I'm saying I'm a Wipro owner or a CEO or I would say the manager of a business unit. I say, you are my developer. I give you the authentication to sign into my account. And you are given some rights. You'll be given access to some developer tools. For example, code commit, code deploy, code pipeline, code build, Elastic Beanstalk, CloudFormation. These are some of the developer tools that are used on AWS. You use Wipro's account. You sign in using your own ID and password. And then based on your job profile, your roles and responsibilities, and also business unit and team you're in right now, you'll be given some access to some services. Fine. So we control using IAM that who signs in and what type of access he or she gets. Okay. So whether you're an administrator, a web developer, a data scientist, based on your job profile, your team, your business unit, you get access to a few different services and resources. Okay. We'll discuss these Amazon resource name afterwards, but let's discuss I'll discuss the components first. So this, for example, this is the root account owned by Intellipaat. Intellipaat wants to deploy its LMS, the LMS you're accessing, right? Intellipaat will have its software developers, its testing professionals, system administrators, who will help Intellipaat to deploy its LMS and manage it on AWS. Now, Intellipaat will say, okay, let me hire developers and I create the user ID and password so that these people can access my account. It's like I have a house, I lock that house and I create duplicate keys for that and I distribute to you. So Intellipaat saying, okay, it's my infrastructure, it's locked. So I'll give you different keys to different people so that you can barge in and use my account. So I will create different accounts, I'll create accounts for different people in my IT and software team so that they can help Intellipaat deploy and manage its learning management system on this cloud platform. Okay, so how to use our services? You just go to all services under the management and governance, or I would say under security, identity, and compliance, you can see IAM. Else, because there's so many services out there, you can click on, just go to search for services, just type in IAM, and it will easily populate that specific service for you. I go to IAM, and this will just land me to the IAM page. This will land me to the IAM dashboard. Now, for the IAM, you don't have to switch between different regions because this is a global service, which means that if you create any user, then he can use the services in any of the regions. So IAM does not need for you to select the regions. Now, let me do one thing. Let me just remove the previous configuration because it will confuse right now. So this was created a few days back for one of my batches. Okay, so this is the digit. Let me delete the rules. So you will see that this thing, this is deleted. Now, the thing is, this is called the IAM dashboard. As of now, this is completely blank. This is the dashboard. I don't have any users, groups, roles. I have some roles and policy. We'll discuss that afterwards. But the main thing that you will see that I don't have any user. Now, who is this user? A user is any person in my IT and software team. It can be a solutions architect. It can be a developer. He can be a DevOps professional. He can be SysOps administrator. It can be database administrator. It can be a Linux professional. Any person in my software and IT team who will be logging into my account through his credentials and performing day-to-day operations, whether it's deployment, implementation, provisioning, management, testing, modifying the resources, and so on. Okay, so let's go to the users right now, and let me just start creating some users on the fly. Now, what's an IAM user? You can see that the definition, it is an identity with long-term credentials that is used to interact with AWS in an account. It's the identity. It's a user. It's an actual user. Okay, so what we need to do is that we need to click on Add Users at the top right-hand corner, and this will automatically just open the username stuff in this case. Now, the thing is, I can start adding the usernames. Fine. So now different companies, they go with different formats. For example, some companies go with the initial of the first name. For example, my name is Rohan and last name Arora, R Arora, or Steve Jobs, S Jobs.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Something like that. Or just for the simplicity, I'll just type in for example, the first name, right? So the first name is a username for the people to log in. Kavita, Suresh, type in Steve, type in, for example, Chris. So these are the actual people, the first name of the people who will be logging into the account to perform day-to-day operations. And that's it. So as of now, I have 6 different users that I've created: Kavita, Suresh, Steve, Chris, Mahesh, Kunal. I can add multiple users on the fly, but that's fine. I think 6 users are more than sufficient for us to test and try the things out. Now, the thing is that you will see that it says select the AWS access type. See, there are 2 types of access you can give to the people. One is access to the AWS Management Console, which means that they will be signing in to the AWS account, to my account, but using their own credentials. I will check it out. The second one is the access key. Now, this gives the programmatic access, which means that if I check this option, I will show you these people will get a key pair. They will get access key and secret access key so that they can programmatically access my account using an API, CLI, SDK, or any third-party tool. Yeah, I can integrate a third-party tool with AWS, but these people can authenticate using access key and secret access key. I'll show you that later on. Don't put too much stress on this information. And so I choose the type of access these people should have. Now, should I go with the auto-generated password or a custom password? Let me choose a custom password, and I will check. Okay, one second over here. I'll define the custom password over here. Now it says required password reset, which means that this is the common password for all the people. Now you must, so users, this is checked by default. So once these people sign in using the custom password that you set, they get the option to change it on the go. I'll just uncheck it for simplicity. Now, so just to recapitulate that what I've just mentioned on this page, 6 users: Kavita, Suresh, Steve, Chris, Mahesh, Kunal. 2 types of access: programmatic access, so that these people can integrate, they can access AWS account using a third-party software, CLI, command interface, or any external tool. And also they get the password to access my AWS management page. I set the custom password. And now the next important thing that I have to do is that I have to assign them permissions, because what I'm doing right now on this page, I'm creating the identities for them. Kavita is one, maybe she's a developer. Suresh and Steve are my database administrators. Chris is my Linux administrator. Mahesh and Kunal are my solutions architect. But as of now, I have created some identities for them. Okay, so username and passwords. Next comes the permissions. Now, permissions I'll assign afterwards, but let me show you. If I just go to the very last option, attach existing policies directly, basically we assign the permissions using the JSON policies. JSON stands for JavaScript Object Notation. I will not attach any policy. I will show you how that policy looks like. I simply click on next add tags. Now tag is just you assign a kind of a tag to it. It's optional. Click on next review. Now the thing is that right now, this is the review. I can review my choices. Of course, I can manipulate these things afterwards. 6 users created with 2 types of access, a custom password set for them, but these users have no permissions as of now, right? Which means that these users can log in, but they won't be able to perform anything. That's okay. We can add the permissions later on. I simply click on create users, and voila, my 6 users are being manufactured. And these are the secret access keys and access key for each of the users so that they can programmatically access AWS account using CLI, API, or other development tools. I'll show you that. I can send email. It will open email client on my Mac, and I can send them the login instructions. Now, one thing that you have to keep in mind is that you could click on download CSV. If you download a small CSV file with all this data encapsulated, because once you hit close, then the secret access key of these users will not show up later on. Okay. Again, I'm saying you download a small CSV file. Let me show you that CSV file, how it looks like. Now, CSV file takes longer time on Macintosh to open up, right? So in the meantime, what I'm saying is that download the CSV file for the future reference, because once I exit from this window, then the secret access key of these users will not be visible to me, but I can rejoin it if needed. So this is what it shows up. I can see the access key and the secret access key of these people. I can regenerate this thing, but thing is that if I exit, then the secret access key will not be visible on this page again. But that's fine. I hit close, and here we have 6 different users being manufactured. Now the thing is that these are 6 users. I've created the user ID and password for them. Let's do one thing. Let's pick Chris as an example, and let me just log in on behalf of Chris. Now, one thing I want to again emphasize: the account that I'm creating is not a special account. It is just that I've given identities to these people so that they can log into my account only. They will log into my account, but using their own credentials. Okay, so let's log on behalf of Chris. Now, this begs this question: how Chris will log in? The answer is that if I just go to the dashboard, on the right hand side, you can see that it says sign in URL for the IAM users. This URL, this link will be used by the IAM users to sign in. They can. There's also another method out there, but generally this link will be used. I can customize this link. I can just click on create account alias. Now this is my root account ID. I click on account create. I can create an account alias for my root account. For example, Intellipaat AWS. Yeah, that's it. Now, the thing is that no 2 accounts can have the same account IDs, the same alias ID. If this is acceptable, click on Save Changes. Okay, it already exists. It says this account alias already exists. So some person might have taken this before. So let me make it as, for example, okay, let's increase the font size. Intellipaat AWS demo v2. Let me just give a random name. Click on Save Changes, and this is created. Now, can you see that this has changed the display format of the link? Okay, I can copy this link and use some other browser, because right now I'm using Safari. So let me just open Chrome browser so that I can use Chrome to sign in. So let me just open Chrome and just paste this link. Now, I will try to sign in on behalf of Chris. So immediately it picks the account ID or the account alias. So I've set the account alias. I'll define the username. Just type the username and type in the custom password that I've set in. Now you will see that Chris is able to sign in without any trouble, without any issues. And he is able to sign in. And if you see the format at the top right-hand corner, Chris, the user ID @ account ID or the account alias shows up. Chris @ account ID or the account alias shows up. That's how you can differentiate between the root account. This is my root account. This one. Root account is a simple name with no @ symbol, unless you deliberately put that in this thing. But this is the root account. From this root account, I've generated this IAM account. Now, Chris is using my account only, but what he's doing is that he's using his own credentials to access the root account of Intellipaat. It's not a separate account. It is just that I've built a home, and I'm saying, Chris, here's the key, duplicate key of, and you can just come in whenever you want. Now, even though Chris is able to sign in, he will not be able to perform. He will not be able to perform any operation whatsoever. Why? Because I haven't assigned any permission for him. For example, if you just go to any of these predefined services over here, let's go to the EC2 right now. And for example, Chris says, okay, let me just try to deploy one instance. You will see that immediately he gets an API error because he has no access whatsoever. Okay, if you try to access any random service on the fly, for example, he wants to go to S3 storage, he'll be kicked out because as a root owner of Intellipaat, I haven't given him any access. It says you don't have any permissions to list the buckets. So he'll be kicked out from the services because even though I have given him the user ID and password to get in, but he'll not be able to perform any action because there's no policy, no permission added to him. I've given him the identity, but I haven't given him the access. Simple. He has the identity, but he has no access. Okay, so how can you give the access? Having said that, I go back to the root account, go back to the users, and I pick Chris. I'm saying, Chris, let me just assign you some permissions. Now I go to Chris. In the summary, this is the Chris account that I'm working on right now. I have permissions tab. It says get started with the permissions. This user, Chris, doesn't have any permissions yet. I click on add permissions. Now there are three options out there. The first one is the most effective method. We'll discuss that later on. You can copy the permissions from the existing user, but right now we'll attach the policy permission. So the policy is added in terms of permission. I'm sorry, the permission is added in the form of policy. What is a policy? These are more than 700 policies you can start using on the fly. These are default policies. The one that you can see AWS managed, these are default policies. These policies define permissions, right? Each policy will give certain type of permission to certain set of services. Now, the administrator access gives you the highest level of access. What is AWS administrator access? It provides a full access to the services and resources. Now, even in your organization, you have seen that if you get some admin access, you get the full access. On your computers, if you get the admin access, you can install any software and service. Fine. Now, the administrator access, if I link this policy with Chris account, I say, Chris, I want to add on the permission to you. I give you the administrator access, then Chris will be able to access any service on the go. He will get the full access. So now the thing is that I can see the policy summary. He gets full access to all the resources in the list, all the resources. But if I show you the JSON version of it, now JSON stands for JavaScript Object Notation. Basically, these policies are formulated in JSON. Now, if you pay close attention to this JSON policy, it may look complicated, but I just try to just make it simple for you. This is the version of this policy. Then this is the statement. A statement defines a single permission. A statement is okay. Let me do one thing, which is open the iPad screen. So right now, what we're discussing is the IAM. So over here, let's understand this thing. What is a statement, by the way? A statement is equal to a permission. So if I say statement, a statement is equal to a permission. Fine. One statement defines one permission. Fine. So one statement defines one permission. Now over here, you have to understand this thing, that in the statement, there are two types of effects. Fine. One is allow and the other one is deny. One is allow and the other one is deny. So there are two types of effects in a statement. Either you allow something or you deny something. Fine. Now in this policy, if you see something like asterisk, if you see a star on asterisk, it denotes everything or anything or all. Fine. So asterisk means if you see asterisk in a policy. So what I'm talking about is this is a part of an IAM policy. So a statement is a permission. Effects, there are two effects. Either you allow something, you deny something. Asterisk, if you see anywhere, it is everything, anything, or all. Fine. Now the thing is, if I go back to the AWS page, what is effect? Allow. Either you allow something or you deny something. So what is effect? Either you allow something or deny something. Action, every action, any action. Read, write, change, delete, modify. Resource means service, any service. So resource means, if I say resource, I'm talking about every single resource over here, every single service. So I'm saying, if I go with this policy, action, any action, every action, all actions, read, write, change, delete, modify, anything. Resource, every resource.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So I'm saying that if I allow this administrator access or I allocate this type of access to Chris, he gets every he can perform any action, read, write, change, delete, modify any action to any of these resources. It gives the highest access. Okay, so it is quite obvious you will not give the administrator access to every person. Maybe a team lead, maybe a manager, maybe a owner of the business unit will get the business administrator access. Okay, so if I grant the administrator access policy to Chris based on the JSON policy, I can see I allow him to perform any action to any resource, or all the actions to all the resources. We'll discuss a few more examples over here. So having said that, I click on Next Review. So I can say, okay, I want to review what I'm doing right now. 1 second over here. Now the thing is that this policy is attached to Chris username. Click on Add Permissions, and now Chris is added on. So this policy, the administrator access, I've shown in the JSON format of it, is attached to Chris account. Having said that, I go back to Chrome browser. Right now, this is where we signed in to the Chris account. If I now, you can see that he was not able to perform or list the buckets in S3. If I just make a refresh, you will see now the things were visible to him. Now able to see the buckets in my list. Previously, he was unable to access EC2 as a service. Now, previously he was getting an API error. Now he will not get that. He can delete the things, he can change the things, he can deploy the things, because I've rendered him the full access. So that's about the Chris username and his credentials. Now, the prototype that I've shown you is not the most healthy way of access management. Why? Why it is not a healthy way? Because let's imagine in Intellipaat, to start with, let's imagine that in Intellipaat root account, or in Intellipaat's IT and software team, there are only 6 users in the IT and software department. What if Intellipaat grows further and it has to recruit more developers and system status, maybe up to 200 or 500, let's suppose. So I grow from 6 users to 500. Now, if I start assigning permissions to every person or manage the permissions for 500 people, I'll go insane, because the thing is that managing permissions for so many users, it is a big headache. I want to go with a neat and clean method to ensure that the access management is done properly. It is process oriented. Now, you guys might have heard about this thing in your own organization. We have Microsoft Active Directory groups. The same concept applies over here. We group the people together based upon their roles or responsibilities, their job profiles, or maybe their teams or business units. And then we assign the permissions to the groups and then add the users to them. I think, let me just discuss with you one example. Okay. Now, for example, what is a group? It's a logical collection of multiple IAM users. It's a logical collection of multiple identity access management users. For example, I create 3 groups: admins, developers, and operations. Now what I do is that in the orange rectangle, the orange rectangular things you can see on the slide, these are the groups. I create 3 groups. Left one in the orange is admin. In the middle, it's a developer. And the third one is the operations. 3 groups. Now in the blue, you can see these are the users. For example, in the admin, I have admin 1, admin 2, admin 3. So we can have names: Chris, Kavita, Suresh. Now what I do is that instead of adding the permissions for individual admins, I simply add the permission to admin group to the orange block. And then all the admins underneath will get the same permissions. Let me give you one more example. I have a group called developer. Under developer, I have 5 developers. Under developer group, I've grouped 5 developers: dev 1, dev 2, dev 3, dev 4, dev 5. So these can be names: Steve, Chris, Kunal, Rohan, Davik, Mishu, whatever the names are. Now, I group them in the form of a developer group. I assign the permission or the policies to the group itself. And if any policy or permission assigned to the group will be applied to all the underneath developers. Same scope with operations. So I assign some permissions to the operations group. All the ops guy will get ops 1, ops 2, ops 3 will get the same permissions. Right? This is the most process-oriented, neat and clean method of access management. The one that I showed you before, it is a very bad example. But what I showed you, because I want to start with a simple thing. In a big business unit, in a big business environment, that's the best move that you can take. You ensure that you group the people together based on their roles and responsibilities, and you start with the permissions management. Let me show you an example. Let me do one thing. Let's do one thing. I create user groups. You can see on the top, a user group is a collection of IAM users. Groups specify the permissions for a collection of users. So group the people together based on the job profile, business units, teams, and then you assign the permissions to them. Now I click on create group at the top right hand corner, and the very first thing is that it says enter a meaningful name to identify the group. Any meaningful name. I just type in, for example, developers. Fine. Okay. Then it will ask you, okay, this is a group, developers, add the people in this group. I'd say, let me add Kavita, Kunal in the group. Fine. So group name, developers. I group these 2 people with initial K, Kavita and Kunal. Now it will ask you, okay, then what policies you want to assign to them. Now I can attach up to 10 policies. Now it automatically, because I've typed in developers, it automatically shows me some of the services that these people can use. But the thing is that I'll attach the policies, permission policies. So for example, I search for code commit. Now, this is a service that these developers will be using. A code commit is a service which is used as a repository, as a Git repository. So I choose code commit. Okay. What about CodePipeline? Okay, so CodePipeline, I choose CodePipeline. CodePipeline, approve access, read-only access. Let me choose full access. CodePipeline full access. Okay. Then what's the next service that we need to select? Let's choose Lambda. So I'm just giving you one example. So for example, I want to give them, do we have Lambda full access? I think we'll have that. Lambda full access. Okay, I'll choose Lambda read-only access. Let's choose that. Let me choose code build, code or code deploy. Code deploy full access. Let me choose ECS, Elastic Container Service, or just type in container. So Elastic Container Service full access, container distributed full access, fine. So I've attached multiple policies. I've attached 5 policies as of now, and click on create group. Now it creates a group called developers. This group has 2 people, Kunal and Kavita. And what are the permissions? Based on these 5 policies attached to the group. What's a group? Developers. What's the permission add to the group? Code commit full access, container registry full access, code deploy full access, code pipeline. You don't have to learn these services. I'm just giving one example. These are developer tools. Lambda read-only access. Now, based on the access permissions I've assigned to developers, these users will get the same permissions. I can add more users. I can say add user. Okay, let me add Mahesh, add the user. So I've added Mahesh under this list. So Mahesh is a user just added on to the group called developers, and he will get the same permissions because these are the policies that are linked with this group. Fine. So that's how you do that. Basically, this is the most process-oriented and neat and clean method of access management. In a business environment, you go with the process. That's how you go about doing that. Now, also, there will be less chances of you doing some errors, because if you have 500 users to manage, and if you manage the permissions of 500 different people, then you'll make some errors or some mistakes. So to bring down those mistakes. Okay, that's how you do that. So the group permissions or adding the groups is one of the most effective way of permission management. Fine. Let me take one more example of groups. So I just go to user groups and I create a second group, I'm sorry. So second group is for my new hires or graduate trainees. So these are my people who I've just recruited afresh in the organization. And these people will be, I just want to give them the read-only access, because they're just doing some hands-on, just learning the process. So I just want to give them the read-only access. So for example, I choose Steve and Suresh. Yeah, Steve and Suresh as a part of my graduate trainees group. And I search for view only. I think it is a policy over here. If I can search for that. Okay, let me see that. View only access. Now, view only access is a policy that, if you see the view only access policy, it gives the read only access to all the services. So Steve and Suresh are just going through some training programs, learning the skills, they're building up the skills. So I don't want them to mess up with my infrastructure. So they should get only the read only access. So I'm saying Steve and Suresh, view only access. Okay, create group. Now these people, so the group is graduate trainees, and who are the 2 people being added to this group? Steve and Suresh. Let me hit refresh. Steve and Suresh are there. The permissions, view only access. So if they try to deploy something, they will be kicked out. right? So let me do one thing. Let me just log in on behalf of Suresh. So I sign out from the previous Chris account. Let me sign out from Chris, and let me log in on behalf of Steve. So let me just go back to the dashboard and choose the link that I've set in. Go back. I think this is Chrome. Yeah. So I paste the link one more time, and I just log in on behalf of Steve real quick and put his password. Now the thing is, once Steve is able to is trying to sign in, he just, because you can see that Steve has signed in. This is the Steve's account, because he is get a view only access. If he tries to, for example, launch a virtual server, for example, he goes to EC2 and he tries to launch a virtual machine. So for example, he clicks, so he can read the things, he can view the things, but if he tries to launch the things or deploy the things or delete the things, he will be kicked out. For example, he tries to launch a virtual machine real quick. I'm not going through the process because I just want to show you. He'll be, say, launch failed. You are not authorized to perform this operation. You are being kicked out because you don't have the deployment access. You just view the things. You cannot change the things. You cannot create the things. So it is a powerful tool to ensure that a group of users have certain common permissions. Fine. So this is the best strategy for the access management or the permissions management, that instead of adding the permissions to the group directly, you add on to the group and all the people in that group will get the same permissions. Fine. That's about the this thing. The next thing that I'm going to discuss with you is the policy. Now, the thing is, if I show you right now, let's go to the policies one more time. Most of these policies that you can see, these are the AWS managed. When you start afresh, you will see that it is the AWS managed policy. AWS managed is the one that is default. That's there by default. Okay, we haven't discussed the S3 as of now, but what is it? See, the thing is, for example, I go to the services right now and open S3. What is S3? S3 is a service, is a storage service, and basically you store your data in the buckets. These are buckets, right? In this buckets, these are containers in which I store the data, right? Now, in any account, I can have up to 100 buckets. As of now, I have 33 buckets. I have 33 buckets right now. Each bucket can contain some data or unlimited quantities of data. So if I show you, for example, this bucket, let me just pick this bucket. This bucket will have some data. I can put in a lot of data into the bucket. We'll discuss buckets later on. But the things I want to convey is that if you go with the permissions, for example, I want a group of people to just have the read-only access to one bucket out of 30. These are 33 buckets. Out of these 33 buckets, I just want to have my users, a group of users, to only have the read-only access to only one bucket. Okay. So I have 33 buckets right now, but a certain group of users should have read-only access to only one bucket out of 33. Okay, so now you may say that, okay, you can do that using the policy. Yes, I can do that. But the challenge is, pay attention. The challenge is, if I go with the default AWS managed policies, let me show you. If I go with the default policies, for example, let's type in S3 read only access. This is the default policy, S3 read only access. If I assign this policy to any user, then this will give the read only access to all the buckets. Okay. Now, what are the read only access? Get, list. These are the read only policies we use, but we'll discuss that. But so the main thing is that if I go with this policy, it will give read-only access to all the buckets. Now, this is not suitable in my case because I have 33 buckets right now, out of which I want to grant the permission to only this first bucket, not all the buckets. I want to give the read-only access to only one bucket out of 33. So the problem with this custom policy is that it doesn't suit my need. It will give the read-only access to all the buckets. But in my case, I just want to give the read-only access to only one bucket. Okay. So what's the solution? The solution is that I shall be creating a custom policy. It's called a customer managed, which I can customize based on your need. For example, let's imagine you go to a restaurant. You order some chicken curry, right? Now the restaurant will have a certain menu. They have the certain recipe and they will serve you that dish based on how they prepare it. But if you prepare the same meal at your home, you can customize. You can put the spices, you can put the salt, ingredients based on your taste and preference. The same thing over here. It's a bad example, but same thing. Instead of going with the AWS default policy, we're saying, let's customize it. Let's create our own policy. Now, the example that I'm giving to you, that example is that I want to create a policy that will give the read-only access to only one bucket to my user out of all 33. So only this bucket would be accessed, not all the buckets. So I'm showing you the example. It's a bit complicated. That's absolutely fine. Just see the process. Just understand that what step I'm doing and why I'm doing that. Right? In 5 days ahead of you, you can practice on your own. Just see that exactly what's the process that we need to follow along. So I go back to the IAM page, okay, and just at the top right-hand corner, I click on Create Policy. Now the thing is that you have this visual editor, a wonderful tool to create a JSON policy by yourself. So I'll show you that how you generate a new custom policy. The very first thing it will ask you, can you please choose a service? For which service you're creating this policy? So service I'm choosing is S3. Okay, fine. Now, what actions you want to allow in this policy? Basically, the thing is that list and read are the two actions that we choose. It also has certain sub actions. List means, for example, if I go to the bucket, I can see the list of buckets. I can see the list of buckets. If I go to the bucket, I can see the list of data. This data is called objects. Fine. I can see the list of data or files over there. List and read are the two read actions that pertain to the buckets. So these are the read actions: listing the items and reading the items. Okay. Tagging, writing, permission management, I'll skip as of now. So I'm saying for S3, I want to include list. People can list the buckets, read the things, read the items in the bucket. Okay. Now, to go specific, I'll choose the resources. Now pay attention. You have to define the permissions for the bucket and the data into that. See, in the bucket, we put an object. Okay, let me do one thing. Let's imagine this is the S3 bucket. So this is my S3 bucket. What is a bucket? It's a container. It's a container which can contain your data. Fine, which can contain your data. Now, the thing is that any data, any piece of file, it is a file over here. It can be of any format, AVI, MP3, for example. It can be a JPEG, a PNG, an AVI. It can be any format. Now, the thing is, this piece of data that you put in the bucket is called an object. Fine. That anything that you put in the bucket is called an object. It's a container, and the data that you put in the bucket is called an object. Fine. Now, the thing is, bucket is a container, and anything that you put in the bucket is called an object. Now, the thing is that when you create the custom policy, you define the permissions at two levels: at the object level, the data level, and at the container level. So you define the permissions at two levels: bucket level and object level. Fine. That's how you define the permissions: bucket level and the object level when you create a custom policy. Now, let's go back to the page. I go back to IAM. So this is where we were to create a policy. Yeah. So I'm saying S3 list and read. These are two permissions. I can list the items and read the items. Now I need to go to the resources. Now the thing is that I need to go to the second option, specify bucket resource. I have to specify the bucket over here. So what is this? It says bucket, specify bucket ARN. ARN stands for Amazon resource name. It's a format to identify the bucket. I click on add ARN. You don't have to do anything, just type in the bucket name. So I have the bucket in this list. This is the bucket name. Copy it. I paste it over here. Now, again, I'm saying this seems to be a bit complicated. That's absolutely fine. If I choose any, it's choose asterisk. What is asterisk? Every bucket. But in my case, I'm saying this is the bucket. This is the ARN of the bucket, which means that this is the special identifier that identifies, okay, this is the bucket. Okay, ARN stands for Amazon resource name. It uniquely identifies resources. For every bucket, we have an ARN. If I have to show you that on the bucket itself, I choose a bucket, fine, and I choose a bucket in the list, and at the top right-hand corner, you can see that it says copy ARN. I can copy the ARN, and I can go back and paste it over here. Same thing, fine. So it's a special name assigned to the bucket, every bucket, Amazon resource name. So I'm saying this policy applies to this bucket. Click on add the bucket. So we have applied the permission at the bucket level. Now, what about the object level? We discussed the object is the data that we put in the bucket. So we scroll down, then we choose object. Object, it's a data that we put in the bucket. Add ARN. Now it says, what's the bucket name? I mentioned the bucket name. This is the bucket name. Okay. Now, what's the object? To which data you want to apply this policy to? I would choose any. It says asterisk, which means that I want to apply this policy, this permission to all the objects in this bucket. If I have a specific object name, I can specify the name of it. Any, for example, a PPT document. For example, it is rohan.pptx. It's a PPT document saved in my S3 bucket. Or if it's a folder, I can type a / Rohan /. Okay, so I think it's not. So the thing is that, for example, rohan.xlsx. What I want to say is that, or rohan.avi. Do you want to apply it to a specific object? Or if I choose any, it includes asterisk. I'm saying this is the bucket. Just apply the bucket name over here one more time. This is the bucket. And I want to apply this policy to all the objects in this bucket. If I choose any, okay, click on add, and this completes the configuration. Now, once I apply the service, which is S3, the permissions, click on X add tags. Fine. Now this is you can skip it. Click on next review. Now it says review the policy for the S3. This summary S3 list and read access is given. Fine. And that's it. I can just make it, for example, assign this policy name. This is let's suppose demo. Or okay, read only S3 policy. Now this I can find a description. This gives read only access to which bucket? I can mention the bucket name to this bucket. Fine. This gives a read only access to this bucket. So I can define the policy name. I can also define the bucket name over here. Fine. This is the policy name. This is the description. This policy gives a read only access to only one bucket. And then I go ahead and click on create policy. This creates a policy for my only one bucket. If I just go to this policy right now, then in that case, this will give the read only access to only one bucket. That's how you define a customized policy. You can see the resource bucket and all its objects. So for example, if I create another user on IAM, let me just go to the user and attach a policy to that user. Let me do that. I add the user. I name this user as Davik, and fine. Let's add this user one more time, and I define a password for this user. And then I'm saying I attach this policy, which is, I think, if I filter the policy with the customer managed, so this is the policy that I just created, read only S3 policy, the bucket name, fine. Click on XAD tags, I can skip it, next review. So for this user called Davik, this is the policy assigned to him so that he gets the read only access to only one bucket, create user. And if it is try to log in on behalf of this user, let me just do that real quick. I copy this link one more time, shoot back to Chrome browser or sign out on behalf of Steve and just sign in on behalf of Davik, this new user who has got the read only access to only one bucket. So let's type in done. He has just signed in. Now, if he's trying to access any other service, he'll be kicked out because I haven't given him access to EC2. Okay, I've given him access to S3, but limited access. If he goes to S3, then he can list all the buckets. He can see the buckets. But if he randomly goes to any bucket and tries to access it, he'll be kicked out because it says insufficient permissions to list the objects. Okay, so he goes on the track and search for the bucket that I've given him access to. I think it's Rohan AWS S3, this one. Fine. So he picks that bucket and now he'll able to read the objects. But if he's trying to choose anything and tries to delete any of the object in this bucket, he'll be denied. You can see that it says access denied, fail to delete. So the customized policy will empower you with some custom-based.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Permissions that you can formulate by yourself. So in a business environment, you'll be creating and managing these customer managed policies because the default one that you get, it may not suit your need. Fine. The very first thing I will do is that before I launch the instance is that I'll discuss with you this concept, the AMI or the Amazon Machine Image. See, what's that? See, right now, for example, you have a machine with you, a physical machine. It's a physical server, maybe a computer, maybe a laptop, maybe a smartphone, any device that's there with you. So AMI stands for the Amazon Machine Image. So what is that? So if you have a physical server with you, maybe any device, a laptop or a computer, a production server, a desktop, and I ask you to install an operating system upon it. You can very easily do it on the fly and you can install the OS upon it. But if I ask you that, okay, now install the operating system or software upon a virtual machine in a separate data center that you don't have access to. You need to install the operating system, the packages, and the software upon the virtual machines or the EC2 instances that are running in the confinement of the Amazon's cloud infrastructure. So what's the solution? The solution is the AMI, that stands for Amazon Machine Image. Now, it contains the information which is necessary to launch an instance, including operating system, architecture, virtualization type, storage, what's the storage that you need to get access to, what type of storage you need to add on to it. It's like you can see that it's an entity which encapsulates the operating system, services, application, and scripts. When you execute that package, it installs everything upon that instance. Now, what's an EC2 instance? It's a virtual machine which has certain type of compute capacity, RAM, storage, or without any clicks. Now you have to, without any clicks can also be done. If you use auto scaling and automation, then you don't have to click anything. That's right. So the thing is that you need to have the AMI. If you don't have the AMI, then you can't install the software components upon the instances. Okay, I'll do one thing. I'll start with the launching process, and in that journey, in that midway, I will start making you understand those concepts. Now you have to bear with me. You have to be patient enough. Now I'll be skipping some of the concepts that are advanced in nature or that are out of the box. See, if you go on AWS page, you will see so many services out there. No one on it who's working on AWS will know all the services, right? Even in EC2, you will see so many things that will attract you. I will only discuss those services that are within the curriculum. Yeah. So I just go to the EC2 right now, and you will see that we just went to this page. Now, in order for the this thing to work properly, you have to make sure that you switch to an appropriate region of your choice. So because the instances are the region-specific resources, so you have to switch back and forth between different regions so that you can decide upon that, okay, in which region you want to deploy your EC2 instance into. Okay, so I'll do one thing. I just go ahead and click on launch instance. Okay, no, IAM is not region specific, but the instances are. So now before you can deploy the instance, you can see that these are the availability zones that are available in Mumbai. So 3 data centers. You can see the service is operating normally. Okay, so this is called the instance dashboard or EC2 dashboard. Now, on the left-hand side, you will see there are a bunch of options out there, and there's so many options. We'll discuss some of the options in detail on the left-hand side, and I'll try to cover almost all of them. Now, the thing is that I need to click on launch instance first and click on launch instance once again. The very first option that you're being presented with is the AMI, that stands for Amazon Machine Image. Okay, let me do one thing. Let me switch back to Virginia and show you that thing. So this is the page where you can access the AMI or the Amazon Machine Image. Now, what's an AMI? AMI stands for Amazon Machine Image. As you can see that it's a template that contains the software configuration, including operating system, application server, and applications. Now, these things you need to launch your instance. Fine. You need an operating system. It can be Linux or Windows or Mac OS. Nowadays, we also have Mac OS as well. And we also have different flavors of Linux distributions like Ubuntu, Red Hat. Okay. Now, the thing is, on the left-hand side, okay, these are the quick start AMIs. Now, these are the AMIs that we'll be using just for the demonstration purpose. You will not be using them in a business environment, to be very frank and honest. This is just for the purely hands-on and just to get your feet wet or get your hands dirty. Okay. Now, the thing is that there are two types of virtualizations, PV and HVM. We don't have to go into the details. We don't have to get and understand the para virtualization type or virtualization type of these AMIs. Basically, it's nothing but it's an operating system along with the additional software installed upon it. So these are the quick start AMIs. We have Amazon Linux, Mac OS Catalina, Big Sur, Mojave, Red Hat Enterprise Linux, Ubuntu, Microsoft Windows, Deep Learning AMI, Debian, Microsoft Windows Server 2019, 2022, base as well, Data Center Edition. Yeah, so you can see that there are different AMIs you can choose from. This is purely for the demonstration purpose. Now, the one that will be using the most in your business environment is your My AMIs. Now, what are these things? Now, these are the pre-built, these are the custom-built AMIs that you can start using on the fly. Now, as we have seen the customized policy, the same goes with the customized AMI. See, the quick start AMIs, these are the raw AMIs. These are not being customized based on a specific requirement. So this will have the operating system plus set of services and applications of your choice. So in a business environment, you will have a complete container. This is a container only. This is a repository where you can maintain multiple Amazon machine images. Those are customized in nature. Okay, I'll show you that process later on. Marketplace means that you can purchase the services or software as a service from different vendors in the form of AMIs. Okay, this is also that your company will be using a lot. For example, you want to deploy a Juniper VSRX next generation firewall in this infrastructure that's being developed by Juniper Networks. It's a very popular firewall company like Palo Alto, Cisco. Okay, click on VSRX next generation firewall, and immediately you will get the prompt to deploy this firewall by using the AMI. Okay, so it's a VSRX next generation firewall. You can see the product details of it, the pricing details. Now it's available for free for 30 days. Okay, and you can see that there's a software fee imposed upon you, 55 cents per hour. This software fee will go to the software vendor, that's Juniper. The instance fee per hour will go to AWS. You don't have to go to them separately and pay to them. Just pay them an hourly fee, and then based upon this amount, it will be distributed to Juniper and AWS. Now you can see this is, instance type on the left-hand side. Instance type is nothing but it's the physical specification of those instances, the amount of RAM, the CPU, the storage, and instance offers to you. Okay, now the higher you go, the more you have to pay. So you can see that the instance fee will increase as you go down, right? Because the amount of RAM, CPUs will change or increase, but the software fee remains the same. So you can leverage a software from a very esteemed vendor like Microsoft, SAP, Xent, Cisco, Microsoft, and use this software as a service and deploy the services in Amazon's infrastructure by using their AMIs. You have to pay for them. You can also go with long-term. There's an option to go for long-term as well if you want, and also separate charges for storage. Fine. Community AMIs, it is used for lab purpose. Basically, the people who are just experimenting with the stuff, they can publish their own customized AMI in this community repository, and you can use it. It's just for the use for the experimentation purpose or the lab purpose. In the business environment, you'll be using my AMIs and the AWS Marketplace the most. Okay, community AMIs, most of them are free, but some are paid. See, if I go with any of these AMIs, I can publish them on community platform, and I have the option to charge for that, right? I can select any one of them, and I can make it public in nature. These are private as of now. If I make them public, they will show up in community AMIs. I have the option to include a charge on them, but you will see that 95% of them are free of cost. Just 5% are paid. Okay, these are free. Okay, so coming back to the quick start. So the quick start AMIs are the one that you use for the demonstration purpose. And of course, we're just doing the demonstration stuff. Then we're using this right now. Now, you will see that we have the Amazon Linux 2 AMI. It is one of the basic AMIs you can start using on the fly without giving it a much thought. Okay. I click on select, and you will see that it's being selected. Now, the next type is that you have to choose instance type. Now, I don't want to deep dive into different instance types as of now because it's a complete theory, but I want to give you a very basic information before we go into the advanced concepts later on. See, for example, today you just want to simplify the things. Today you want to buy a laptop. Maybe you say, okay, I want to buy a MacBook. Okay. Now, based upon your budget and your requirement, you will see that, okay, what's the amount of storage it gives? Maybe you want to go for 512 gig of SSD storage. What is the amount of GPUs it has? The RAM specifications. Maybe you want to go for a 64 gig RAM. Okay. So depending upon your requirement and budget, you choose the specifications of your laptop or the computer that you want to purchase. Similarly, in a business environment, if you want to buy a production server, you see the amount of RAM storage it offers. Similarly, when you go with a virtual machine, you will see the amount of virtual resources it offers to you. Now, the virtual resources is in the form of virtual CPUs. Okay, now I don't go into a lot of specifications. It is one virtual CPU. It says 2.5 gigahertz of Xeon processor, 1 gig of RAM, right? Some amount of storage. It gives you almost 8 GB of storage, right? So this is the T2.micro, which is a free tier eligible. Now, one thing that you have to understand, if you're using a free tier account, make sure you use a T2.micro or T3.micro instance type, depending upon the availability. So if you're using a free account and you want to refrain yourself from paying extra charges, of course, no, who will do that unless it's required. If you don't have much of the requirements and you want to go simple, then go with T2.micro. Now, these instance types are being differentiated in form of different instance classes. For example, T2 are the burstable, which means that you can also add some credits to them. You can increase their performance afterwards. We'll come to that afterwards. So the thing is that these, based on your requirement, these are instance families that based upon different requirements. For example, this C type instance type, they give you more compute capabilities. Then we also have, for example, G, that's time of G will give you more GPUs, the graphical processing units. Then we have, for example, M4. These are used for web-based applications or very medium-built database applications for a variety of use cases. Okay. We also have R, which gives you a lot of, so anything which stands for R in this test family will give you more amount of RAM. So the thing is that you can see on the right-hand side, the virtual CPU, the amount of RAM this gives to you. And based upon that, they will charge you. So, right. So it's like you're going to a store, and the more RAM you add to a laptop and the more the high performing resources you add to it, the RAM configuration, the GPUs, the storage, the more you have to pay. It's the same thing. Now, it all depends upon the workloads you'll be running, the set of services and applications you'll be running upon these instances. Fine. So now the next thing that you will see over here is, now the very first thing is that you need to define the number of instances that you want to deploy in one single shot. Now you can go up to 10, 100, 150, depending upon how many instances you can launch in one single shot based on your account. And for example, I want to deploy 10 instances with the same configuration, same instance type, same operating system, same settings, right? But I'll just go with one. There's another option which says launch into auto scaling group. Now, what's that? Now, auto scaling group is just to facilitate automation process. It's there to facilitate your automation process. Purchasing option. Now, the thing is that whenever in a business environment, you want to deploy an instance or a virtual machine, there's some billing options that you are being presented with. Apart from this instance type you choose, you also need to pay for that how you'll be running that instance. Maybe based on the time, hour consumption, or the seconds consumed, or maybe you want to reserve it for a 1 year or 3 year contract. Okay. Now, if you search on their documentation, if you just Google it, just AWS EC2 purchasing options, if you just type these keywords, so you'll be able to see that how they are priced, they are different. So what is it, there are different billing options they have. I just put the link in the category. It's not there on the slide itself. So how they will charge you for the running of instances. Apart from these types that you choose and you have to pay for the specifications, based on the consumption-based model, you need to pay for these different types of these instances based on the pricing model that you choose. Now, on demand is the one that is very common to use because it can be used in any account, whether it's a demo account or it's a business account. On demand means that there's no long-term commitment with Amazon Web Services, no long-term commitment with them. There's no upfront payment. You don't have to pay anything at the initial stage. You deploy any instance, you use it for a few hours or seconds. If you don't need them, stop them. That's it. You pay for the time consumed, and that's it. It's like you hire Uber to drive to a destination. You just pay for the amount of miles or kilometers you have traveled, and that's it. You don't have to pay Uber driver the payment for his installment for his car, right? So it's based on the consumption, the number of hours consumed. Once you stop using those your instances, that's it. Your commitment stops. You pay for the time consumed, and that's it. There's no long-term relationship or contract with Amazon. Now, this goes a little bit costly in terms of usage. If you have any usage which is low cost usage and flexibility, start using it. It is used for a very short-term basis, spiky and unpredictable workloads. So, for example, you're getting your feet wet and you're still trying the waters. You're just trying to test the things out before you can jump in and start going big on AWS. At the initial stage, for example, for the first few months, you say that, okay, let's test the things, let's test the waters and see that whether it suits us or not. I've seen from my experience that people go to AWS, sometimes they might go to then Azure or vice versa, right? The biggest benefit about these cloud service providers is that they give you flexibility to come in and go out. They don't want to bind you, right? You come in, use the things. If you like it, go for a long term. and save your cost. If you don't like it, exit. You can still stick to your on-premises network or go to Azure or GCP. Okay, if you don't like Uber, hire Ola, right? Or hire Lyft. So you can switch back and forth between different service providers. Now, if you think that, okay, for example, I need to go for a 1 year or 3 year contract. In that case, you go with reserved instances. Now, reserved means that you come into a 1 year or 3 year contract with Amazon. It gives you up to 72% discount compared to on-demand pricing. Okay, so for example, an on-demand instance costs you $1 a minute. Then you have to pay, for example, just 30 seconds a minute. I'll just give you a rough example. So you can get up to 72% discount compared to on-demand. You come into a 1 year or 3 year contract with AWS, you purchase these reserved instances. So now this benefits both the parties. Amazons get a long-term contract with you. They get an upfront amount. Now you can pay upfront amount in 3 different phases, installments. It's up to you.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customer says about the course.
The way I got a technical job was because of Intellipaat only. They only arranged me interview with a reputed company in Hyderabad, and I cracked the interview in the first round itself.
Now, let's continue with the session.
So Amazon know that, okay, this customer has come to us, has given us a good amount upfront. Let's give him the benefit, and you get the benefit in terms of discounts. Okay, now you can see over here, if you just go to, let me just go back to this instance page, you can see that we have the reserved instances. Now, reserved instances, you can, for example, just go to this page and click on purchase reserved instances. You choose the configuration, choose the term, 1 year or 3 year contract. You choose that, and you can start using, once you pay the upfront amount, they have some flexi options to make the payments. For example, no upfront, partial upfront, all upfront. It is different payment options that they give to you. Either you pay in installments or you pay your entire thing upfront, and you can purchase it and get a huge discount. Now, in a business environment, you'll be using a lot, right? So you can choose the platform, choose the instance type, then classes. You can convert them in future, or just keep them as standard. Payment option, flexi options, how you'll be paying for that. For example, I'll be paying half amount right now, half amount after a few months, or maybe I want to pay the entire amount right now, and that's it. So once you launch the instance with the same specification, it will be charged under the reserved instance category, and it's nothing but it's the discount applied on your on-demand usage, right? The next thing that you'll be going for would be, now these are the two that you'll be using the most. Spot, I don't think you'll be using it. Basically, you bid for unused EC2 instances. Few companies use it. For example, Netflix uses it. Basically, you can use it temporarily for processing some information, or just for the demonstration purpose. Basically, you do the bidding, there's a spare capacity. Now, the thing is that there's a problem with the spot instances. They can be terminated anytime. You can lose access to them anytime. Yes, you can get a buffer time, but they are not used in all the use cases. I don't think you'll be using a lot in a business environment. The next is the savings plan. It is kind of reserved instances with a lot of flexibility in terms of whether you want to go for hour usage, 1 year usage, 3 year usage. It is a kind of reserved instances, but gives you a lot of flexibility in terms of the configuration that you get. Now, dedicated host is nothing but it's a dedicated physical server that you get for your usage, a complete physical server. Okay. So you can purchase a physical server. They will allot you a physical server. Now they will charge you on the on-demand basis, or you can reserve that physical server, and you get that physical server upon which you're the only one to deploy your virtual machines upon. Okay, you get the entire physical server.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 is which type of storage service? A. Object. B. Simple. C. secure, D. Block. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
See, this is a complete physical server that you can use, upon which you can deploy your EC2 instances. If you see from the hardware perspective, you get the dedicated host. Per second billing, now basically you also being billed for per second usage if you're using Amazon Linux, Windows, and Ubuntu operating system. Okay, so if you, for example, if you stop the instance, if you're running an on-demand instance and you stop it before 1 hour completion, they will charge you for the number of seconds consumed. This was a very concern from a lot of consumers because, so for example, if you just run the instance for 20 minutes, you'll be charged for the complete 1 hour. So now they've come up with this option. Okay, you run the on-demand instance. Okay, so these are some of the purchasing options. Whenever you get the free time, go through them. Okay, it's complete theory, but from my experience perspective, you'll be using on-demand and reserved instances the most in your business environment. Okay, now next we'll discuss the VPC. Okay, now VPC or the network is nothing but it's a virtual data center that you deploy in the cloud. Okay, now there's a very separate concept on VPC in detail that we'll discuss, but I'll brief you about it. See, what is a VPC? See, what happens over here is that let's imagine that today your company says, okay, you work with a company and they today decide, okay, let's go and start deploying our resources on AWS. Let's do that. Now, a lot of companies have this challenge or they have this concern about security because even their competitors are on AWS and you, me, anyone can sign up with AWS and start deploying our resources on the fly. We need some privacy. We need some isolation from other people because let's suppose Vodafone, Microsoft, Airtel, Zolosoft, multiple companies are working, multiple companies have their accounts on AWS. They have their infrastructure running upon the same platform. Now, how you can protect the unwanted or unauthorized access from them? You want some privacy, you want some isolation. So they have come up with this concept. For example, the concept is called VPC, that stands for Virtual Private Cloud, right? So we have this okay, now what happens in this VPC is that you get the entire data center with you. So what they say is that VPC is this is a kind of a virtual data center. And it gives you flexibility in terms of resource management, and it gives you security. Now, how it is secure? I just give you one simple example. Let's imagine that this is a VPC which is owned by Vodafone. It is owned by AWS, but there's a separate VPC owned by Vodafone. Now, there's a separate VPC owned by Airtel. Now, even though they're competitors, they are on, for example, on Amazon's platform, right? So they have their individual infrastructures on AWS, but they're kept separate. So it's a kind of, we can say that it's a virtual data center. So they will say, okay, the Airtel's network is different from Vodafone's network. They are on AWS, but they're being kept separate. They are being given the isolation. They're being isolated from each other. Even though they're running their infrastructures on AWS, they are being kept separate. For example, let's imagine you go to a hotel, your room is different and the other customer's room is different, right? Similarly, you are using a same premises, but you are being kept separate, fine? So that there's no, so you get the seclusion or the isolation, right? So it's a kind of a virtual data center. Now, what happens in a VPC is that if I just get into some more details, VPC is a region-specific resource. For example, this is my VPC, right? This VPC is in Mumbai. Now, Mumbai is denoted by this terminology or this term AP South 1. Fine. So AP South 1 is my Mumbai region. Now, so what is a VPC? It's a virtual data center. Now, in a VPC, we have different subnets. So VPC is given us an IP address range. For example, it is 10.0.0.0/16. Okay, I'm just giving one example. And this VPC will have the subnet. For example, this is subnet. Now, subnet is a complete block of IPs. For example, so would be linked to AP South 1A, and will have a set of IPs assigned to it. For example, 10.0.1.0/24, right? It's a complete block of how many IPs? 4091 IPs. So this is a set of somewhere around 4000, I think 91 IPs. Right? So these many instances can be launched into that. So a subnet is a block of IPs which is linked to one of the data centers or availability zones, and you deploy your instances or databases inside them. So these are your EC2 instances, right? Similarly, you can have a different subnet. So a subnet is nothing but it's a block of IPs. It's there embedded into a VPC, which consists of your instances. Fine. So a subnet is nothing but it's a block of IPs. A subnet is linked to a specific data center or the availability zone in that region. You can have different subnets in a single VPC. Fine. So VPC is nothing but it's a virtual data center, which gives you flexibility and the amount of security that you need to go for. Okay. Now I just go ahead and show you the stuff. Now this is the VPC. This is the default VPC. This is there by default. These are different subnets which are linked to different availability zones in North Virginia, because the dashboard I'm working on is the Virginia's one. Fine. So for example, I choose this subnet. In this case, the instance that I'm going to launch would be deployed in US East 1D availability zone. But if I choose to no preference, then Amazon will automatically pick any one of these different subnets or availability zones and deploy my instance into that. Fine. Now what happens is that your instance will get the private IP address from the IP address range assigned to the subnet. So the private IP would be fetched from the subnet range, right? So instance will get the private IP from those 4091 IPs. So private IP is used for internal communication, which means that communication within the VPC. So it's used for internal communication. So if two instances in a VPC want to communicate with each other, what they're going to be using? The private IP. Now, what if this VPC needs to communicate with the internet? The instance within that needs to communicate with the internet, then you can auto assign the public IP, so that apart from the internal communication, this instance can be public in nature and can talk to the internet. For example, if you deploy any website or web application for this instance, it can use the public IP. Fine. Placement group. Basically, placement group is nothing but you cluster your instances. For example, you go with a cluster placement group. Now, this is the one that you'll be using the most. Okay. Placement group means that you cluster the instances together in a single data center so that they can talk to each other with minimal latency. If you have instances running in a single availability zone, they will have the fastest access to them because they're running in the same facility. You can cluster them together. Now, you may have this requirement where the instances need to have an internal dialogue with each other for a fast performance. In that case, you can cluster them in a placement group. Capacity reservation is one concept where you can keep this capacity reserved for a few hours. For example, you need to deploy 100 instances. You need to have this capacity guaranteed for a certain amount of time. Okay. Frankly speaking, I haven't seen this being used in any production environment. You have this option. You can create a new capacity reservation by ID, or you can just create a new capacity reservation. For example, let me show you. I click on create new capacity reservation. So I can see that, okay, I want to reserve 100 instances for few hours, right? So this would guarantee you the reservation for a specific duration. See, sometimes in few situations, you're going for on-demand instances. Even the on-demand instances are not available every time. For example, you're going for a very specific high-level configuration. And sometime that specific instance, the type that you want to go for, you need 100 instances of that. Sometimes those 100 instances might not be available at that time. So if you want to guarantee it for a certain duration, for example, specific time, then in that case, you can specify that date and you can reserve that capacity. Fine. Frankly speaking, I haven't seen that used too much in a business production environment, because either the companies go with on-demand, or most specifically, they'll go with the reserved. Okay. So this guarantees you that you'll be guaranteed the capacity for a certain duration. You can choose that, okay, I want, this is the instance type, this is the platform, this is the availability zone. Just give me, I can end my reservation whenever I want. So guarantee me the capacity until I cancel it out. So every time you launch those 100 instances, or out of 100, you pick 20 instances today, 20 instances tomorrow, you will get up to 100 instances guaranteed. There's a cost for it. Fine. Okay. Having said that, let's go back to this page. Domain join directory. Now you can have a domain created and join this thing with your instance, but as of now, it's not needed. IAM role I've discussed with you. So you can use this role so that this instance can access my buckets in my account. Shutdown behavior. When you shut down the instance, do you want to stop it or terminate it? Stop means that you can stop it, start it, stop it, start it, stop it, start it without losing anything. Terminate means that you permanently remove that instance from the account. It's completely gone from your account. It will not be there. So you get rid of the instance itself. You delete it, you permanently remove it from the account. So I just make it stop as the default behavior. You can also enable hibernation as an additional stop behavior. You can also put it to hibernate state, but I will just uncheck it as of now. Enable termination protection. Now, see, when you terminate any instance, maybe this instance that I'm going to deploy is a very high-end production server with a very critical application running upon it. If some IAM user by mistake accidentally terminate this instance, my operation would be inhibited. It would be hampered. So I just want to make sure that no one can accidentally terminate this instance. I protect it from accidental termination. In that case, the termination option gets grayed out and it has to be enabled. There's a series of steps that needs to be followed to re-enable that. So if you want to gray out or you want to disable this termination option for a very critical instance, then you can check this option. Okay. Now, the next thing is the CloudWatch detailed monitoring. Monitor means that why we want to monitor it. We want to monitor the performance of the instance. We want to analyze, we want to gauge upon our instance performance. Now, this begs this question that why an instance performance needs to be gauged. See, an instance will take the traffic, process the information, send back the request, store some information. Now, an instance will have some capacity. If that capacity is being maxed out, the application running upon the instance would be impacted, would be severely impacted or adversely impacted. Now, it's important that you can analyze its behavior, its functionality, so that if it's touching the limit where it can just shut down, or maybe it is impacted or it hangs or freezes, then you can take some appropriate steps beforehand. Now, the monitoring is done by a single service that's called CloudWatch. Now, CloudWatch is a service that we discuss explicitly in detail in SysOps curriculum. Okay, so now we're talking about the CloudWatch in terms of instance performance. So how it works. So let's imagine that this is my virtual machine. This is my EC2 instance. Now, I want to gauge upon the performance of it. Now, what happens is that you need to imagine the CloudWatch as a separate entity. Now, CloudWatch, we don't run it upon the instance. It is a separate entity. So you don't run up upon EC2 instance as a client software. Instead, you treat it as a separate entity. Now, how it will analyze the performance of the instance? That's the main thing that we have to look into. See, what happens is, basically, it analyzes the performance based on the metrics. Metrics are the parameters, or it is a scale based upon which the performance would be analyzed. For example, I'm running a marathon. So how my performance will be analyzed? Based upon the kilometers or the miles I ran in the certain amount of time. Okay. So in a marathon, what are the two metrics? Kilometers or miles to cover the distance, to calculate the distance covered, and the minutes or hours for the time consumed. So what are the metrics? Minutes and kilometers. These are the scales based upon which my performance as a marathon runner would be analyzed. Now, similarly, we have metrics. Every single resource will have its own set of metrics. For example, EC2 instance will have metrics like, let's suppose, CPU utilization. So it will have a lot of metrics, but I'm just giving you one example. CPU utilization. Now, whenever you launch an instance, the instance will push those metrics to the CloudWatch. It will say, hey, CloudWatch, these are the metrics based upon which you'll be gauging upon my performance. It will push those metrics to the CloudWatch. For example, the CPU utilization. Now, the CloudWatch will ping, it will try to it will just call the instance, say, hey, instance, I know that what your metrics are. Now, could you please give me the values? So the instance will then push metric plus statistic. So instance will say, okay, this is my performance. For example, presently my CPU usage is somewhere around 70%. It will push that information to the CloudWatch, and you can easily log into the CloudWatch. For example, this is you are the system administrator. You can easily log into the CloudWatch and you can see that, okay, yes, and this is what the performance right now. Right now, the CPU performance is 70%. Okay, so the resource will push the metrics to the CloudWatch. CloudWatch will analyze the performance of the instance. It will fetch the metrics along with the statistics from the instance, and you can log into to the dashboard and you can see the entire picture. You can exactly see that what's going on. Now, the frequency of this monitoring, especially with respect to the instance, it comes in two flavors. There are two types of frequencies. So if I talk about the frequency of monitoring, means that how frequently the monitoring would be done. There are two frequencies. The first frequency is called the standard. Standard is a default frequency. Standard/default. Now, the standard or default frequency, it is a 5-minute interval, which means that it will happen every 5 minutes. So every 5 minutes, you can just get the new fresh statistics, and this is free of cost. So CloudWatch will monitor the performance of the instance every 5 minutes. The dashboard, you can just get the fresh statistics. So every 5 minutes, it will come up with new data. Okay, the real-time data, the present data. So that's the first one. The second frequency is the detailed monitoring. That's a detailed. Now, for mission critical applications, if this is a very critical instance for you, you can say that, okay, I'll monitor its performance very extensively, and I can go with detailed. Now, what happens in detailed is that you lessen down the frequency. So you bring the frequency down. Every time it will ping the instance every 1 minute and give you the fresh statistics. But so it is fast in nature. So it's a 1 minute frequency, but it's paid. So every 1 minute, it will ping the instance and get you the fresh statistics. So it is a 1 minute interval. Fine. Monitoring. So these are the two different flavors of the CloudWatch monitoring with respect to the instance: standard/default, and then we have the detailed monitoring. Now I'll just go back to this thing. So if I keep this option checked, it would be standard. If unchecked, it would be standard. The 500 frequency. If I check it, it becomes detailed. So if I uncheck it, what happens? It becomes standard monitoring. It remains standard with a 500 interval frequency, which is free of cost. But if I check it, it becomes detailed, which means that the performance will be monitored every single minute, but it's a paid option. The additional charges apply. Okay. Now the next thing is tenancy. Tenancy means that how exactly what's the platform that you're using to deploy instance upon to. One is shared. See, your instance will run on a physical server. This is a diagram that I want to show you over here. So if you see this diagram on the right hand side, let me see if I can just click on that. Okay. If you see this diagram right now, what happens is that you have a physical server, a bare metal, and it's a host server. What you do is that you install a client software that's called hypervisor. Hypervisor is a layer. It's a client software that you install upon the bare metal, and it will help to deploy different virtual machines with different guest operating systems. For example, guest 1 is a virtual machine which is supporting Windows Server 2016. Guest 2 is another virtual machine which is supporting Ubuntu Linux machine. Guest N is another virtual machine which is supporting, for example, let's imagine Mac OS Catalina, right? So on a single host server, you deploy a hypervisor. That hypervisor will facilitate deployment of different guest machines, different virtual machines. Now in AWS, those guest machines are the EC2 instances, right? Now the thing is, guest 1, guest 2, guest N, EC2 virtual machine 1, EC2 machine 2, or EC2 machine N. If they belong to different accounts, different customers, different organizations, it is assumed as the shared tenancy model. For example, you hire an apartment, okay, which consists of 5 rooms. Now you don't need 5 rooms to stay in, you're just the only one. So you say, okay, I'll go to a shared apartment where I'll stay with other people and I'll share the rent, right? So similarly, you just go with a shared tenancy. You're saying that, okay, I'm not the only tenant. I'll share the physical server space with other people. So in shared tenancy, your EC2 instance, your virtual machine will be running upon a physical server, which is being shared by other consumers, by other clients, other organizations, other accounts. Now, this tenancy cost is free. You don't have to pay for this tenancy. But if you say, oh, okay, I don't want anyone to barge into my apartment. I want to have my own space. So guest 1, guest 2, guest N, all the EC2 instances will be yours. You say, hey, AWS, allot me this physical server. I want this physical server. Give me that. I'll be the only one to deploy my instances upon that. So all the guest machines, all the virtual machines would be yours. So in that case, what you can do is that you can just go back to the instance dashboard, and then you will say, okay, if you go with the shared, this is free of cost, where you'll be sharing your instance with share the physical server with other clients, with other account holders. But if you go with dedicated instance or dedicated host, they're the same thing. Dedicated host is much advanced. If you go with dedicated, then you are given a private space, a physical server you own, and any instance that you deploy in the future will be deployed on a dedicated physical server for your usage. But for that, you have to pay separate charges. Now, this begs this question that, okay, why would I go for that? Why would I pay separate charges? See, might be you have some compliance requirements where you're not allowed to deploy instance on a same physical server upon which the virtual machines of other people, other account holders are running. You may have some compliance requirements. You may have some security and compliance issues, even though you get the isolation and segregation at the shared instance level. Still, your company's policies don't allow you to have a shared virtual machine on a shared physical server. You have some strict legal, security, and compliance requirements. Sometimes there are some software requirements. For example, the Oracle Enterprise databases, if you want to deploy that on AWS, you have to go with the dedicated database instances. Some software requirements may force you to go with the shared dedicated instances.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 has how many pricing components? A. Only 4. B. Only 5. C. Only 3. D. Only 2. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So some software, legal, compliance requirements may push you towards dedicated instances and pay you some extra bit of amount to get some private space at the hardware level. Okay, so I go with the shared tenancy as if now. So that's about the instance details. I've discussed with you pretty much a lot of options so far. Let's click on next add storage. Click on next add storage. Now, this is the amount of storage being allotted to the instance. This storage is called the EBS volume. Now, this is a kind of a virtual hard disk you assign to the virtual machine. That's your EC2 instance. See, you're using a laptop or a desktop to join this session, to be a part of this session. Your laptop or a desktop, whichever machine you're using, maybe a tablet, it has some internal storage. If you don't have the storage, it will not have any space to boot the operating system upon, or to store some data, to have the system files upon it. So a virtual machine needs a virtual storage. That virtual storage, that a default option is called the EBS volume. Now, by default for Linux machine, you get 8 GB of root volume. Now you can change the storage up to 16 terabytes. Click on exact tags. Now tags is nothing but it's a simple identifier just for the documentation purpose. See, you will have a dashboard. And for example, you have the S3 buckets, right? If you have multiple S3 buckets, you can identify those buckets. Okay, this is the bucket for my production environment. This bucket is for the development. This bucket is for this team. This bucket is for this business unit. Now you have the names allotted to the buckets. Similarly, you assign some special names to the instance just for the identifying purpose. Maybe you're running 1,000 instances on a page and you assign special names to them. Okay. So for example, I add a key first, key is name, and I just type the value for this one. For example, production server. This is for a team. For example, this team is anything, production server, team, or project alpha, right? There's a separate team, there's a separate production server in that team, and this instance belongs to them. So you can identify that on a single page, you can identify that instance. Okay, this instance is meant for this one, just for the documentation purpose. Okay, click on next, configure security group. Now this is very important. See, a security group is nothing but it's a firewall that you apply to your instance to restrict the incoming and the outgoing traffic, or you specify that which is the specific traffic to reach your instance. So for example, you allow a web server access and you want to restrict the incoming traffic or outgoing traffic with respect to that instance. You want to restrict the traffic. You don't want the traffic to just any traffic to reach your instance. Now you need to have some kind of restrictions imposed upon the instances. So what happens in that case is that you want to ensure that you can filter the incoming and outgoing traffic with respect to your instances. So what is how exactly you can do that? Right? Okay. So what is a security group? Let's imagine that this is my AWS cloud infrastructure. This is my Linux instance. So this is my Linux EC2 instance. Now, upon this Linux EC2 instance, I have, for example, a WordPress blog running. a WordPress site. Fine. Now, the thing is that there are two different set of people who will be accessing this instance, one for the administration purpose, another one just to access the website upon it. So on the right hand side, I have this data center located. So this is my on-premises network. This is my, for example, my corporate network. This is my in-house data center. So this is my corporate network, and this is my in-house data center or office. Now, this is where my solutions architects, my administrators will be operating their day-to-day task. Now, this office will have a specific IP address assigned to it. Okay. Now, I can say that, okay, if my internal employees, the IAM users I'm talking about, IAM users, they will be accessing this instance they will be getting the root access to the server to, for example, install some scripts, some software, some additional services, right? So they need to get root access. Now, if it's a Linux instance, we'll be using SSH. SSH opens the access to the root of the Linux server. It uses port 22. Now you allow it from this IP. Now, if it's a Windows, you'll be using RDP, but we are using Linux for this thing. So I'm saying SSH is allowed from the known IP address, from my branch office IP address. On the other hand, I have a bunch of external users. External means these are the internet users. These are the internet / external users. Fine. Now, these people need access to my instance so that they can access this application. Right. So the thing is, what they will be doing is that they will be sending the HTTP request, which uses port 80. Maybe they're sending HTTPS traffic, which uses 443, right, to access the web application running upon the instance. Now, I will give them the open access to my web application. So I'll say, let's allow the HTTP access or HTTPS access from anywhere. Anywhere means 0.0.0.0/0. So I'm saying, okay, allow the HTTP and HTTPS access, the web access from anywhere, but the access to the shell of the server, the core of the server, has been given to the people in my branch office who can perform the day-to-day server administration. Now, who performs this job? This job is performed by security group. Now you segregate the traffic, you filter the traffic based upon three things. You filter the traffic based on first port, protocols, and IP addresses. These are three filters that you use: ports, protocols, and IP addresses, based upon which you can restrict the incoming and even the outgoing traffic. But generally, you mainly focus on the incoming traffic. So security group is nothing but it's a firewall. Now you use that firewall to restrict the incoming traffic. See, mainly the incoming, but you can also do the outgoing. Okay. I'll create a new one. Let's name it as, for example, production Linux or production WordPress server. SG stands for security group. Just copy and paste the same in the description. Fine. So set a name to it and a description. Now the SSH is allowed either from my IP. Now this automatically picks the IP address of my computer I'm working on right now, or I choose a custom IP and as I say, okay, 56.0.0.0/16. Now this is the, so I'm saying I want to allow access, allow root access to my in-house sysadmins. So my in-house system administrators will get the root access to this thing. So this belongs to my branch office, my in-house data center. And on the other hand, if I deploy a WordPress site upon it, I would choose anywhere the users can get the web access to the WordPress site running upon the instance. So I'm saying HTTP access from internet users, they can browse the website running upon that. I'm not giving them the root access. Root access is with the in-house people, but the website access is with the external users. See, for example, right now we are accessing the Intellipaat's website. Fine. So the thing is that Intellipaat's website is maybe running on a virtual machine behind the scenes. I'm not getting the root access to it. I can access the website. Fine. Click on review and launch. Now I can review any of these parameters before I can hit launch. Click on launch. Now this is a method of authentication to get a secure access to your instance. This concept is called key pair. One key is with AWS embedded into the AMI, and the other one is that we store on a computer. So I'll show you that afterward how you use it. I create a new key pair and assign a name to it. For example, name it as prod-kp. Now it will store a PEM key that I'll be using to authenticate and get a secure access to the server. Click on download key pair and click on launch instances, and that launches our instance. Plain and simple concept. Okay, I have requested more virtual CPU capacity. I chose 100 because I'm using business account, not an enterprise account. That's the reason. So over here, I can click on launch and simply launch my instance. So I just launched the instance real quick. Now, whenever you choose the AMI, then the next thing is that you have to choose the instance type. Now, as I've already discussed with you, an instance type is nothing but it's the virtual representation of the underlying physical resources. So the amount of RAM, CPU, storage, GPUs, the amount of resources that an instance type offers to you, based upon that, you can deploy your set of services and applications upon the instance, and you can change it afterwards. So if you don't have the idea that, okay, which instance type is the best for you as at this position, you can always go back, stop the instance, and you get the option to change it afterwards. I'll show you. So you can change the instance type. Now, there are different instance families. So some are compute optimized, which gives you more compute power. Some are storage optimized, which gives you more storage. Some are memory optimized, which gives you more RAM. So based upon that, they have differentiated as per different instance categories or instance families. Now, if you're using a free account, either go with T2.micro or just go with T3.micro. Okay. Now I just click on next configure instance details. I discuss with you a few of the options in detail, including the purchasing options. Now, as if now this instance that I'm installing or I'm launching would be the on-demand instance. So we discuss on-demand instance, which is the purely time-based, consumption-based model. You pay for the number of seconds or hours consumed. Then we have reserved instances, where you reserve those instances for 1 year or 3-year contract and get a discount of up to 70% compared to on-demand. Then we have, for example, we also discuss the dedicated host, dedicated instances where you can deploy the instances on a dedicated physical server, spot instances, which is rarely used in a business environment, where you bid for unused compute capacity. But the thing is that the instances can be terminated at any given point of time. So basically, you will use on-demand or reserved. Network, I discussed with you the VPC. VPC is a virtual data center. Now, within a virtual data center, you have different subnets. A subnet is a complete block of IPs, the private IPs, and each of these subnets is linked to a specific availability zone. Now, as per the AWS best practices or recommendation, as per the best practices and recommendation, it is always recommended that you choose no preference, because in that case, AWS will ensure that they will have your instance being deployed in a availability zone which has enough capacity, because might be I'll be launching 100 instances in one single shot. So sometimes if I choose a specific availability zone, that availability zone, it may not have enough capacity to support that specific instance configuration. So you choose it to no preference just to make sure that your instance can be launched in any availability zone which has enough capacity to support the number of instances that you need. Then you can auto send the public IP, which exposes the instance to the public. Placement group I've discussed in brief. We'll discuss in detail afterwards. You can go with a cluster placement group where you intentionally cluster your instances together so that they can have a faster access towards each other over a high throughput network and high throughput and low latency network. We'll not discuss it as of now. Capacity reservation is just to guarantee you capacity for a specified duration. Domain join we will not discuss right now because generally you may or not or go with this. I will not discuss this thing, we skip it. IAM role, as I've discussed with you, this facilitates this instance to access some other resources on your behalf. So I can have this instance access these 3 buckets. Shutdown behavior is stop or terminate. Stop means that you stop it, start it. Terminate means that you permanently remove it from the account. You can enable this protection against accidental termination so that no one can by mistake terminate this instance. I discussed with you different 2 flavors of CloudWatch. One is standard monitoring, the frequency of which is 5 minutes. The detailed monitoring, the frequency of which is a minute. Standard is free of cost, detail is paid. Tenancy I've discussed with you, shared and dedicated. Shared means that you run your instance on a physical server upon which the instances of other account holders would be up and running. If you go with dedicated, because if you have some security compliance requirements or software requirements, then you being allotted a complete physical server, only your instances would be up and running upon that. Okay. Elastic inference, credit specification, they are not of very importance. Very new options. Still, I have seen that I haven't seen them being used anywhere. File system we'll discuss afterwards. Once we discuss the elastic file system, we can link this instance with a EFS block or the storage that we'll discuss afterwards. Advanced details, we can put a script over here under user data that I will show you today itself after we are through with this topic. Then we can add the EBS volume. Click on XAD tags. We can add a tag to it. Security group, I discussed with you that it's a firewall.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customers says about the course.
The way I got a technical job was because of Intellipaat only. They only arranged me interview with a reputed company in Hyderabad, and I cracked the interview in the first round itself.
Now, let's continue with the session.
That is, you can use to restrict the incoming and the outgoing traffic with respect to the instance, right? So I also showed a scenario, just a real recapitulation, just to make sure that we do the revision before we can jump to the next level or the advanced concepts, right? So we discussed this thing, security groups. Now, why security groups are important? Because it's a firewall that you apply to the instance or the instances. You can restrict the incoming and the outgoing traffic with respect to the instances. For example, in this scenario, I allow the SSH traffic from the known IP addresses from my data center or my in-house office, but the web access is given to the external users. It ensures that only the authorized access is given to a bunch of users, right? So it is a firewall which restricts the incoming and the outgoing traffic with respect to the instances, and you filter the traffic based on 3 different parameters: ports, protocols, and IP addresses, right? Now, you may be a developer coming from a development background. This may be a bit off the track for you, but that's the only thing that you have to understand, right? You don't have to go into very advanced firewall configuration. It's a very basic thing. Just try to memorize the concepts. Okay, click on review and launch. You can review the parameters, click on launch. Now you can create a new key pair or choose an existing one. Now this key pair will be used to authenticate and get access to the instance afterwards, fine? And then you can launch your instance. So this is what we have discussed while launching the instance. Let's move forward with the connection process, right? Okay, so guys, the thing is that we need to understand the process of connecting to the instance, and it's a very easy process. It is just that you have to understand that how exactly this works for you. So the thing is that from your local machine, you'll be getting access to this instance running in the Amazon Web Services cloud infrastructure. See, the thing is that you connect to this instance from your end, and the process is a bit different whether you're connecting from a Linux machine, a Mac machine, and the Windows machine. Now, the thing is that this is a Linux instance, right? Now it uses the SSH protocol over port 22. Now, the thing is that AWS has given you multiple options out there. For example, you choose the instance, click on connect, and you have this EC2 instance connect. Now, this is a new option out there, but this is not very reliable. I don't think that you'll be using this in your business environment a lot because it is browser dependent, and sometimes your browser may not support it or not. Now on Safari, it doesn't work properly. Sometimes it works, sometimes it does not. But on Chrome, it works perfectly fine. So I can go to EC2 Instance Connect. Okay, before that, I need to make sure that I just go to the security group of the instance, and I can just refresh the SSH coming from my IP, because in that case, I'll be making sure that I'm authorized to gain the root access, the SSH access. Yeah, so I just use my IP so that it picks the computer, the IP address of my computer, and I can get access to this instance. Now, the thing is, you need to make sure that once you allow the SSH from a known IP address, then you can just choose the instance, and you can click on connect on the top. It shows you EC2 instance connect. This is the default username. So EC2-user is the default username of the Amazon Linux instance AMI. The public IP address, instance ID, you click on connect, and if your browser supports it, then you'll be able to connect to the instance without any issues. Now, sometimes it works on Safari, sometimes it does not. Yeah, this happens sometimes, but I think on Chrome it will work fine. But what I'm saying is that the most stable connectivity option that you have is the client software, PuTTY. You might have used it, might have heard about it. So you need to depend upon some third-party client softwares if you're using Windows, right? So if you're using Windows as your base operating system, a Windows machine, then you can install PuTTY or any third-party client software where you put all the information and you gain access from that. It's a very stable connectivity option that you get, instead of going for any browser dependent connectivity options, right? Okay, so I have a Windows machine running. Let me just drag and drop it over here. This is Windows 10. I think Windows 11 has now been introduced. So I'll get license copied after, but this is unlicensed copy because I'm just using that for the demonstration purpose. What I will do is I'll show from the Mac first. I'll be using it to connect to the AWS account, to the AWS instance running in the Amazon infrastructure. Now you can download PuTTY for free of cost. It's not a big deal. If you just Google it and just type in PuTTY free download, you will get a ton of resources out there to download PuTTY free of cost. So let me just put that. And I see that if I show you the link over here. So this is a link. Now there are two softwares that you need to install on your Windows machine. One is PuTTY, PuTTY.exe. This is the one. So one is the PuTTY.exe. I'll be using 64-bit version of this thing, PuTTY.exe. And the next thing that you have to install is PuTTyGen. PuTTY is used to connect, and PuTTyGen is used to. Let me do one thing. Okay, if you're using a PEM key, then PuTTyGen will be converting that key from PEM to PPK. Whenever you generate a key, let me show you that. So I also download PuTTyGen. Okay, now they're being installed on my computer. Hang on one second over here. Now, one thing you have to understand, that whenever you generate any new key, let me show you. See, the key that that's installed on my computer, it's in PEM format. Can you see that? It's PEM, PEM, this one, PEM format. Now, PuTTY doesn't accept PEM key. It accepts the PPK key, right? Now, why? So you can convert this format. And I think AWS also gives you now the option to download the PPK version of it. Let me see that, if I can get that. So if you generate the key itself, I go to the keys on the left-hand side. if I just try to, okay, if I create a new key pair, can you see that I can also generate a PPK key now? But the thing is that originally I went for PEM key. That's okay. If you have the PEM key, use putagent to convert it. Else, when you create a new key for Linux, make sure that you choose PPK and download the key in the PPK format. Okay. So what I will do next is that I'll open puttygen. Now, if you have already have the PPK key, you can skip this step because putty accepts only the PPK format. But I have PEM format. I forgot to install the PPK format of it. So I'll convert the key from PEM to PPK. So let me see that because I don't have the PPK version of it. So I have the PEM version of it. Let me see that. But I don't have the, just go to the downloads. Yeah, I have the PEM version, right? So I'll be using the PPK version. So I'll just convert it. What I will do is that, see, there are multiple softwares in the market. You can try any one of those, fine. Okay, so what I will do is that I just go to putty key generator, go to file, load private key, and load the PEM key saved on my desktop, right? Click on open, and once it imports the key, then I click on save private key, click on save, and this will save it in the PPK format. Now, if you somehow skip it to download that in the PPK format, then you can convert it using the puttygen. Okay, so I've already converted it. Now you can see that this is the new key in PPK format. I'll be using putty to connect while using this key. So how will I go about doing that? I go to putty. Now, guys, in your organization, this is how you will do that, because you're not to be depending upon the browser related software clients. Because sometimes you don't have JavaScript working properly, or the browser doesn't support that. This is the most reliable option. Now, I've used putty extensively in my day-to-day organization environment, so I'm comfortable using it. If you're using some other software, that's okay. Okay. Now, the very first thing it will ask me is for the host name or the IP address. So the thing is, I need to put in the host name or the IP address. Okay. So how will I go about doing it? I need to just go back. Either I just copy and paste the public IP address of the instance, or the public IPv4 DNS name. Okay, fine. I can put the IP address of the machine. The port will be 22. Connection type, the SSH. Now on the left-hand side, you can see there are different categories out there. Now I need to upload the key right now. To do that, I go to SSH, AUTH, expand AUTH. Now, the thing is, you just go to this thing, SSH. I think they have changed some options over there. Under AUTH. Okay, yeah, go to SSH and AUTH. Then you can browse the key from here. Browse the PPK key. This is the PPK key that we just generated. And we click on open. And I accept it. And it gives me the login as stuff, the prompt. Type in the username, EC2-user, and I shall be able to connect to the instance without any issues. So you need to depend upon putty or any third client party software in a business environment to get access to the Linux instances from Windows. Okay, fine. Now for Macintosh, it is a very simple option. You need to just open the terminal out there, and basically you need to go to your location where your key is being saved. Okay, so this is my key. So you need to use the PEM key, right? Use the PEM key. Now, the very first thing is that if you're using from Macintosh, not for the Windows people, if you're using the key for the very first time, you have to change the access rights of it. So type in chmod 400, type the key name, right? Then SSH-I, type the key name, username, EC2-user, @ Now you define the public IP address or the public DNS name of the instance. So I define the public IPv4 address, paste it, and I'm connected, right? So it is easier on Macintosh compared to putty. You just need to execute 1 or 2 commands and you should be connected. Fine. That's a process that you need to just go through. to connect to your instance, the Linux instance, using a Mac machine or a Windows PC. Now, we don't use private IP because private IP is only used for internal communication. Public means external. See, right now we are external users. We are gaining access to this instance over internet, not internally. You got the point? I'm using internet connectivity, the internet or the WAN network or the internet network to get access to this instance. I'm not doing that internally over VPN. That's the reason we'll be using the public IP. Okay. Now for Windows, the process is a bit different. So for Windows, what you need to do is that I just quickly launch the Windows instance because the options are almost same. So for example, I launch the instance and I pick one of the Microsoft Windows based AMIs. So let's pick the Microsoft Windows Server 2019 base. Okay, click on select. Okay, then we use t.micro, click on next configure instance details. Now the details are same. You don't see any difference out there. Okay, click on next add storage, next add tags. We just name it as, for example, production Windows Server. Production Windows Server, something like that. Just put it anything over here because we're just performing the demonstration, right? And now we just create a new security group because for Windows, if you want to get the root access, you need to choose the remote desktop protocol or RDP, which uses port 3389. For Linux, we have SSH over port 22. For Windows, we have remote desktop protocol, which uses port 3389.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 is which type of storage service? A. Object. B. Simple. C. Secure. D. Block. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
I choose from my IP so that I'm the only one to get the root access to the Windows instance. So we use RDP, this stands for Remote Desktop Protocol, to get access to the Windows instances. Click on Review Launch. Now I can choose the same key pair that I've used with the Linux instance. Okay, you can use the same key pair to access the Windows instance and the Linux instance, and click on Launch Instances. Okay, I think I need to go back and make sure I can change the security group, put a new name for it. Right now, once we launch the Windows instance, then I'll show you the process to get connected to it. Now, for the people who are using Macintosh, you need to depend upon a third-party client software. That software is called the Microsoft RDP or Remote Desktop Connection. So if you just go to the App Store, you can easily get it for free. So from people who own Mac, just go to the App Store and just type in Remote Desktop, and you can install the Microsoft Remote Desktop client on your machine. And the process is very simple. You put in the IP address of the machine and password, and you should be able to connect. I'll show you that how you can get the password to get access to your Windows instance. Fine. So Microsoft Remote Desktop is easy to install on your Macintosh. Now for Windows people, there's no need for that because the RDP client is already pre-installed on Windows machine. Okay. So it's taking some time. Windows take a bit longer to boot up. In the meantime, if you have any questions, then you can just put the questions forward. Sudhanshu is saying from one AWS instance to another instance in same VPC, you can use private IP. Absolutely. If it's internal, in the AWS, then one instance can have a dialogue with another instance using private IP because it's on the same network. But because we are connecting from the outside network to the AWS instances, then we use public IP. But if two instances in the same VPC or in same Amazon's network, if they want to have an internal dialogue, they will be using the private IP. Okay. So what I'm saying is that public IPs, there's no security threat. If AWS is getting a public IP, there's no security threat. Okay. Let's forget about internet service provider. Let's focus on AWS. If you're deploying your services on AWS, no two instances will get the same public IPs, or the instance will not have the same public IP as a machine outside AWS. Fine. I think this will pacify this entire conversation. The instance will get the unique public IP. It will not be same as a machine in the same network or outside it. Fine. Okay. So there's no threat to security. Okay. Apart from that, even someone gets the public IP or has the same public IP doesn't mean that you will be able to get access to the instance, because you have security groups, you have the key pairs. So you have different authentication mechanisms to give the authorization to the authorized people. Okay. Right. Okay. Now let's go back to the Windows instance. Let's the thing is how you can make sure that you can just go ahead and get access to the instance running on Windows. I was not talking about the public IP of the instance. I was talking about the public IP of client connecting to it. You were restricting access to the instance to users using a particular public IP. The answer is same. No two clients will have the same public IP. Okay. I'm not sure which service provider does that. No two machines can have the same public IP on the internet. Okay. Okay. Let me just go log into AWS Management Console. And also one thing that the public IP address is once the public IP complete public IPs is leased out to your corporate network, it is static in nature. The public IPs that are being assigned to your corporate network, it is static in nature. It never changes. You will see on a company's network, the machines have the same public IP every time you log in. So the block of IPs assigned to your corporate network, it remains the same. It never changes. Okay. All right. So let me log into the my root account. Okay, so I just go to the EC2 right now, all services, go to EC2. Now to connect from my Windows machine, I'm running this Windows 10. I just simply click on connect from there. And so I choose my Windows instance. I choose my Windows instance and I click on connect. Now I have to generate a password for it. So I can just go to RDP client. I can download a remote desktop file. Now, before that, I can just get a password. Now, to get a password, I just browse for the PEM key that's being saved on my desktop. Okay, now this is the password. Now you can change this password afterwards at the Windows level. Now I click on download remote desktop file. Now I open the RDP file that's being saved on my computer, click on connect, just put in the password and from my Windows 10 computer. So I should be able to connect to the Microsoft Windows 2019 server, right? So from a Windows 10 machine computer, I should be able to connect to the Microsoft Windows 2019 server. Fine, that's the way. And on the Macintosh, download the third-party software I've shown you, put in the public IP or the public DNS name along with the password, and you should be able to connect. This completes the conversation of the EC2. I've shown you the entire process of connecting to the instances. Fine. Okay. Let's discuss the concept of EBS, the Staff Elastic Block Store. I also show you afterwards how to create an AMI. We'll show you after we discuss the EBS stuff. We'll discuss that. Okay. Okay. One thing that's I missed out is the concept, the differentiation between the public IPs and elastic IPs. Now, the thing is, the public IP, we already see that we need to have the public IP to make the instance public in nature. Now, what do you mean by public in nature? Public means that it is exposed to the internet. You can get access to the instance over the internet, whether you need to connect to it using SSH or RDP, or the simplest use case is that you have installed a WordPress website or some web application upon the instance. And now you need to ensure, hang on one second over here, you need to ensure that you can get access to it. So the purpose behind we discussed the public IP. Now there's no charge for public IP. So public IPs are free of cost, as you see on the slide itself. They're free of cost. Now the thing is that at the back end, Amazon Web Services, they maintain a complete pool of public IPs. What happens is that whenever you deploy an instance, it automatically fetches a public IP. without even you knowing that, it automatically gets a public IP, right? So what's the purpose of public IP? The concept, the purpose behind the public IP is that it allows you to gain access to the instances and the applications running upon it. You gain access to the instance or the applications running upon it over the internet. It makes your instances and its resources public in nature. Fine. Now, it's free of cost, no charge for it. And whenever you deploy an instance, automatically Amazon will fetch a new public IP from its pool and assign it to the instance. It's automatic in nature. But public IP comes with certain disadvantages. I'll pick the first instance as an example, and so that we can just focus on this instance, Linux instance, right? Now, this instance that you can see right now, it has a public IP. Okay, I can use this public IP to get access to this instance using SSH, or if I deploy any Apache or any web application upon this instance, maybe Nginx server plus some WordPress site running upon it, anything I deploy upon it, any web application, I can get access to it on the fly. But the biggest challenge is that this is not static in nature, which means that if I stop and start the instance, this will be gone. And so what happens is that the public IPs, they don't interact with the instance on permanent basis. Let me show you this thing. And I'll discuss with you the real-time scenario that how it will impact the performance or the reachability of your website. So for example, I go back to the details, copy the public IP, and let me put that on a text document, right? So this is my public IP address of the instance. Let me do one thing. Let me just go ahead and stop and start it. I go to the action, go to instance state and stop it. You will see that once I stop the instance, automatically the public IP address, which is a part of this instance, which ends with .15, will be detached from the instance automatically. It will be gone. Let's see. So this instance, once it stops completely, the public IP address of this instance will be detached automatically. Let's wait for a few seconds and see what happens. So as you can see that this instance is getting stopped, okay? And once it stops completely, you will see that the public IP address will be completely, it will just not show up. The private IP would be there, but the public IP would be just detached itself. It will just not be a part of this instance anymore. Now, you may ask this question, where it's gone, by the way. When I stopped the instance, before I stopped the instance, it was there, where it's gone. So when you stop the instance, see, there's already shortage of public IPs. There's already shortage of that. That's why now we are going towards IPv6 addresses. There's already shortage of it because public IPs are unique resources. Now, when you stop the instance, Amazon will assume that, okay, now because if any machine is stopped, there's no purpose of assigning it a public IP, which is a scarce resource, because you can't access it over the internet. It is stopped, right? So there's no point to have a public IP v4 address assigned to it. It's a scarce resource. So Amazon says, okay, you stop the instance, we'll just take it back and put it back into the pool of public IPs that we maintain at the backend. We detach it and put it back in our own set of public IPs that we maintain, okay, right? Now, when I restart this instance, you will see that now this time it will get a new public IP. When I restart the instance, you will see that it will get a new public IP. Can you see that? Immediately it got a new public IP. Immediately. Now, this may be a normal thing for you. This may not impact you, but sometimes this will impact you. Why or how? Let's suppose that, let me give you one example over here. So let's imagine that this is your AWS cloud infrastructure, right? This is the AWS cloud, and this is the, for example, this is the a Linux instance or EC2 instance, any instance, Linux or Windows. Now, the problem with the public IP is that, so what happens is, for example, you have installed upon it a kind of, you can see that a Drupal web application. So a Drupal web application is installed upon it, fine. So a Drupal web application is installed upon it. Now, this is a website that people would access from outside. Now, what happens from your end is that you will be, this instance will have a public IP. So how the users will get access to the website? So for example, you have these external users. These are external or internet users. These are your end users who would be using your services. Now, how they will access your website? Now, they will use a domain. Now, how you access facebook.com, google.com, you just type in www.facebook.com. So these users will, for example, type in, for example, your website domain, xyz.com. They will say, okay, I want to reach, let's imagine xyz.com. This is your domain. Now, this xyz.com will translate itself to the public IP address of the instance. Fine. So the user types in xyz.com and it will translate it to the public IP address of the instance. Fine. Now, what happens that if you stop this instance and restart it, then this domain has to be pointed towards a new public IP. Then in that case, if you skip doing that, then what happens? Your users will not be able to access your website. So this means that every time your instance reboots and you restart it, and if the website or the web application running upon this instance needs to be linked to your domain, then in that case, your domain has to be pointed to a new public IP. Now this adds on the overhead on you because every time, say, instance restarting is a very normal process. If you're doing some patching, some updation, some upgradation, you will just very frequently reboot your instance. Now, if you reboot your instance, restart the instance every time, and it gets a new public IP, if it's linked to a domain, the web application running upon it, then you have to link the domain to a new public IP every time, right? Now, how to sort it out? Because the public IPs are not static in nature, they are not reliable resources. So AWS says, okay, if you are dependent on the public IPs, why don't you use a static public IP that's called the elastic IP? So don't depend on the public IPs too much because they are not reliable. If you stop and start the instance, you'll get a new public IP. So if you want to get a static public IP, the other workaround is that you can attach the elastic IP address to the instance. Now the question is that how you can go about doing that. The answer is that you just go to the elastic IPs on the left-hand side. Now the elastic IPs are allotted to your account. You can see that there's a elastic IP allotted. Let me just, I think, yeah. So elastic IPs are allotted to your account. They stay in a region. So you need to allocate an elastic IP to the account first, and then you associate it to the instance. So I will say allocate elastic IP address. Okay. Now network border group is nothing but it will say that, okay, in which region this elastic IP would be assigned to. In my case, it's US East 1. That's the North Virginia. And that's it. Click on allocate, and you will see that you'll get a new elastic IP address assigned to you automatically. Now, this is assigned to the account, not to the instance. It is not assigned to any instance right now because you can see that the associated instance ID is blank. Now, I need to just choose the elastic IP, go to actions, click on associate elastic IP, and I need to associate it to one of the instances. I choose one of the instances. Okay. Choose the private IP address of the instance, and I click on associate. We'll also discuss the network interface afterwards. You can also link it to the elastic network interface if you want. Okay. But as of now, I'll be associating this elastic IP to one of the instances running in my account. Now, what happens? When I assign this elastic IP address to my instance, which already has a public IP. Okay. So this is the elastic IP. I'll be linking it to this instance, which already has a public IP. So if you assign an elastic IP address to an instance which already has a public IP, what happens? This public IP address would be detached automatically, and the elastic IP becomes its new public IP. I repeat my statement. When you link an elastic IP to an instance which already has a public IP, then the public IP address is gone, and the new elastic IP becomes its new public IP. The new elastic IP becomes its new public IP. Okay, let me show you. So I go to the elastic IPs and choose it, go to actions, click on associate elastic IP address. We'll choose the instance, choose its private IP, and click on associate. Now you will see that immediately it associates or it binds itself to the instance. I click on the instance, and you will see that now that instance, which had the public IP address it's no longer there. And this elastic IP that I just linked to the instance, it becomes its public IPv4 address. It becomes its public IPv4 address. Now, IPv4 addresses are out of 32 bits. So there are 10, 10, 10, 32 ones and zeros. So the IPv4, the public IPv4 address or the elastic IP is linked to this instance. Now, if I just stop and start this instance, you will see that there will be no change to this public IP because now it is the elastic IP, which is the public IP address of this instance, which is static in nature. So I go to this instance state and stop it. You will see that once I stop it, there will be no change. Once I restart it, there will be no change whatsoever. It will remain static. Now, the other advantage of the elastic IP is that you can achieve something called quick failovers between two different instances in the same region. For example, so this instance has my, for example, I may label it as primary instance. And then you have the secondary instance, primary instance or the secondary instance. Now the primary instance has the elastic IP assigned to it, but not the secondary instance. So for example, you have two instances, one primary, one secondary. Now your entire traffic goes to primary and secondary is there just a standalone server just for the backup. Now let's imagine a situation comes up to you when you have to stop the primary instance for some time because you are performing some maintenance. Maybe it is it's not working properly. You have to upgrade some of the apps running upon it, maybe the operating system version. So this instance would be unavailable for few hours. Now, the thing is that because there will be a downtime to perform some maintenance or patching, you want to make sure that there's no downtime. The users can still access your website or the web services running upon that instance. So you can say that, okay, I need to shut down my main instance for a few hours, upon which my main web application is running. Why don't I switch the traffic to the secondary instance for a few hours? So how can I achieve that? The quick workaround is that I just detach the elastic IP from the primary instance and move it and align it to the secondary instance. So I just I take the elastic IP address off from the primary instance and put it to the secondary instance. What will happen? As a consequence, the traffic will be diverted to the secondary instance automatically. Okay. So how can I do this detaching and attaching? So first thing first, I will detach the elastic IP from the primary instance. Now, once I do that, you will see one thing. Once I detach the elastic IP address from the instance, automatically gets a new public IP. So let me show you the process. I go to the elastic IPs, choose it, go to actions and click on disassociate elastic IP address. Let me choose that. I click on disassociate. Now, can you see that it's no longer being associated to any instance? And if I just go back and check out my primary instance, you will see that the primary instance has got a new public IP now. Now, can you see that? The primary instance has got a new public IP. The elastic IP is blank, right? So whenever you take out the elastic IP address from an instance, immediately Amazon will give it a new public IP. Now, this elastic IP, which is now available and free, it is not assigned to any instance right now. I'll be attaching it to the secondary instance. And so secondary instance has a public IP, it will be gone, and this elastic IP would become its new public IP. So now this is free and available. I'll be attaching this elastic IP address to the secondary instance. And as a consequence, the user's traffic would be diverted to the secondary instance. So I click on actions, associate, and choose the secondary instance, choose its private IP and associate. Now you will see that now I've just switched my elastic IP from the primary instance to the secondary instance. The secondary instance has got this elastic IP, which is its public IP. This was previously the part of my primary instance, but now it's a part of my secondary instance. Okay. Now this flexibility you don't get with the public IPs. This flexibility you cannot achieve using public IPs. But you can do that. You can achieve that using the concept of elastic IPs. You can achieve that using the concept of elastic IPs. And also, elastic IPs are static in nature. Now, coming to the billing part. See, elastic IPs are free of cost. You get 5 elastic IPs free each region, any type of account. It's a free account, it's a business account. You get a bunch of 5 elastic IPs per region. You can use 5 elastic IPs for free in each region free of cost. And that's the maximum limit it can go up to. But the problem is that if the elastic IPs are assigned to stopped instances, or they're just sitting idle over there, then Amazon will start charging you. Let me show you. For example, I go to the elastic IP. So you get 5 elastic IPs free per region. But if I just disassociate this elastic IP, for example, I go to actions, click on disassociate elastic IP, click on disassociate. Now, if I have this elastic IP address unallocated to the instance for hours and hours, this should be free of cost. I get free 5 elastic IPs per region. But Amazon will say you're wasting this. There's already a scarcity of public IPs or elastic IPs. It's not assigned to any running instance. We'll charge you for that. You're wasting it. Okay. So the elastic IP should be assigned to running instances. If you assign the elastic IP to a stopped instance for more than 1 hour, there will be few cents charge being added to your bill. Okay. Few cents every hour. So elastic IPs, you get 5 elastic IPs free of cost per region, but you have to make sure that they are being assigned to running instances. They should not be sitting idle without being unassociated or not associated to any instance for more than an hour, and they should not be assigned to any stopped instance for more than an hour. Okay, that's the case. Now, if 5 elastic IPs are that you get for free, each region is less for you, then you can order a bunch of 20 elastic IPs as a package from Amazon for some cost. Okay, apart from 5 elastic IPs which are free of cost, if you want to have more, you can order a package of a bunch of 20 elastic IPs, but there's a charge for that per region. Okay. Having said that, this completes the concept of elastic IPs. So now the question may be that if the elastic IPs are not used, they're not being assigned to any stopped instance, how to prevent the further billing? So you can choose it, go to actions and click on release elastic IP. Release means that you can release it from the account, but you not get it back. I think there's one option you can get it back within half an hour if you want. So I click on release elastic IP. So it says, if you release the elastic IP address, they will no longer be allocated to your account, and you can no longer associate them with the resources. Click on release, and they will be permanently released from your account. So that if your elastic IP is sitting idle and you have to pay the charges for it, it's better that you release it. Fine. Having said that, this completes the concept of elastic IPs versus public IP. So I think you got this thing. The next thing is the elastic network interface. Now, this elastic network interface is the interface between computer and internet network. So your machines is using a network interface card. It's called NIC card. Now, this NIC card, your computer, your machine to connect to the outside network. Okay. Now, the network interfaces, they have the IP addresses and the MAC addresses assigned to them. Now, your computers, your devices that we use all have MAC address. Now, where that MAC address is embedded on the NIC card of the device, right? Now, what happens behind the scenes that the instances have the primary interface attached to them, which carry all these options. Okay, so let me show you that thing. You don't have to deep dive into this thing. It's a very simple concept. See, every instance will have a primary network interface card attached to it. Let me show you. If I just can scroll down. If you just go to the networking details of the instance, the networking details, you can see that it's an interface. Now, this is the, okay, let me just discuss with you this thing. Now, let's suppose that, okay, this is my instance. Now, this instance will have an ETH0. Now, this would be my primary elastic network interface, or ENI. Okay. Now, what is this ENI? This is a kind of a virtual NIC card, virtual network interface card attached to the instance. Now, what's the purpose of it? See, in actuality, the private IP. It carries a private, public / elastic IP, and even the MAC address. It has a unique MAC address that it carries. So basically it carries these properties for the instance. Okay, you can attach more interfaces to it if you want, but generally nowadays I've not seen any of the very high scale applications being using multiple interfaces. Just a concept, you can attach multiple interfaces to the same instance. Okay, now the thing is that that primary ENI, it's called ETH0, it will carry the private IP, the public IP, and the MAC address properties of the instance. Fine.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Amazon S3 has how many pricing components? A. Only 4. B. Only 5. C. Only 3. D. Only 2. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, let me show you that. If I just click on this interface ID, this is the primary interface. I click on that once again. Now you see that it will carry the private IP. Now this private IP is in actuality a part of the interface, but it shows up for the instance. The public IP, right? So basically it carries these properties on behalf of the instance. And also it has the MAC address. Show you that. Even the security group is assigned to it. And even the MAC address, you can see there's a MAC address. Okay. Now, what's the purpose of this interface? Basically, it connects the instance to the external network, maybe internet, because it carries the IP addresses, the MAC address, the security groups, right? So it allows the instance to be part of to access the outside network. Fine. So the elastic network interfaces are attached to the instance automatically once you launch it. You can also attach multiple interfaces if you want, but nowadays I don't think it will be of much use. You can create a new interface and attach it to any existing instance. But one interface is more than sufficient. It will help your instance to gain access to the internet outside. The next thing that we have is the EBS, or Elastic Block Store. What is EBS? EBS stands for Elastic Block Store. Now, the purpose of the EBS is that you can assign a block level storage volumes with the instances. So your instances will need some storage to store some content to boot up the operating system from. So it needs some volume to be attached to the instance. Now, the thing is that these volumes are nothing but these are the virtual block stores that you attach to the instance, and it is connected to the instance in such a way that it remains a separate entity at the backend.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Let's hear what our customer says about the course.
The way I got a technical job was because of Intellipaat only. They only arranged me interview with a reputed company in Hyderabad, and I cracked the interview in the first round itself.
Now, let's continue with the session.
Okay. So I'll just give you some overview on the slide itself, and I'll just switch to the this presentation part. So what is EBS? It's a raw unformatted block level storage, which is exposed as a raw device to the instance. Now it's an unformatted block level storage. Now block means that it is considered as a hard disk. If you see S3, it's an object-based storage, right? But it's a block-based storage. It's kind of a virtual hard disk that you send to the instance. Now EBS volumes persist independently from the instance, right? What do you mean by it persists independently? Persist independently means that if your instance is impacted somehow, it is terminated, then the performance of the volume is not impacted. Okay, let me just draw that example for you. So what exactly this thing is? What do you mean by the EBS volumes and snapshots and what this thing is? See, let's imagine, I'll just give you one example so that you understand this concept. Let's assume that this is my EC2 instance. We already understood what is an EC2 instance. It's a virtual machine. Now, basically what happens is that you have to have this EC2 instance being attached to a volume. Now, I've shown you that how a volume looks like whenever, on the fourth step, you attach an EBS volume to it. Now, what's an EBS volume? It's a block level storage. It's a block level storage attached to the instance. Okay, now the thing is that you attach the volume. So back end, whenever you launch an instance, this volume would be, it will attach itself to the instance, and automatically, if it's a root volume, it would be mounted. Fine. Now, there's one thing that you have to understand, that these two entities should be in the same availability zone so that they can be connected with each other. So they should be in the same data center. You can't have the instance in one availability zone where the volume is in a different availability zone. Fine. This volume is attached to the instances in such a way that if you as an administrator, this is, for example, your system administrator, you log into the instance from your end. For example, you initiate an SSH or RDP connection. You will find this instance you'll find this volume as the in-house storage. For example, it's a Windows instance. You will see that as a C drive or a D drive. Fine. So you might assume that, okay, this is the inbuilt storage of the instance, but the reality is completely opposite. The reality is completely opposite behind the scenes. The reality is that this instance may be running on a, for example, HP, IBM, or maybe a Dell physical server. It's running on a separate storage, and this volume can be running this running on a separate server. This would be a part of a different storage infrastructure. So these are running on different platforms. So instead of running on a different physical server, the volume is a part of a different storage infrastructure. Now, this will enhance your capability to restore your data. See, the data of the volume and the image files. So the data plus your AMI files, if it's a root volume, root means the main volume, it will be stored upon the instance. Now, there's a statement that we saw over there that the life cycle, the EBS volumes persist independently from the life cycle of the instance. What do you mean by that? Let's imagine this instance goes down, it terminates. Fine. Now, even in the events when your instance are being terminated, it's no longer can be reused, it crashes for some reason. You can have the volume stay over there. Okay, you can take this volume and link it to a separate instance, but in the same. So this is a separate instance or another instance, but you have to make sure that it is in the same availability zone where the volume resides. So you can detach it from one instance and attach it to another one in a same availability zone. So you have that capability. So how this will prevent your data? Your data will be prevented in case of instance failure. If your instance crashes, it terminates, your data remains unaffected or safeguarded, because the life cycle of the volume stays independent from the life cycle of the instance, because they both run on a separate underlying hardware. I think you understand this point. So this is a very important fact you have to understand. I think now the next question that, okay, there's a question, what if the okay, NAS stand for network attached storage, SAN stand for storage attached network, DAS stand for disk attached storage. You can say that it's a storage servers. Just to make an example, these are the storage servers, storage infrastructure. Fine. Okay, now the question is that this begs this question, what of the EBS volume goes down? See, one thing you have to understand, the EBS volume data is replicated across different places in a single availability zone. The data is automatically replicated, right? Automatically in a single data center. Apart from that, you can back up the volume in the form of snapshots. You have the capability to back up the volume in the form of snapshots. How you can do that? So for example, this is my EBS volume. Fine. Now you can back it up. You can back up using a concept called snapshot. Right? You back up the data in the form of snapshot. Now this snapshot data is being put into a backend Amazon S3 bucket that you can't see. It's a purely backend process being handled and managed by Amazon. So the data is being put to the Amazon S3 bucket. Now this is a pure backend process. You can't see that. This is not visible to you. It's a backend process. So you can see the volume, you can see the snapshot, but you can't see the bucket which consists of the snapshot data, right? EBS volume is replicated within an AZ, right? And the snapshot is replicated across different AZs in a region. The data of the snapshot is replicated across AZs in a region. So in these events, your data is being safeguarded because there are multiple applications going on. Your data is being duplicated in a single data center and across different regions, and your data is being safeguarded. Multiple copies of your data is being manufactured and synced in a single data center or across a region if you do that in the form of snapshots. Okay. Raw and unformatted data means that it's a raw data. Raw storage, raw disk attached to it with no data. It only has the image files with no data upon it. Unformatted, see, the thing is that basically what they say is that we attach a very new fresh volume to the instance with no data upon it. Okay, it's a fresh new volume. Fine. I think so the thing is that there's a cost for the snapshot and the EBS volume. So they take that replication cost from the snapshot cost and the EBS volume cost. They will not charge you any extra for that. So they will charge you from the snapshot storage cost and the EBS volume cost. Okay. Now, snapshot stores across a region, across different availability zones in a region, within the region. For example, in a region there are 6 data centers. It will sync the data across all the AZs in a single region. Now, snapshots are called incremental backups. What do you mean by incremental backups? Now, can someone make a guess? What is an incremental backup? The snapshots are called incremental backups. What do you mean by incremental backups? Can this someone guess? It's an incremental backup strategy. What do you mean by this incremental backup strategy? So the thing is that the purpose of incremental backup is that only the new blocks of data would be put in the bucket every time you have the same snapshot of the same volume. Okay, let me just give you one example. Let's imagine that this is an EBS volume of 30 GB. Let me just give you guys already know the concept, but just to make sure that no one is left behind. See, let's imagine, I just give you one example over here. Just try to understand the example. See, whenever, for example, this is the original volume of 30 GB. Now, basically, it's a gigabyte. GIB is gigabyte. 1 gigabyte is equal to 1.07 gigabyte, right? Now, you have this original volume of this volume of gigabyte, and you want to create a first snapshot out of it. You say, okay, let me have a first snapshot being created out of it. You will say, okay, this is my first snapshot. So this is your very first snapshot. Now, one thing you have to understand and you have to remember, the very first snapshot that you take from the volume itself what it will do is that it will take the entire space in the backend S3 bucket. So it will say, okay, I will take the entire space in the backend Amazon S3 bucket. This is the S3 bucket. So in this case, it will consume the entire 30 gig of space, and you have to pay for it. You have to pay for every GB of data consumed in the backend S3 bucket, right? So in this case, 30 GB would be the one that you have to pay for. Now, let's suppose that you want to take the second snapshot of the same volume. So you say, okay, let me take the second snapshot. Now you take the second snapshot. So you're saying, okay, this is my second snapshot I want to take. Now you took the snapshot after a gap of 1 day. You took the snapshot after a gap of maybe 2 days. Let's suppose 2 days. Now, in the span of 2 days, only few blocks of data has been changed. Let's suppose in the span of these 2 days or these 2 snapshots, only 10 GB of data was changed. So in that case, snapshot 2 will append only 10 GB of data. That's it. Similarly, if you take a third snapshot, so for example, you take the third snapshot of the same volume, it will add on, for example, between second and the third snapshot, only 5 GB of data was changed or added. So it will just find those blocks of data that were changed or added and only add on that amount of data. Okay. Now you may ask this question, or this begs this question. Okay, in that case, what's the advantage you will get? The first advantage you will get is that it will bring down the cost in terms of. So the very first advantage that you will get is that. Low storage cost comparatively, because instead of adding on 30 GB every time, it will only append the change data. So you have 30 plus 10, 40, 45. So in total, you just have to pay for 45 GB of storage, right? Also, faster backups. See, the thing is, the more data needs to be backed up, the more time it will take. 30 GB will take more time than 10 GB. 10 GB will take more time than 5 GB. So the more the data you need to back up, once you try to take a snapshot, the larger the snapshot, the more time it will take. So if you want to increment only changed data, only the blocks of volume that have changed, then only some amount of data would be added on. So it will result in faster backups and low storage cost overall. Okay. Now there's another part of the story. If you're able to retain the latest snapshot, so from the snapshot, you can also create a duplicate volume. So from the snapshot, what you can do is that you can manufacture duplicate volume, right? Now, so from the snapshot, you can store it to the duplicate volume. Now, if you're able to retain the latest snapshot and you carve out the volume out of it, it will encapsulate the data of that snapshot and all the previous snapshots. For example, you take the third snapshot and you're saying, okay, I want to extract a duplicate volume out of it. Now that volume would consist of the data of the third snapshot. If you're taking from the third snapshot plus second plus first. So if you're able to retain the most latest snapshot and you carve out the volume out of it, it will capture the data of the third snapshot, the latest one, and all the previous ones. Now, sometimes some people ask this question: if I remove first snapshot and second snapshot, so will it impact? No. Will it change your cost? No, because at the back end the data is still saved in the S3 bucket. So even if you delete the first snapshot and the second snapshot, there will be no change in the terms of cost added to your bill. And if you're able to retain the third snapshot, you can, if you carve out the volume out of it, you will retain the data of that snapshot and the previous snapshots. You got the point? Okay, so this is the incremental backup strategy of the snapshot. Fine. Now, snapshots are used as incremental backups. Also, they are used. Also, they are used for data migration and disaster recovery. They're used for data migration and disaster recovery. How? Let me show you. So they're used for data migration and disaster recovery. So let me do one thing. So for example, let's go to the AWS page, and so the thing is that let's imagine that this is, let me just go back to the services, and this is my EC2. Now let's imagine, okay, these are two instances running, primary instance and secondary instance. If I just go to the volumes, even you can see that on the instance page, I can see the volumes that are linked to these two instances. The ones that are in use are attached to a running instance, in use are attached to an instance. The ones that are available are not attached to an instance right now. Okay, so let me remove these free available volumes. Right now, let me show you. For example, I create a volume. Okay, now a volume is the availability zone specific resource. Now I'll discuss the volume types. Now these volume types will determine the performance of the volume. The volume types will determine the performance of the volume. It will decide upon the performance of the volume as such. Okay, we'll discuss them in detail. You define the gigabyte. I just make it as 5 gigabyte. Okay, now you have to choose the availability zone where that the volume would stay into. I choose US East 1A. That's it, and I can encrypt it. We'll discuss the encryption afterwards. I can add a tag to it. The tag is just the identifier. So I just name it as, for example, additional volume, right? That's it. And you can also extract it from a snapshot, but I'll not use snapshot as of now. Fine. Click on create volume, and your volume ID is created. This is a volume ID generated, and this is my volume. Now this volume, I can choose it, go to actions, and I can modify it. I can have a snapshot out of it, or I can attach it to, I click on attach volume and attach it to any instance in the same availability zone. I can do it without any issues, right? I can choose any of the instances in the same availability zone and attach to it. We'll not go with the attaching process as if now. So this volume, I just produce a snapshot out of it. So how will I go about doing that? I just go to the actions and click on create snapshot. Okay. Now, once I just click on create snapshot, it says that, okay, just put it in the description. I just name it as, for example, demo underscore snapshot. Fine. Now I can add a tag to it. Fine. Demo snapshot. So what I'm trying to do is that I'm just carving out a new snapshot from this volume. Click on create snapshot, and the snapshot is created. Now, this snapshot is contained, is the data of that snapshot. It will take the entire 5 GB space and put into a backend S3 bucket that I can't see. Now, I can, if I just take the snapshot of the same volume, so only the incremental data would be backed up. Now there's no data being changed, so it will. If I just take the snapshot again, only 0 GB of data would be saved in the backend bucket. Now the snapshot is also used. So the very first thing is that it is used as an incremental backup strategy for the volume. Also, it is used for data migration. How? See, this snapshot, if you see over here, this snapshot is in region Virginia. I can take the snapshot and copy to a different region. So go to actions, click on copy, and I can copy it to, for example, let's suppose California. Okay, so I'm creating a copy of the snapshot from one region to another. I click on copy, and you will see that now, if I just go to California, switch to California, I'll be able to see the snapshot, the copied snapshot from Virginia to California. Can you see that? It just got copied over. Fine. So it is used for data migration, and also it is used for disaster recovery. So for example, if I lose access to the snapshot in Virginia, I can retain the same data from a duplicate snapshot in California. So also it is a disaster recovery and a data migration tool or a strategy. Okay. Now I can just go back to, for example, Virginia. Now you can't use a snapshot raw. You need to extract the volume out of it and attach it to the instance. So for example, I go to my snapshot, I go to actions and click on create volume, and I can create a duplicate volume from the snapshot. So let me show you once again. I can choose the snapshot, go to actions, click on create volume, and I can choose a different availability zone this time and manufacture the volume in a different availability zone in the same region, right? So snapshots are used to back up the data of the volumes. They're used as incremental backup strategy. It's used for disaster recovery and data migration. You cannot pull the data raw from snapshot. It has to be extracted in the form of volume, right? Fine. If you want to retrieve that, because snapshot is just for the backups, not for data retrieval. If you want to retrieve the data, then you have to go for with the volumes, because snapshots are just in the case if you lose the volume, right? Snapshots are not used on daily basis. It's just for the backing up. Just in case if the volume crashes, you have the snapshot so that you can retain a duplicate volume out of it and retrieve your data. Fine. The data can be retrieved from volumes, but you back the volume in the form of snapshot, just in case if the volume crashes or it corrupts. Fine. You can also automate the process of snapshot creation. There's something called Lifecycle Manager. You can just go to Lifecycle Manager and you can automate the creation, retention, copy, and deletion of snapshots and AMIs. AMI process I will show you today itself. So it says create a new lifecycle policy, EBS snapshot policy. Click on next step. Okay, you just choose the volume. You can also go with the instance, but I will just go with the volume, and I can just start mentioning the resources over here. See, you can go with this one. Okay, you can type in the key. So this is the name, enter the value. So this is the additional volume, right? So this is the additional volume, and I want to back up. I want to create an automated snapshot at regular intervals, right? So I want to automate the snapshot creation process. So I can, this is a policy, let's name it as, for example, automated snapshots. So I go to Lifecycle Manager on the left-hand side under this thing, snapshots, choose the volume, right? Put in the description. You don't have to change the role over here. Click on enabled, click on next. Okay, this is the volume ID, I think so. Hang on 1 second. So the tag is name, additional volume. So I'm choosing this tag only. Why it's not accepting it? Added this thing and click on next. Now it will ask me the frequency. This is schedule name, frequency daily. I can choose daily, weekly, monthly, yearly. So I pick the additional volume. I say daily, every 12 hours, starting at 9 a.m. as per the UTC time. Retention type count. You can keep the amount of snapshots and delete the previous one. So basically, you are scheduling the daily backup of this volume. For example, every 12 hours, you can choose frequency daily, weekly, monthly, yearly. You can create a custom cron job. So I'm saying that, okay, I want to back up this volume in the form of snapshot every 12 hours, and retain means that what's the count of last snapshots you want to retain. Let's make it as, for example, 5, right? And click on review policy and click on create policy. So it will just retain the 5 latest snapshots of this volume. Now, as per this policy, it will automatically create the automated backup in the form snapshot every 12 hours and retain the last 5 snapshots. So you can automate the snapshot process. There's another complicated way. I'm used to it, but this is the simplest way out there. You can use CloudWatch to automate the backups automatically. Okay. You can also share the snapshot with a different account as well. I can just go to the snapshot. I can choose a snapshot, go to actions, and click on modify permissions, and I can define another root account number over here. Click on add permission and share the snapshot with other root account owner. That I can also do. Okay, fine.
So in any tech company, in any tech team, you have two teams which basically contribute to a release of a software. The first team is called the development team, and the second team is called the operations team. Right now, what is development team and what is the operations team? A developer is basically a person who develops the code, right? He would develop the code, and the code would then be forwarded to the operations guy, whose job is to basically test the code and put it on the testing server or the production server based on the requirement, right? Now, what was the problem here? The problem was when the developer developed the code and he forwarded it to the operations guy, the operations guy's system could not run the code which the developer has forwarded, right? So obviously the developer would have tested the code that he's sending on his system first, and only then he's sending, right? On successful operation on his system, he will only forward the code to somebody else who wants to test it, right? But it did not run on the operations system guy. It could be the problem of environment. It could be the problem that he has not installed everything which is required by the software. So he used to push it back to the developer saying, your code is not running on my system. Please check your code. It is faulty, right? But now the developer was furious. It ran fine on his system. And if that operations guy is not installing something properly, it's not his problem, right? It's not his job to go ahead and fix his system and then run the code, because his job is to run or develop the code which he is doing, and the code is running fine on his system, right? So it's the operations guy problem that he's not able to run it on his system, right? So these were some of the problems that were between the developers and the operations guy, and this was solved later. But before that, there was a lot of problem in team communication, and it solved and it caused a lot of inefficiency in the team, right? When we talk about lean methodology, we were talking about faster release cycles, eliminating waste, but this was a waste that we were not able to eliminate using lean methodology, right? And this was solved using DevOps. Right now, the DevOps is what is DevOps exactly? It is not a tool. It is not a software suite. It's basically an idea. It's basically a thinking, and this thinking is obviously implemented using some tools. But right now, if you were to talk about DevOps, like I said, it's just an idea of working in a certain way that could solve the problem that we were facing between the development and the operations team. So if you were to draw some differences between what we were doing earlier when we were working without DevOps and what happens when we use DevOps, is that the traditional IT system was less productive, although it was very productive, as we saw in lean methodology, where we have eliminated everything. We have tried everything in our hands to solve it using the planning part, but there was still some room of inefficiency that we could not solve using planning, and that was solved using DevOps. So DevOps was more productive than traditional IT, right? And then in traditional IT, we had a skill-centric team, right? Each team was skilled in a particular territory, and we had a lot of teams in our organization which used to work on different things. Now in DevOps, what we do is the smaller teams are also specialized in different domains based on the silos, right? Based on the technology. So rather than having 4 people who are equipped or who are skill centric in one particular technology, in DevOps we had each person who was skill centric in a technology, right? So probably one person would know Kubernetes, the other person would know DevOps better, the other person would know Git better, the other person could know some other technology better. So we had silos like this, right? In traditional IT, we used to invest more time in planning. So when I talk about traditional IT, I'm talking about waterfall, agile, lean, both collectively, right? So there was still some planning involved when we talk about traditional IT. In DevOps, we are basically saying we do smaller and frequent release cycles, right? So we do smaller and frequent release cycles, as we saw by the end of lean and agile methodology, that we are doing smaller release cycles. DevOps take the advantage of those methodologies and implements it in its own model as well, that we have smaller and frequent releases, but they're still smaller than what we were seeing in lean and agile methodologies. How is it? We are going to discuss it in the future. So DevOps still shortens the release cycle by the help of automation. It's a release cycles and hence releases software in even lesser days than or lesser weeks than we had in traditional IT. If we talk about DevOps, guys, I would like to give you a fact that using DevOps methodology, you can have release cycles in a day rather than weeks or months. So every day there could be a release if you're using DevOps methodology to the fullest. Okay, so this was again a good thing. In traditional IT, when we were using waterfall model, for example, it was difficult to achieve a target or goal because the goal was set 1 year later, right? So there was a difficulty in doing that. Reason being, we could not foresee future, right? There could be some more problems that could be there while we are working on a project, but everything cannot be planned in advance. But in DevOps, because we are doing shorter release cycles, it is not that difficult to achieve a target or goal. It is easier to set objectives for a day than to set objectives for an year what you're going to do, right? And that is why DevOps makes it easy for us or for your employees to achieve their goals or their targets. Okay, so this was basically the difference between what we had in the past, probably when we were using waterfall methodologies in the past, and what is the present, what we are able to currently achieve using the DevOps methodology. So guys, like I told you guys earlier, DevOps is nothing but a methodology. It is an idea, right? It is not a tool, it is not a software, it's an idea or methodology of solving the problems between developer and operations guys, right? Now, this methodology involves a life cycle, which as you can see in the diagram that the first thing that you do is you plan what you have to do, right? Then you code your way in. Then you build the code. Building the code means if you have a Java file, for example, you'll have to create a jar file or an executable file out of that. So that is called building, right? So building your code, and then you will be testing your code. So what executable you have built, you'll basically test that code for any faults in the functionalities. And if there are no faults, you'll basically release the code to the ops team. Now there are two kinds of release, guys. There's an internal release and there's an external release, right? The internal release talks about releasing the software to a different team of the company, and this is what exactly is happening. Then comes the release phase where the developer guys release the software to the operation guys for their work, right? The operations guy will in turn deploy the software onto the target system. It could be a testing server which basically will test or do automated test on it, or it could be, you know, the production server where everything has happened, the testing has happened, and you're deploying it on the production server, right? So once you have deployed it, of course, now comes the operation phase. The operation phase can be done internally, or it could be done by your customers, wherein you know, you're operating the software or you release the software for internal employees to see whether you know, the traffic, when is it doing good when it holds when it's getting traffic onto it, is it doing good when normal people are doing arbitrary tasks on your software. And then you are also continuously monitoring it to see if you know, your task is or your application is functioning properly, and if it is not functioning properly, you're basically creating a log of events which are happening, right? Which this is called monitoring. And after monitoring again comes the planning phase, which means if you get any kind of feedback from the monitoring part, you again start planning it, how to do it, how to solve this kind of a problem that you're getting in the monitoring phase, and then code your way in, build the code, again test it, again release it to the ops guy, and this goes on and on until you get the perfect application. And there is no perfect application, guys, right? Always there will be new requirements coming in, always there will be some bugs, always there will be some security patches, and therefore this life cycle goes on and on. So this is what DevOps is, guys, right? And if you were to think about it, how is it solving the problem between the dev and the ops guys is by automating this life cycle. Basically, that means that now the developer does not have to give the code to the ops guy. It'll basically be given through a tool which we have, so there is a tool called Docker, right? So basically the dev guy will enclose his code inside Docker and will push it to the ops team, and the ops team just have to run Docker and this code will run fine, right? There is no problem for dependency. There is no problem for configuration management. Everything happens automatically in this life cycle. So don't worry if you don't understand exactly what DevOps is, because in our next slides, we're going to discuss how it actually works, right? So going forward, now let's discuss how the DevOps lifecycle actually works, right? So if you were to that infinity sign that we had, it if you were to condense it, or if you were to expand it, so that DevOps lifecycle diagram that we had, the infinity diagram that we had, if you were to expand it, it would look something like this, right? So you have something called as planning, you have something called as coding, building, and testing. Now this used to happen on the developers side, right? And then we go on to the ops side, where we have release, we have deploy, you have operate, and then you have monitor, right? So in between this, we have to integrate this part of the developers side to this side of the operator side, and this is done using continuous integration. Now what is continuous integration, we'll discuss in a while, but for integrating the developer and the operations guys, we use continuous integration, right? Now before moving on to what is continuous integration, let's pay attention to what we have over here as well, right? So the planning and coding phase, we contribute, or we collectively call it as continuous development. What is continuous development? I'll explain you in a little while. Building and testing, we call it continuous testing, okay? Releasing and deploying, we call it continuous deployment. Operation and monitoring, we call it continuous monitoring, okay? So you start with planning, you do coding, you build it, you test it, you then release it to the ops team, then you deploy it, then you operate it, and then you monitor it. And this gives rise to 5 stages, that is continuous development, continuous testing, continuous integration, continuous deployment, continuous monitoring, which again goes back to continuous development. Now let's understand these terms. Let's understand what is continuous development, testing, deployment, monitoring, and integration. Okay. So this is the life cycle, guys. Now, why are we calling it continuous? Continuous basically means it goes on and on, right? It never stops. So like I told you in the diagram for DevOps, that the cycle goes on and on. It never stops. The product is always being developed, right? It is always in some part of the life cycle. So if you were to explain continuous development and continuous integration, continuous testing, this is the best way to learn it. Okay, so we have a developer who basically will be pushing his code to a version control system. Okay, and this version control system will basically, any changes in this version control system will be taken up by a continuous integration tool. Okay, so what is a continuous integration tool? A continuous integration tool does nothing but it joins each of these stages to each other. For example, if I have to go from continuous development to continuous testing, and if this happens in separate softwares, continuous integration will join these and this, right? Continuous integration will join testing and then deployment. Continuous integration will join monitoring and then again coming back to development. And how does this happen? It happens like this. So there is a software which basically does continuous integration. Okay, let's understand just this as a black box. This is a software which does continuous integration, and the function for this particular software is the moment you push your code to a version control system. This version control system is nothing but a software which takes care of storing your code. Okay, so the moment you push your code to a version control system, or you change your code in the version control system, the continuous integration tool automatically identifies, okay, so there's a change in the version control system. So what it does is it takes this code and it builds it on the testing server. It first builds it and tests it on the on the testing server, and this is called continuous testing. Reason being, every developer who does this, continuous integration does the job similarly, right? So if there are 100 developers in the team, so for every developer, if we configure a version control system, that for every developer it has to test the code, it will always do that. Okay, so every developer who's doing a version control, who's pushing his code to version control system, continuous integration software is going to test their code on the testing server, right? And this is the reason it's called continuous, right? Because it happens continuously. Okay, so continuous development, we push our code to version control system. It is identified by the continuous integration tool. So the first job that continuous integration tool does is it pushes onto the testing server the code where it is built and tested, and if the test succeeds, continuous integration tool pushes it on the production server. Okay, now either if it's on the production server or if it's on the testing server, now if on the testing server there are some bugs which are identified, the feedback is given through continuous monitoring to the developer. Or if the production server, if there are some problems on the production server, or like I said, when you deploy your code on the production server, it basically gets available to the world and it gets continuously monitored, right? For any kind of problems which are occurring, it gets continuously monitored and the logs are generated, and these logs are being stored somewhere using continuous monitoring. So your production server is continuously monitored for any kind of activity which is happening on it, and the logs are being generated. Now, the developers, the team, now when I go back to the developer, why am I coming back over here? Because this identifies, or this tells us basically now that now when the development team is done with the release and now they have to see what other work I have to do, all they have to do is check the logs from the continuous monitoring tool, right? And they'll be able to identify, so okay, so this and this is causing a problem, this and this is causing a problem, and also the users are saying that, you know, we should have this feature. The client also came in, he also wants some features, so they plan a release, right? And once they plan a release, they again start coding, and again once they're done with the code, they'll push the code to version control system, which will be identified by the continuous integration tool, which will then automatically test it. Once it's been tested, if it's successful, it will push to the production server. Again, the logs will be identified by the continuous monitoring stage. Again, it will go to the developer after planning, and then he'll code his way into version control system, and the life cycle goes on and on, right? So this is exactly how DevOps work, right? Now let's look at each of these stages independently to understand what exactly happens in continuous development, what exactly happens in continuous integration. Okay?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
So in continuous development, you basically push your code to a version control system. The version control system could be a software like Git or a software like SVN, right? Now, when the moment you push your code to the version control system, it basically creates a new version of your code. For example, if you wrote ABC on a text file, right? Now that ABC you wrote and you uploaded on the version control system. So this was the first version. The version control system automatically makes it version 1. The moment you make some changes and again push it to the version control system, what happens is it creates, the version 1 was the text file having ABC. Now the new version that you have pushed, it becomes version 2 and the file would be ABC and probably whatever changes you have made to the file. Okay, so it creates a new version, and at the same time it also holds on to the previous version, so that in any case, in any problems that you might have in the future, if you want to revert back to the previous version, you can easily do that, right? And that is why we have version control systems like Git and SVN. And continuous development is an integral part of pushing code to your version control system. Okay. Now this was continuous development. Then you have continuous integration. Now what is continuous integration? This is nothing but integrating your life cycles with each other, right? For example, once you push the code to your version control system, it obviously has to be picked up and pushed onto the testing server for testing, where it could be built and tested, right? So all these life cycles are integrated, or there is someone who is doing the manual job of a person of taking code from one stage and pushing it onto another, then taking the results from there, pushing it onto another, then taking the results from there, pushing onto another. And that manual effort is being done by a tool which is called the continuous integration tool. Okay. Then you have continuous deployment. Continuous deployment basically means you will deploy your code onto a particular server. It could be a testing server, it could be a production server, and deployment basically involves putting the right kind of software on it and then pushing the build onto your server so that it has the right software environment where it will function, right? And again, installing softwares on system and everything is also automated using a tool which is used in continuous development lifecycle. Okay. Then we move to continuous testing. Now, continuous testing is again a lifecycle stage wherein you continuously test your software. So like I told you guys, in this, what happens is you continuously build and then test your code. So your code is pulled from the version control system. It is built. So when I say built, it basically is converted to an executable file, and this executable file is then run, right? Now the continuous testing, how it happens is you create testing suites, which are basically pre-installed in the testing server. And the moment it gets a new executable, all those test suites are executed on this particular executable file to check if all the tests are passed or not, right? And if all the tests are passed, it is then again picked up by the continuous integration tool and then pushed onto the production server. Once it reaches the production server, again it gets monitored, right? It gets monitored for user activity, it gets monitored for any errors, it gets monitored for any user comments on version upgrades, right? On version upgrades, or you can say any feature requests. So all those feature requests, all those errors, all those logs are then visualized or then are then stored inside a monitoring tool, right? And this monitoring tool helps us in sorting these logs based on what we want. It'll basically sort it on the basis of general logs, it'll sort it on the basis of error logs, it'll sort it on the basis of feature requests, right? So it becomes a one destination stop for you where you can check and plan your day ahead or plan your team's work for the near future. Okay, so this is continuous monitoring. So these were all the life cycle stages of DevOps, guys, and this life cycle stages basically make it possible for us to have shorter release cycles because all these stages are automated, right? And these are automated using tools, and these tools we'll be discussing in our next session, where we'll get an introduction to all the tools which basically come together to create a DevOps. Right. So far we have discussed the DevOps methodology, how the DevOps lifecycle work, but they are incomplete without their respective tools, which will map to each of the lifecycle stage in the DevOps lifecycle. Okay, so let's go ahead and start discussing these tools with their respective stages. So the first stage that we saw was continuous development. Now, continuous development is implemented using version control systems, like I told you guys, and in most of the companies, the most used version control tool is Git. All right. So Git is a version control system which we'll be also using in this course, right? And it is basically used when multiple people are working on one particular project. Right, so it is great for team collaboration. It is great for tracking changes, and is absolutely awesome on command line. All right, so this is what we are going to learn in this course. So for Git maps to the continuous development lifecycle stage, then we have continuous integration. Now, you heard a lot about this continuous integration tool when we were discussing in the DevOps lifecycle, and the tool is called Jenkins, right? So Jenkins is basically an open source tool, right, which is used to implement the continuous integration features that we saw in the DevOps lifecycle. So in this course, we'll be learning Jenkins, and there is a separate module on Jenkins that we'll totally devote to explain different features that you can explore in Jenkins, right? The next stage is continuous deployment, and continuous deployment basically means two things. It means configuration management, and it means virtualization and containerization. So we use Docker for virtualization and containerization, and what exactly Docker does is, so the problem of running your code on one system and not being able to run on another system is what is solved using containerization. So what containerization basically does is, it wraps your code along with the software dependencies, and all these software dependencies and code is wrapped around by a container, right? So a container is a physical entity which will basically wrap your software dependencies and your software, and it will, if you run that container on any other system, it will run as if it is running on the same system that is on the developer's computer. So a container is an executable form of an operating system which can be run on any system. The only pre-requirement is that you should have Docker installed on it, right? Similarly, you have configuration management. Now configuration management, what is configuration management exactly? So say you have a computer, you have a freshly set up computer on which you have some operating system installed. Now if you want to test your application on that system, what you have to do is you first have to install all the softwares on it, right? For example, like I said, you would need Docker for your container to run. You probably would need an Apache server. You would need Python, or all these softwares which have to be installed can be installed using configuration management without even touching that remote computer or that freshly set up computer. And that is possible using tools like Puppet and Ansible, more of which we will be seeing in our course as we progress in our number of modules. All right. Our next stage is continuous testing. Now, continuous testing, as we learned, was all about creating testing suites which would automatically test your code once it gets built on your system, right? So all these automation testing suites can be created using the Selenium software, right? So we will be learning the Selenium WebDriver in this course as we move along, and we will see how we can create our automation suites in Selenium for testing our applications. Okay, so this was about continuous testing, and then next we have continuous monitoring, wherein your application is continuously monitored and the logs are created. Any errors are also monitored, right? So all of that is done using Nagios. So Nagios basically gives you a dashboard with all your services listed on it, and those services can exist on any system outside the network or inside the network, and all these services running on it can be seen on the Nagios dashboard. Okay, so it's a great tool for monitoring your application. It's a great tool for gathering user data or user activity data at a one-stop destination. Okay, so that is what Nagios is all about. And this brings us to all the tools. So these were all the tools that we will be discussing throughout the course, right? And this brings us to the DevOps tools lifecycle. So you saw the DevOps lifecycle earlier, wherein you had a developer and the developer was basically pushing code onto a version control system. This is a replica of that figure, and in this figure we have just replaced the tools with the life cycles. All right, so now what the developer does is he pushes his code to GitHub. From GitHub, Jenkins automatically detects that on GitHub your code has been changed. It pulls the code and pushes it onto the testing server, and it installs all the softwares required on the testing server, and the testing suite that has been built on the Selenium is already present on that testing server, right? So Jenkins pushes the code here, the code is built and tested over here. If it goes successful, Jenkins again pushes the code to production, right? And on the production server, Nagios continuously monitors it for user activity, how many users are logged on, what the users are saying about it. All of that information is saved inside Nagios, and that information can actually be seen on the Nagios dashboard by the development team, and they can make a plan for the next release, what all features they have to include, what all fixes they have to do, right? And once you do that, you again start on with your next release. So this is what you do when you are working with the DevOps tools, and this portrays the whole DevOps lifecycle that we have in a company, in any arbitrary company which is using DevOps.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Let us get introduced to Git, but before that, let us understand why are we only learning Git? Why not some other tool, right? Like I told you guys, there are a lot of distributed version control systems out there. Why are we only learning about Git? right? So let me just compare it on Google Trends, and this is the result that I get. Right? So if I search for Git, Perforce, and Mercurial, which are actually the top 3 distributed version control systems out there, you can see that the Git tool is the most famous among them all, right? So that basically means that if you learn Git, you have a high chance that you might land up in a DevOps job more if you know Git than Mercurial or Perforce. Because Mercurial and Perforce, because the popularity is low, we can easily conclude that not much of the companies are using these two tools, right? So most of the companies are using Git. In my experience also, I've seen most of the companies do use Git, right? And that is the only reason we have included Git in our course, and that is the reason we are learning Git also today. All right. So moving forward, now let us see what Git is exactly. Right? So Git is a version control system. It's basically a software which falls under the architecture of distributed version control system, right? And it does the same things which any other version control system does. That is, it tracks changes, it keeps your files versioned, right? And because it's distributed, you have a local repository as well, and then you also have a remote repository. Now in case of remote repository, you get a lot of options, guys, but in our course what we are going to do is we're going to opt for a free option, which is GitHub, right? So you might know GitHub is famous for all the open source tools which it hosts, right? So we are also going to work with GitHub, but for now we are going to just focus on Git. First we're going to understand what Git is, and then probably later we'll see how we can use GitHub in conjunction with Git. All right. Our next session actually is going to talk about the life cycle of Git. So we have understood, why are we actually learning Git? We understand what Git is exactly, but we do not know how it exactly works, right? We know the architecture, but we do not know how it works. So basically we've divided all the commands that you could be used frequently or you will be using frequently among these 4 domains, right? The first domain is about creating a repository. So we'll be discussing some commands which will help you create a repository in Git. Then we'll be dealing with commands which can help you make some changes in Git. Then we'll be dealing with commands which will help you do parallel development in Git. And then towards the end, we'll also be learning commands which will help you in syncing your repositories. Okay, so let's discuss each of these domains one by one. So let's talk about how to create repositories. Let's start from the scratch, right? So our first, whenever you start a project, the first thing that you have to do is you have to go to your working directory and you have to do some code or make some code, right? So the first thing that I'm going to do is let me just switch to my terminal. Alright, so this is my terminal and I'm logged into an Ubuntu server. So what I'm going to do is I'm going to create a directory which is say called DevOps. Okay, so let me create a directory called DevOps and let me just cd into this directory. Okay, so I'm into this directory now. Let me just clear the screen. Now let us add some files. Say I add a file called nano. Let me add a file called 1.txt. Okay, and let us say hello world in it. So this is our first file. Okay, now let me add one more file. Let us add a file called nano2.txt. Let's say hello from Intellipaat. Okay, so this is a file that we have added now. Let's save this file. Okay, so now we have 2 files which are there inside a folder DevOps. Okay, so this is not being tracked by Git as of now, right? But it is still our working directory. Now for making it a Git initialized working directory, all I have to do is type in git init and hit enter. Okay, and now we have an initialized Git repository in front of us. Okay, so this is how you can initialize a directory in Git. So now you have created a repository in which you have your code which will now be tracked by Git. Let's come back to our slides. So this is exactly what we wanted to do. We wanted to initialize a Git repository and we have done that. We have added some files in that directory. Now let's go ahead and see what our next command is. So our next command is about knowing the status of what are the files doing in that directory. Are those files saved in Git? What is the status of that directory? And the command for seeing the status of directory or the files inside it is the command git status. So let us quickly jump back to our terminal. Let me just clear the screen. And now if I want to see if my files are being if my files are saved in Git, what exactly is happening with my files. So what I'll do is I'll just type in git status and I can clearly see that my files are right now untracked. Okay, Why are they untracked? Because I've not staged them yet. These are just files which the Git is seeing that they exist in the directory, but they have not been added to my file system yet. So this is what Git is telling me right now. Okay, and it is also telling me if I want to track these files, all I have to do is git add and then the file name. So I don't want to do that right now. So let us go back to our slide. So this is what git status does. It basically gives you a status of your repository or of your directory. What are the files which are in the directory? I mean, what is the status of those files? Okay, so we got the status. Our next command is about adding, right? So basically we have made some changes to our file and now we want to add it into a repository. And for doing that, all I have to do is just go back to my terminal and I'll say git add. I can either type in the name of the files. So say I want to track both the files. So I'll just type in 1.txt or 2.txt. You type this, or what you can do is you can just type in git add and then a dot. Dot means track all the files which are present in this directory. So I'll hit enter. And now if I do a git status, let me just clear the screen. If I now do a git status, I can see that my files are now being tracked. Okay, so my files are now being tracked. They are staged, right? So if you think about the life cycle, you were in the working directory. Now you are in the staging area. You have staged your files. You want these files to be saved in the Git file system. They're still not saved. They're still in the staging area. The next step is saving these files in the Git file system. And for doing that, the command is git commit. Okay, so how do you type in the git commit? You type in git commit, then you give a space -m flag, which basically means the message, and then you type in the message that basically would point to what you are basically doing in that commit. For example, in this case, since this is our first commit, we can simply type, let me just clear the screen, git commit -m. We can say this is our first commit, adding 1.txt and 2.txt. Okay, so this is what we do. We just hit enter, and now you can see that my files have been committed to Git. Okay, and now if I do a git status, now, you can see it says on branch master there is nothing to commit, working tree is clean. That basically means all the files which are there in this directory right now are clean. They are all saved in the Git file system, and there's nothing to worry about right now, right? So now let's do a little experiment. What I'll do is I'll add one more file. Let me just create one more file, and let us name this file as 3.txt and type in test file inside it, right? So now what happens? So if I do git status, you can see it will say that 3.txt is a file which is untracked in Git. Rest all the files which are there, it is not listing that because those are already saved in Git, and they are there's nothing changed to those files. Also, let us try by changing the 2.txt file, which is not listing over here, right? So what we'll do, we'll just do a little change to it. Let me just add 1 to over here. Let us save it, and let me do a git status now. Let's see what happens. So if I do a git status now, it can see there's a modified 2.txt file, and there is an untracked file which is 3.txt. Okay, so this is something what you get. So any changes that you do to a file, it will be reflected in the status of Git. Now if I want the 2.txt file to be saved, I have to stage it again, and then I'll have to commit it. Okay, that is the only way I can modify the 2.txt file. Okay, so let's come back to our PPT now, and let's go ahead and see what is our next command. So our next command is about syncing repositories. So now we have committed the files to our local system, but how do we make it available to the world, right? So for making it available to the world, the first thing that you have to do is you should have a Git repository. Okay, so let me just jump on to my browser, and then I'll show you how you can create a Git repository. So just give me a second. Okay, so guys, you just have to sign up on GitHub, and once you sign up, this is how your page would look like. Now what I want to do is I want to create a new repository. So on your left hand side, you will see a button called new repository. Just click on that, right? And now let's name our repository something. So let us name it as DevOps and course. Okay, so our repository name is DevOps Course, and the type of this repository is public, and let us just now click on create repository. Okay, so our direct repository has now been created, and now what I have to do is I have to copy this link. This is a HTTPS link, guys, so I have to copy this link. Let us copy this link, and now let's come back to our PPT to see what exactly we have to do. Okay, so now to add files to this repository or to push files to this particular repository, first I have to add it in my command line. Now for adding this repository in my command line, I have to type in the command git remote add origin. Okay, this is the command git remote add origin and then the URL to the repository. So let us do that in our terminal. So I'm here. So right now when I'll commit, basically my 1.txt and 2.txt will be saved. My modified 2.txt file and my 3.txt will not be pushed. Okay, so let us see if that happens. So now what I'll do is I'll type in git remote add origin and then the URL of my repository. So the URL is this. Let me copy that. This is the URL and I'll hit enter. So now my files or my origin URL has been added in my command line, right? It has been saved in this git repository, my command line that is working on my git repository. Okay, so now let's come back to our slide. So we have executed this command. Let's see what our next command is. So our next command tells us how to push files to my URL, right? So the command is git push origin master, and see guys, this is the output for your command. Now when you type in this command git push origin master, it will ask you for your username and it will ask you for your password. So let us do that. So let me come here and let me type in the command. So the command is git push origin master. Okay, I typed in this command. It is asking my username. Let me enter my username. It is asking my password. Let me enter my password. I'll hit enter, and as you can see, it is pushing the files, and now my files have been successfully pushed to my repository. Let us check that. Let us come back to our browser. Okay, and let us refresh the page. So as you can see, it just says 6 minutes ago the files were committed to the repository and now they have been pushed, right? And over here you can see the message of my commit, which was first commit adding 1.txt and 2.txt. So you get the message over here. Here are the files, so you can see the changes or you can see the content of the files as well. If you click on 1.txt, my 1.txt had the content hello world, so it's being reflected here. Similarly, if I want to see my 2.txt, I can see that it says hello from Intellipaat, right? So everything is here, everything seems to work fine. And again, what I can do is now if I do a git status, you can see that there are two files which have not been added. So what I'll do is let me first make or let me add first the 2.txt file, that is a modified 2.txt file, into my git repository. So what I'll do is I'll type in the command git add 2.txt. Let me hit enter. So now this file has been staged, right? So if I do a git status now, I can see that this file is now staged. Okay, but this is still untracked, so we'll deal with this later. Okay, so now I have a modified 2.txt file and all I have to do is git commit, and now I'll specify the message as modified 2.txt. Okay, so this is the message that I'm passing. I'll hit enter and now my file has been changed, but these changes have now been done to my local repository, not to my remote repository. So if I come back to my browser and if I refresh, you can still see the file which was added to 2.txt. It still says hello from Intellipaat and it was committed 8 minutes ago, right? So it still is not added to my remote repository. Now to add it to my remote repository, all I have to do is git push origin master. Okay, I'll hit enter. It will ask me my username. I'll provide the username and the password. And now my files are being pushed to GitHub. It has successfully done that. And now if I do a refresh over here, you can see that it says that 2.txt was committed a minute ago, right? And you can see the message over here. It says modified 2.txt, right? And this is exactly what we did. So we have added the second file as well to our remote repository. Let's add the third repository file as well, which is the 3.txt over here. So we'll do a git add dot git commit -m adding 3.txt, and now we'll do a git push origin master. We'll give the username, we'll give the password, and now my file has been pushed. And now if I do a refresh here, I can see even 3.txt has been added with the commit message adding 3.txt. Okay, so guys, this is how you can push your files, or you can sync your remote repository to your local repository. Okay, so this was the command for that. Let's move forward now and let's check whether this step I've already done. So basically you can see that I have now synced my local to my remote repository. I have as you can see in the browser. Okay, now let's go ahead and see what our next step is. So our next step is to basically show you guys how you can clone a repository. Okay, so this is when I have basically I have pushed my local repository to my repos repository. Now say you are another developer who wants to work on this code. Now how can you work on this code? All you have to do is click on clone or download and just copy this link. Okay, copy this link, go to your terminal, right, and let me create a folder, say test over here, and let me create a folder called test over here, and let me go inside the test folder. Okay, now what I'll do is I'll type in the command git clone and I'll give the URL and I'll hit enter. Now what it has done, it has successfully copied the directory over here. So if I do an ls, I can see that the directory has been copied, or my repository has been copied to my local. Okay, and the awesome thing about this is, now if I go inside DevOps course, the directory, now over here I don't have to basically add a remote origin, right, because you have cloned the repository. So this directory automatically knows where, if I push any file, where it has to go. For example, if I create a file, say I create a file nano4.txt, I say test file for clone. Okay, I'll say that, and now what I'll do is I'll add this, I'll commit this file, adding clone file. Okay, I'll hit enter. So my file has been committed, and now I'll do git push origin master. I'll give the username, I'll give the password, and as you can see, my file has now been pushed automatically. Okay, so if I do a refresh here, 4.txt has automatically been added, and I did not do a git remote add origin even if I am in a different directory. Okay, now let me show you what I exactly mean. If I create a folder, say I create a folder called test. Okay, test exists. Let me create a folder called hello. Okay, and if I go inside hello, and if I do a git init, say I did a git init, and now let me say create a file called hello world.txt. Let me add any arbitrary text into it. Now if I do a git add dot, and if I do a git commit, and I'll say let's adding file. Okay, so the file has been committed. Now if I do a git push origin master, it'll give me an error. See, it says origin does not appear to be a git repository. Why? Because I'm in a separate directory right now. Okay, now if I do a cd, I go inside test, which was my first directory where I created all the files. So over here, if I do a git push, if I add a file, say let me first pull everything. Okay, so because the git pull origin master. Okay, 1 second guys. Okay, so I think this is now the repository. Okay, so the repository was DevOps. So let us go into inside DevOps, and let me just create, or let me just say git pull origin master. So this was the directory where we first created our code. Okay, let me hit enter. So now it has, as you can see, it has added 4.txt to it, because earlier we added in a separate folder, right? So now it has created 4.txt inside it. It has added 4.txt inside it, and if over here you can see I have not specified what origin is. It automatically knows what origin is. Why? Because DevOps is a git initialized repository. Okay, similarly, when I said that hello is a git initialized repository, but in hello, I'll have to specify what is the origin of that repository, right? But if I do a git clone as I did in test, right? I went into test and I did a git clone of the DevOps course. When I do a clone, it automatically copies the parameter as well as to what my origin repository is. Okay, any files that I add, if I push it on origin master, it will know where exactly it has to go. Okay, so this is how git clone can be helpful to you. All right, coming back to our slides. So now we know how to clone a repository in Git. We also saw how to pull, files in Git, but let me show you again. So basically what we want to show you is that say you are inside this folder, DevOps course, which is the same repository as what you have. Let me just duplicate this session.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Alright, so this directory, which is DevOps, is pointing to the same repository as DevOps course. Okay, now if I do an ls here, I can see that there are 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. Similarly, over here I have 4 files: 1.txt, 2.txt, 3.txt, and 4.txt. What I'm going to do is let me add a file from here. So nano 5.txt, and let me say test file. Okay, I've added it. Let me say git add dot. So I've staged the file. Let me commit the file. Test. Okay, I've committed the file, and now let me push the file to my remote. So I'll enter the username, the password, and now my file has been pushed. Okay, so if I have updated my remote repository, this local repository of mine will not get automatically updated. As you can see, it will not get automatically updated. If I do an ls over here, I can see there are 5 files, and if I go here on my remote repository, if I refresh, I can also see here are 5 files. But imagine this to be one developer and this guy to be another developer. Now this developer will not have the updated files till he does a git pull. Okay, so if he wants also the updated files which have been put on my remote repository, all he has to do is he has to type in git pull origin master, hit enter, and now the files will be updated in his system. Okay, so if I do an ls now, you can see that 5.txt file has now been added to this directory as well. Okay, so for coming back to our slides, so git pull helps you in updating your repository to the latest commit which is available on your remote repository. So that is what git pull is all about. And the difference between git clone and git pull is, like I told you guys, git clone is basically used when you want to copy the whole repository at your local system. But if you want to update repository when you're working in it, if you want to update all the files which are inside it, you can use git pull. In that case, git clone will not serve the purpose. Okay, moving forward, now let's talk about branches. Now as you can see, now we are talking about parallel development. Okay, and as we learned in our previous topics or previous sessions, that if you want to do parallel development, or if you want to assign code to multiple developers, you basically branch out, right? You create a branch in your repository and you assign that branch to the developer who would be working on the code. Okay, so let us see how you can create a branch in Git. So for creating a branch in Git, this is the command: git branch and then the name of the branch. Okay, so let us see if we can create it over here. What I can do is, let me just clear the screen. Okay, and let us say I create a branch which is something like this: git branch and say I create the branch feature 1. Okay, so the branch has now been created. Now if I want to list all the branches which are there, I'll just have to type in git branch, and I can see there are 2 branches in my repository now. One is called the master branch and the other one is called the feature branch. Okay, now any developer who wants to work on this code can basically work on this branch, and when he feels that his work has been finished, he can basically merge this branch to master. And merging means that whatever code you have added to feature branch will also be added to the master branch. Okay, don't worry if you're not understanding as of now, you'll understand as we move along. Okay, so I have added a branch feature 1. Now if I want to delete a branch, again all I have to do is git branch -d and then feature 1. Okay, so it says deleted branch feature 1. That's it. Okay, so now your branch has been deleted. Okay, and this is exactly what we wanted to do. Moving forward, now if you create a branch and you want to switch to that particular branch, the command is git checkout. Okay, so now let me create the branch again, git branch feature 1. So I have created a branch, and what happens when you're branching, basically the last commit of your master becomes the first commit of your feature branch. Whatever you have created, whatever branch you have created, the last commit of your master becomes the first branch of your branch that you have created. Okay, so for example, in my master you can see that there are 5 files. So now if I go inside, if I do a git checkout into feature 1, so basically now I have switched to the branch feature 1, and if I do an ls over here, you can see there are 5 files. Okay, now what I want to do is I'll add a file. Say I add a file 6.txt over here. Okay, and I say hello world. Okay, and what I do is I save the file, git add dot, I stage the file, and now I commit the file, added to feature branch. My file has been committed, and now if I do an ls, I can see there are 6 files now. But mind you guys, this is not on my master branch. Now if you want to see which branch you are on, just type in git branch, and you can see you are on the feature branch right now. Okay, now what I want to do, I want to check if my master branch also has these changes. So what I'll do, I'll just switch to my master branch, git checkout master. I'm on my master branch now, and if I do an ls over here, you can see that the 6.txt file does not exist here. Okay, reason being, my feature branch is isolated from my master branch. Whatever changes I'm doing on my feature branch, it will not get reflected on the master branch, whatever I do. Okay, and whatever I do on my master branch will not get reflected on my feature branch. It works vice versa. Okay guys, so this is a feature which you basically use when you want to do parallel development, so that no branch is it is interfering with each other. So now I don't care what my developer is doing on feature 1. When he says that the feature is complete, I'll ask him to show me, and when he shows me the feature and I feel it's right, what I can do is I can merge it with my master so that it becomes available to the world. Okay, all right, great. Now if I do a git status here, git status, one second, git status, it says on branch master, nothing to commit. If I check out to feature, yeah, so if I have switched to feature now all I have to do is I will type in git status, and it again says on branch feature 1, nothing to commit. Why? Because I've already committed 6.txt to it. Now what I want to do is I want to push these changes to my remote repository. So what I can do is git push origin feature 1. Why? Because now we are pushing the feature 1 branch. We are no longer pushing the branch, the master branch. We are pushing the feature 1 branch, right? And I'll hit enter. So it'll ask me the username. I'll hit that. It'll ask me the password. I'll put that, and I'll hit enter. And now you can see my files are being pushed. And now you can see that feature 1 branch has now been pushed to feature 1 branch of my remote repository. So if I go to my browser now and I refresh it, you can see the 5.txt is still not visible here. Why? Because I'm on my master branch. I'll click here. I can see that I have a feature one listed over here. I'll click on that, and now I can see that the 6.txt file is visible here, and with my commit message which was added to feature branch. Okay, so I can again switch to my master branch, and I can see that my master branch is clean. If I switch to my feature branch, I can see that my feature branch is having the 6.txt file. Okay, let's come back to our slides. Alright guys, so we now know how to switch to a particular branch. Now let's go to our next slide. Now we probably know all the commands through which we can probably start working on Git, right? This command is a very important command, which is git log command. Now what is git log command? Now git log command helps you to see the history of your repository, like what all have you done on your repository. Okay, now to see the history of your repository, the command is git log. Now let us go back to our terminal and let us just clear the screen. Now if I do a git log here, I can see the history of all the commits. Okay, so I can see that I am on my head is on the feature branch right now, right? And I can see that the last commit was this, when I added 6.txt to the feature branch. Before that I had a test commit. Before that I had a clone file that I added. Before that I had some other commit, 3.txt, 2.txt, right? So similarly I get everything. I get a history of everything that I've done so far, right? And these are all the commit IDs, guys. This is what we studied earlier, right? So if I want to say revert to this commit, all I have to do is just copy this commit ID and I have to type in git revert along with this ID, and I'll be able to revert to this particular commit. But we'll do that later. We're not doing that right now. We'll do that later. But this is the history of your branch. Okay, now if I want to see the history of master, this is the history of feature one. Okay, let me just clear the screen and let me see where I am right now. So I'm on feature one. So if we go to git checkout and then master and then clear the screen, if I do a git log over here, you can see that the head is now on the master, and only the log of the master branch I'm able to see right now. Okay, I cannot see the log of adding the feature file. Why? Because I'm on the master branch now. So whenever you do git log, you always see the log of what branch you are on. Okay, so right now I'm on the master branch, and that's why I can see all these logs. If I am on the feature branch, I can see all the logs of the feature branch along with the logs of master branch when the branch was when basically the moment I create a branch in my repository, it gets created from the master branch, right? So say I did 3 commits before I created a new branch. Those 3 commits will also be a part of my new branch that I've created. And if I go inside that branch and if I do a git log, I would be able to see those 3 commits in the log as well. Why? Because those 3 commits are also a part of those of that particular branch. Okay, so but the moment I do any other commits on master, those logs of that commit will not come in my feature branch. Reason being, now my feature branch is separate. All right, so I hope this is clear. All right, coming back to our slides, guys. So we now know how to see the history of our our git operations. Our next command deals with git stash. Okay, so what is git stash? So whenever you're working with multiple branches, there could be a point where you don't want to basically commit the file is basically still not complete, right? But you want to switch to another branch because you want to probably fix something in some other branch where you're having a problem, right? So basically it's about multitasking. It's about putting on hold the work that you're doing right now, completing the work over there, and then coming back here again and then starting with your work, right? So let me exactly first show you why do you need the git stash command. Okay, so if I'm over here right now, let me just clear the screen. Okay, so let us see where we are right now. So if I do a git branch, I can see I'm on the master branch right now. Okay, so what I want to do is I want to create, or let me just switch to my feature one branch, and let me create a file called 7.txt. Let me name it as stash file check. Okay, so I have created a file, but this file is still not staged. It is not committed yet, right? So I am on my feature branch right now. So if I do an ls, I can see 7.txt is here. Now, if I change my branch, what will happen? Let us see. So if I do a git checkout master, and now if I do an ls, you can see the 7.txt file over here. Why can you see the 7.txt file? Because this file is not being tracked right now. It is not a part of any branch, right? Because it has not been saved yet, correct? So what I can do, so let me just come back to my feature branch. What I'll do, I'll just add, or I'll just stage this file. So let's see what then happens then, right? So I'll do a git add dot, right? And now the file has been staged, but it's still not committed, right? So if I do an ls now, it has all the files. Now if I check out to my master, and if I do an ls here, I can still see this 7.txt file. Now this can become a problem, or this might cause a confusion when you're working within branches or when you're working with production code, because you don't want this file to be here when you're on the master, right? Because you don't want your code to go haywire or cause a problem because of an extra file, or probably you changed something in 5.txt. Let me give you an example. Let me check out to my feature 1, okay, and let me go to 5.txt. So this is my 5.txt, and it's there in the master as well. Let me change the contents of this file. Okay, so I've changed the contents of the file. I'll stage it, okay, and I'll do a git checkout master. Okay, I'm on my master branch now. I'll do an ls, and now if I do a cat of 5.txt, can you see these changes are also there in the master? I don't want that. I don't want that to be reflected over here, because my feature branch should be different from my master branch. Now to avoid this confusion, although this file is not saved on the master yet, right? It is just being reflected over here. Reason being, these files are not committed to your branch in your respective branch where you were working. Okay, so how can you avoid this? Now the way to avoid this is, you would just check out, or you would just check out to your feature branch where actually you want this file to belong, okay, and it tells you that these two files are there which this has been modified and this has been added, okay. So it gives you a notification, which is good. Now what you'll do is, you'll say git stash, you'll just say this and hit enter. Now what will happen? Now if I go to my master, git checkout master, okay, and if I do an ls, I can see the 7.txt file is no longer visible over here, okay. And also if I do a cat on 5.txt, I can see this is the original file that the master should have, right? Now say I wanted to do something in my master branch. I'm done with that work. Now I want to get back to the work that I was doing in the feature branch. So what I'll do, I'll just do a git checkout feature 1. I'm back here. I'll do an ls. So right now the files will be not saved. So if I do a cat.5.txt, it will still be the test file. It will still show me the committed version of the file. I mean, if I want to restore the files that I was working on, all I have to do is git stash and then pop. This is the command to basically come back to your working state. So I'll hit enter, I'll clear the screen, and now if I do an ls, I have 7.txt, and if I do a cat on 5.txt, I can see this is the modified 5.txt. So I'm now again in my working state. If I do a git status, it will show me that my files have been staged, but then they have to be committed now. Okay, so now all I have to do is, I'll say git add dot, and now I'll commit these changes, committing stashed changes, and now these changes have been committed to my feature branch, right? And now if I do an ls, if I do a git status, I can see that my branch is clean. and I can now easily just go back to my master. I don't have to stash anything anymore. And if I do an ls, it is still isolated. Reason being, everything is committed to the branch now, and there is no dangling files here and there, which could confuse me with the files that I'm working in whichever branch I want. Okay, and this is why we use the git stash command, so that we don't have any confusions. The files don't get mixed up with the files of other branches, and we don't get confused. Okay, so guys, this was the git stash command. Let's see what our next command is. So our next command is git revert. Okay, so this is an awesome feature of git. So let us come back to our terminal. Okay, so what I want to do is I'll just do a git log, and I have all these commits over here, right? So I want to go back to my first commit where I just had my 1.txt and 2.txt. Okay, I want to go back to this commit. So all I have to do is I'll just click, or I'll just copy this commit ID, right? I'll clear the screen. I'll do a git revert, and I'll just paste that commit ID, hit enter. Alright, so let's go back to our terminal. Alright, so now for doing this, let us first see where we exactly are. So we are on the feature 1 branch. Awesome. So now we want to revert the changes, right? So for reverting the changes, the first thing that you do is you see the log. So right now the logs is that the last commit that was made, on which the head is right now, is this commit where we added these stashed changes. See, this caused a problem in my code.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
And I want to revert this. So I want to revert this commit. So whatever changes I'm doing in this commit will be undone, right? Now for doing that, all I have to do is I'll copy this commit ID, okay? And before just doing everything, let me just do an ls. And I can see that I have 7.txt, which I added in my stash changes, right? So what I'll do is I'll just do a git revert, and I'll paste the commit ID, right? So let me just take the commit ID from over here, done, paste it here, hit enter, and now you can see it will say your 7.txt will be deleted, and we modified 5.txt, remember, right? So my file which was modified 5.txt will also be reverted. So these will be the changes which will be committed once I revert from this commit. So I'm like, okay, so I want to do this. So I save it, and now if I do an ls, I can see that 7.txt has been removed, and my file also which I had modified has now been changed, and you can see the changes over here. So that 2 files have been changed, 1 insertions and 2 deletions, and this is it, right? This is what just happened. And if now I do a git log, you can basically just see that when I did git revert, it basically committed a new thing on my feature 1 branch. It committed a new file on my feature 1 branch with the message revert of committing stashed changes, right? And it says this revert commits 9A6090. So basically it undid the changes which I did in this particular commit. Now if you still want to go back to this commit and see what changes have actually been done, what you can do is, if I want to go to this commit, all I have to do is just copy this commit ID, and now I'll type in git checkout and then the commit ID. Okay, so now I'm in the stashed commit, right? So now if I do an ls, I can see that 7.txt is present, right? Now what I want to see is what all things did we modify. I think we modified 5.txt, so let's do a cat on 5.txt. So I can see it says test file 12, and here is my 7.txt, which I do, if I do a cat, it will say stash file check. Okay, now what I'll do is I'll say git checkout feature 1, so it will again return to the latest commit on my feature 1 branch. So I'm returned now. If I do an ls, I can see that 7.txt file is not there. If I do a cat on 5.txt, I can see that it has again returned to test file. So my changes which I did over here, that is I changed file in my commit of stash changes, that is I changed the file content to test file 1.2, and I created a file called 7.txt which I had stash file check. I had reverted this commit, and reverting means undoing the changes that you did in that commit, right? And it undid the changes that I did in that commit. So I don't no longer have 7.txt which I created, and I no longer have the contents of 5.txt to be the same as what was there in that particular commit. Okay, but remember guys, you still have that commit in your logs, and if you want you can go to that commit and see what all things you want to fix, right? It's right here. But the head of the feature branch has now changed to a new commit which basically has undid changes or undone changes of what was there over here. Okay, sounds great. So this was all about git revert. All right, moving forward, the next command is git diff. Now git diff basically helps us in understanding what all has changed, right? What is the difference between two files, or what is the difference between two commits, what are the difference between two files? You can all see that using the git diff command, right? For example, if I come back here and I want to see the differences between what I did over here and what I did over here when I actually committed the stash. So we can do that. Let us see how we can do that. So I'll type in git diff, okay, git diff, and then I'll type in this commit ID which is my head right now, and this commit ID which was which I basically reverted. So I hit enter, and it will tell me that what all did change from both these commits, right? So it says that you have modified 5.txt. So there are two versions of 5.txt, a/5.txt and b/5.txt, right? So the a file was deleted and the b file was added, and it also shows the content, what content was changed and what content was added, right? So if I am comparing the head with my previous commit, it says basically this file was changed and this file was added, right? And if I see over here, it says that there was nothing before and then we added 7.txt. Okay, now if I do the same by reversing the order of the commits, let's see what happens. So what I'm gonna do now is I'm gonna say this is the commit which I want to check the difference with this commit. So now you can see that it says that test file 1.2 was removed and test file was added. Similarly, 7.txt was removed and null was added. Okay, so basically this should be your newer commit and this should be your older commit, and then it will tell the difference according to that, right? Similarly, if I want to do this, so I want to first check if everything is fine. So let me do a git status. Okay, so everything is committed on my feature1 branch. What I'm gonna do is I'm gonna change something in 4.txt file. Okay, so what I'll do is I'll do a nano 4.txt, and let me change the file content to test file for diff. I'll save it. Okay, sorry. So alright, so let's call this file as test file for diff. I'll save it. Okay, the file is now saved. I'll do an ls. So now my 4.txt file has changed and I can see that in git status. Okay, but I want to know what exactly changed. So what I can do is I can do a git diff with my head. So head points to the committed version of my branch, and I want to check what is happening currently, right? What is the current in my current directory I have not committed, or I have not staged the file for changes, right? My current directory is different from what is committed on the git file system. So that is what I'm comparing right now. I'm comparing my committed my latest commit with what is there currently in my folder, that is dot. Okay, I hit enter and you can see it says that there is something which has changed in the 4.txt file. So there was test file for clone before, which now has been changed to test file for diff. And this is exactly what I wanted to check. So git diff is basically used to check the differences between two commits or two files. Okay, and this is exactly what we have checked right now. Awesome. So let us come back to our slides. So guys, this brings us an end to all the common git commands that you could be using in your day-to-day life while you're using git, right? In a next class, we are going to discuss the most important topic of git, which is merging, right? Now, before going on to the next slide, I would request you guys, you practice all these commands once on your own. You will understand how things are actually working behind the scenes, right? I've showed you the syntax, I've showed you how it works, I've showed you the results. I want you to practice on your own as well.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, guys, Docker was essentially a need which came out of the problem that we're going to discuss just now. So, imagine yourself as a developer, and probably you're just creating a website on, say, PHP, right? So, if you create a website on PHP, the first thing that you would do is write some code. Now, when you want to test that code, the kind of environment that you would be putting it in, let's see what all components would be there in that particular environment. So the first thing that you would need in this environment that is around the PHP file is an operating system, right? So an operating system which probably would have a browser or would have a text editor, right? So you need an operating system to work on. Now, secondly, because you are developing a PHP application, of course, you need the PHP software installed on that operating system so that your file can actually work. Right? Now, when you're developing a web application on a particular language, it's not just the language which will suffice with what you're doing. You also have to take into mind the third-party applications, the third-party libraries that you would be including in your code, right? So the third component that you would need when you're developing a website are libraries, right? For example, if your PHP website has to connect to a MySQL host, then it would need a PHP MySQL library for connecting to it, right? So these are the components that are basically required by a developer to run his program, right? So what he does is he writes a program, he configures the environment according to the program, and when everything goes fine, his program works well. Now, the problem occurred when this particular program had to be given to someone else. Right? So the developer finished his job. Now it was the job of the tester to check this program. So the developer would give the PHP file to the operations guy, and let's see what the operations guy would do. Now the operations guy in the same exact position that the developer was when he was starting to develop his code. Right? So, but the difference over here is now the PHP file is running. It is just that he has to run this file on the system, on his system. Right? So the first thing that the ops guy would do is replicate the environment that the developer is having, right? So he would get the same OS, the same software, and the same libraries to run that PHP program. Now, there are a lot of versions for a particular software. For example, for PHP, you have PHP 7, which is currently running, but there are companies which are still they're still working on PHP 5.6 because of, probably legacy problems or because the commands have changed. And if they want to move on to 7, they'll have to change all the commands in the code base. There are a lot of reasons, right? So there is a particular version that this company is also following, right? So this ops guy has to have the exact same version so as to make the file work of the developer, right? Now he tried his best possible judgment in it and he installed the PHP software. He installed the libraries, he installed the OS, but still the problem was the ops guy couldn't make the file run. And he came to a conclusion that the code is faulty. But the developer says it ran fine on my system. It's your system which has the problem, so fix it by yourself. So these were some of the statements which were exchanged between developers and operations guy. I mean, if you think about it, it was actually nobody's fault, right? The operations guy did what he could in the best of his ability to replicate the environment, but it didn't work out. Now, you guys might argue that why don't we, use VMs in this case? Probably the developer could work in a particular VM and then just give that VM to the ops guy, and then he can work on the same VM and probably run the file, right? I mean, that is a viable solution. But the problem is the size of VMs is too large to give to the ops guy and give to the testing guy on every feature that a developer adds, right? For in that case, every developer has to have a VM that he's working on, has to have his own version of the VM, because if you are adding, say, feature A, and feature A requires 3 or 4 more libraries that you have included into your particular VM, it'll become inconsistent with what other developers have. Now imagine the ops guy having several versions of VMs and he not knowing what kind of VM he has to impose on the production server or on the testing server, which basically will act as the final version of the image on which all the features of all the developers will work. Now it's a very hectic situation. So the problem was that VMs were very large and they were complex as well to handle when we are talking about staging area or the deployment area, the production area. They were a little difficult to handle. Now, this was the problem that was there before Docker. So, what did we need? We basically needed a wrapper, like in the case of what we just discussed, the wrapper was a VM, wherein it basically contained all the operating system files, all the software, all the code, and all the libraries together, and could be basically lifted and shifted to a different system where it would execute, right? But we needed something more portable, we needed something more smaller that could easily be given to some other person for testing, right? We needed something like that. We needed a wrapper around our files. And the answer to this was this particular scenario, that now if we get a wrapper which will basically contain all the files, in that case each and every environment of ours will become the same. The developer environment is going to be the same, and the moment it gets passed on to the ops guy, he will again deploy the same wrapper, and his problem is also solved because the ops guy does not have to match the versions of the OS, the software, the libraries, because everything is there inside that wrapper, or everything is there inside that container, right? He just has to run that container and he can just see if the code is working properly according to what has been specified or not, right? So the answer was that all the environments, the developer environment, the staging or testing environment, the production environment, all of these environments are now going to be the same, right? And this was possible using Docker. So what is Docker? Docker is basically a software which helps us creating this wrapper around the files of a code, the operating system, and the libraries that we mentioned that are required for a particular code to work, right? But the awesome thing about Docker is that you do not need the environment to be in GBs, right? You do not need it to be somewhere around 900 MB or 800 MB or 1 GB or 1.5 GB. A container could be as low as 50 MB. That is the size of a container called Alpine. It's as low as 50 MB. So it becomes very easy to basically give it to other people to test your code with all the environment set up in that particular container, right? So Docker is a software which helps us enable that. Docker is basically a tool which helps us in containerizing an application, right? And now let's see how basically Docker is doing this. How is it so portable? How is it so low in size? So basically this is the architecture of Docker. So at the base level you have the hardware. That basically means that you'd have a computer, and on that computer you would have an operating system present, right? So this is your operating system. So it's as simple as you have a laptop, and on that laptop you have Windows or Linux installed, right? Now once you have the operating system installed, the next thing is the container engine that you would install. So the container engine is nothing but the Docker software that you would install on top of your operating system, and that is it. Once you've installed the container engine, you can run any type of container that is there in the repository on the or on the web which is available. For example, if your code needs an Ubuntu container, right? All you have to do is write Docker run Ubuntu. And what would it do? It would basically download the Ubuntu container. And then you can add your code files inside that Ubuntu container and start working, right? But how is it low in size? How is it not in GBs when we compare it to the Ubuntu operating system? It's around 800 or 900 MB, right? The Ubuntu desktop version. But how come this container is so small? So the answer for that is the container does not contain all the operating system files, right? So as you can see, the container engine actually shares its space with the operating system. So a container is void, or a container does not have a kernel in place, right? It shares the underlying kernel of the operating system on which the container engine is installed. So if I talk about, say, you have an Ubuntu operating system or you have a Windows operating system, and basically what you do is you download the container for CentOS. So CentOS is basically a Linux distribution, right? So you download the container for CentOS, and now when you're working in that container, you feel as if you're in CentOS. But the point is that the CentOS operating system is actually not installed. What is basically happening is your container is sharing the resources from the operating system, but your container has the minimum binaries and libraries that are required to run the CentOS commands, right? For example, for installing anything on CentOS, you pass the command yum install and then the package name, right? So it would have the yum package in there in the container, right? It would have all the repository URLs there in the container, and that's how it behaves like a CentOS operating system, although the container is nothing but a set of binaries and libraries which are important for the CentOS commands to work, right? That is all what a container is. But with the underlying virtualization of the kernel or the BIOS of the operating system, your container seems to be like an operating system, although it is not. And because of this very reason, that it virtualizes the underlying kernel or BIOS to make it as if it's running on its own, that is it is its own kernel or BIOS, is the reason that the containers are very lightweight, because they don't need to have all the files required for an operating system. They just need the bare minimum binaries or libraries required for that particular environment to work. Okay, so if you again come back to see this architecture, you have the hardware. On top of the hardware, you have the operating system. On top of operating system, you install the Docker software, and on top of Docker software, you run containers. So all these containers have the minimum binaries or libraries, and on these you basically just put your code. In my case, I will put my PHP code on top of the container, and that would be app1. And there could be multiple containers running on my system. For example, one code file is running in Ubuntu, the other code file could be running in CentOS container, the third could be running in some other operating system or some other flavor of Linux container, and all this is possible using the Docker software. Okay, so this is the architecture for a Docker container or a container in general. And now let us compare it with a VM, right? So I gave you the example of VM when I said that VMs are heavy in nature. So let us understand how containers are different from VMs. All right, so on the right side, you can see the architecture of VM, guys. So on the VMs, you have the hardware, which is the same as the Docker architecture that we saw. Then on top of hardware, you have the host operating system, which is the same as the Docker container that we saw. Now, on top of the host operating system, you have a hypervisor or a VirtualBox kind of software, which will basically virtualize the hardware from the operating system and give it to the VMs running on top of it, right? So you have a hypervisor software in case of VM architecture, and then you have the container engine software in case of a Docker architecture. Then on top of the hypervisor, you have the guest operating system. And this is where the all of the difference is, right? So in case of containers, you just have the bare minimum binaries or libraries which are present. But in case of your VMs, you have the whole operating system, which is basically installed on top of the hypervisor. Right? So because you have the whole of the operating system installed, your size of the VM is quite bigger than what you have in the container, right? Now, you again, the VMs could be multiple in nature. When we talk about how many VMs can we run on a machine, it totally depends on the specs of the machine, right? What are the specifications of the machine? So in VMs also, you can run multiple VMs on a single machine. And also, one thing to notice over here is that there could be or there could not be a host operating system in case of VMs, right? So in case of virtualization technologies, it has advanced this much that the hypervisor itself, it does not require a host operating system. It could directly work on the hardware level as well. But usually when we guys work in R&D, or when we have the kind of laptops that we have, right, the kind of specification that we go ahead with this kind of an architecture where we have an existing operating system. On top of that, we install tools like VMware or VirtualBox, and on top of that, we install the VMs. All right. So guys, this was the basic difference between a Docker architecture and a virtual machine architecture. Moving forward, now let's just discuss. So we have understood why do we need Docker, and we have understood that what Docker is exactly. Right now, let's go ahead and see how we can install Docker on our machines. Now, when it comes to installation, there could be basically three kind of installations that you might come across. You could either have an Apple or a Mac system that you're working on, you could have a Windows system that you're working on, and you could have a Linux distribution that you're working on. So let me walk you through all the three domains in basically installation, so that we are on the same page once we come out of installations and when we are doing hands-on. I hope you guys all will be able to, go along with the video as we are performing the hands-on. All right. So if you're on Mac, guys, all you have to do is go to this link. So this link is basically going to download the Docker toolbox for Mac. And once you have the Docker toolbox, it basically install everything. It will install Compose, it will install the Docker software, it will install the other components of Docker. So you don't have to worry about what component is what, but basically just go to this particular link, download the Docker software. And once you have the Docker software, just come back to this CLI and this just pass the command Docker version. And if you get the reply as the version of the Docker which is running on your system, it's your software is basically successfully installed, right? So this is the installation for Mac. If you talk about the installation on Windows, just go to this link, download the Docker toolbox, and everything is going to be set up automatically for you, right? When we talk about Ubuntu, things are a little simple on the Ubuntu side. All you have to do is pass these commands and your Docker would be up and ready, right? So for our sake, we will be basically doing all our hands-on today on the Ubuntu distribution of Linux. So what I'm gonna do is I'm gonna just go back to my terminal so that we can use the PuTTY software to basically connect to our Ubuntu distribution. So just give me 1 second. Alright guys, so this is basically my Ubuntu distribution, right? So what I'm gonna do is I'm gonna install Docker in it. So the first thing that I would pass is the command sudo apt get update. So the first command that I'm gonna pass is sudo apt get update. Once I've done that, the next command that I'm gonna pass is sudo apt get install docker.io. All right, and then you'll be prompted for a yes or no. Just type in Y, which will mean yes, and this will install all the packages required for Docker to work on this particular system. right? So if your internet is fast, it will hardly take a minute to install Docker. And once Docker is all installed and set up, we can go ahead and check whether Docker is working on our system or not by typing in sudo docker version. So just give it a minute and this will all be over soon. All right, so Docker is installed now, and all we have to do now is check the version. So it's Docker hyphen hyphen version. And as you can see that the Docker version is 18.061 CE and the build is this. So this basically confirms that Docker has been installed on our system. So I've successfully installed Docker. So now let's go ahead and see what is in store for us on our next slide. All right. So we have installed Docker on our system, guys, and I hope you guys have also, if depending on the kind of OS that you're working on, I hope you guys have also installed Docker on your system. If not, you can pause this video, do that first, and come back because I would want you guys to learn as much as you can from this session, and I would want you to follow me while I'm doing the hands-on so that you get the maximum knowledge possible from this session. All right. So the next thing that we're going to do in this session is get acquainted with the Docker container lifecycle. All right. So basically, this is how this is the whole life cycle of what a container goes through when we talk about the Docker ecosystem. Now, if you guys know what GitHub is, or if you guys have worked on GitHub, you guys might know that there is a central repository. Whenever you start or whenever you have to start working on a particular code base, the first thing that you have to do is pull the code base from the central repository. Right, so that central repository is nothing but something on the cloud or something on the internet which holds all the code base for your organization or for your team that everyone is working on, right? So that is basically a central place where you can download everything from. And similarly, in Docker, we have something called as Docker Hub. Now, Docker Hub would contain all the container images that are present, that are open source images that are present. For example, I told you that you could run a container on Ubuntu, you could run a container on CentOS, you can run a container on Alpine, you can run a container on some other operating system. So all of that is present on Docker Hub. Right, so the first thing that you do is pull an image from Docker Hub onto your system, and this is your system where Docker engine is installed. And basically, what you download from Docker Hub is an image of a container. Okay, so you get the image, and the next step that you do is you run that image, and the moment you run an image, it becomes a container. Right, so you can run that image, and that would basically be the normal way or the normal state of a container that it is running. Once you want to stop a container, you that is again a life cycle state that when you're done with working on the container, you can stop it. And once you are done with everything, you don't need it on your system anymore, you can remove it. So this is the life cycle of a container. The first thing that you do is you pull it from Docker Hub, it becomes an image, then you run that image, and it becomes a container. And the containers can either be in a running state, in the stop state, or in the deleted state. So this is the life cycle of this is basically I would say a summary of how what happens inside Docker, but of course there is more to it, and we'll see as we move along in the session. Okay, so we've understood the common the common ecosystem of Docker. We've understood what Docker is. We have understood how the containers work inside the Docker ecosystem. You first download them, they become an image, then you run that image, and then they become containers. Right. So with this knowledge now and with Docker installed on our systems, let's go ahead and perform some common Docker operations that you would be doing when you are working on Docker in your day-to-day life. All right. So this is the first command that we can try out when we are working on Docker. All right. So whenever you want to find out what version of Docker that you're working on, you can simply pass this command Docker version, and then you can basically get the version that you're getting on. Let me quickly change the color of the terminal because I feel that this color is a little dull. So that it becomes better for us to see. Just give me 1 second. All right, much better. So when we pass this command docker version, you get the docker version, the current docker version that installed on your system along with the build name. And this is exactly what this command does. All right. The second command that you can go ahead and try is docker pull. So we saw the container lifecycle. The first thing that you do is pull the image from Docker Hub. All right, so what and the syntax for pulling the image is docker pull and then the image name. So as you can see in the screenshot, we passed the command docker pull ubuntu, and what it did was it downloaded a container from Docker Hub automatically. So what we can do is we can also try that out. So let me just clear the screen. All right. Okay. So we'll type in docker pull and then the image name. So this is the image name and we'll hit enter. All right. So sorry about that. I forgot to use sudo. All right. So sudo docker pull ubuntu, hit enter, and this would download the latest Ubuntu image on your system. Now remember guys, we have just downloaded the image. We have not run the container yet, right? So our next command would be docker images. So now if you want to check what image did you download and is it existing on your system to verify, all you have to do is type in docker space images. So about that. So sudo docker images, and then you would be able to see the image that you just downloaded. Okay, so this is the image that we just downloaded, and you can see the size. It's 86.2 MB. 86.2, that's too low to be an operating system, right? Imagine the beauty, guys. So an Ubuntu operating system, a VM that you're working on, is I think around 1.5 or 2 GB. But when we talk about this container, it's hardly 86.2 MB. Awesome, right? So once you have seen the images, the next step would be to run this image, right? Now to run this image, the command is called docker run and along with the image name, right? So you use some flags as well when you're using docker run. So let me explain you while I'm executing this command. So sudo docker run, this is the syntax. The next flag that you add is hyphen IT, which basically means make the terminal interactive. Hyphen D, which means run the container as a daemon, run the container in the background. So whenever I run the container, make it running in the background till basically I stop the container. So that is what hyphen D does, right? So the command would be sudo docker hyphen IT. IT means make the container interactive in the terminal so that I can also pass in commands. Hyphen D, which basically means make the container a daemon that it should be running in the background even though I'm not working on it. And then you pass in the image name. So the image name is Ubuntu, and then you hit enter. So can you see you just got an ID of the container? So basically this, if you get something like this, this means that your container has just started. And then to view all the running containers, all you have to do is pass the command docker ps, and that would list down all the containers which are currently running in your system. So let us do that as well. So let me just clear the screen. So just pass in sudo docker ps, and this would basically show you the container which you have just started. So as you can see, I started the Ubuntu container 29 seconds ago, and this is the container ID for that particular container. All right, so my container is running. So what's next? Next step would be to see Docker PS would basically show you the containers which are in the running state. But what if you want to see all the containers which are there in your system? For example, what I can do is I can do a sudo docker stop, and I can stop this container, right? So this container is now stopped, and what I can do is I can run one more container, which would be sudo docker run hyphen it hyphen d and then Ubuntu. Sorry about that. So if I do a docker ps, I would only be able to see the container which is currently running. So you can see it is up 7 seconds ago. But if I want to see all the containers which are there on my system that could either be in the start state or the stop state, all I have to do is type in the command sudo docker ps and then -a. And with this, I can see the containers which are running. So this is container which is running, which was made around 27 seconds ago. And this is the container which has exited, which we manually stopped. And we can see that also by passing the command sudo docker ps -a. Okay. Now the next step would be to work with the container. So we have started the containers, but the next step would be to start working on them. And how can we do that? We can basically do that using the command docker exec. So what we'll do, we'll just first get the container ID. So that container ID is docker ps. All right, so this is the container ID. This is where this is the container which is currently running. Now if I want to get inside this container, the command for that would be docker sudo docker exec, so exec, then -it, make it interactive, give the container ID, and then bash. Bash would be that I want to run this container in the current terminal space that I'm working in, and the current terminal space is bash, and I'll hit enter. So let me just clear the screen. So can you see that you are now inside the container, right? So this is the container ID, and this is the user of the container. So we are basically acting as root of the container ID. That is, we are inside the container and we are acting as root. So this is basically the environment. This is the environment that I was talking about that the developer will start working in, right? And this is basically an Ubuntu container. So all the Ubuntu commands are gonna work inside this particular container. So once we are inside the container, we can do whatever like. So for example, if I have to update the container, I can do an apt-get update, and it will start updating the container as if it's a new operating system which is running on the system, right? And also to show you guys that this is different, or this is completely independent from what we were doing outside the container. You remember we have Docker installed on our host operating system. Now if I try to access Docker from here, I will not be able to do that. So if I do a sudo docker ps, you can see that it says okay, let me do a command docker ps. You can see that it says docker command not found, right? So basically Docker is not installed inside of the container, and that is the reason it is not able to access Docker. Also, an interesting thing that you can see over here is that I pass the command sudo docker ps, and it says sudo command not found. So the sudo library is not installed in the container, right? So I told you the bare minimum libraries which are required for a container to make it behave as a particular operating system is only present in the operating system, is only present in the container and nothing else. And that is why you can see even sudo as a command is not present inside the container. All right, so if you are inside the container and you want to exit the container, all you have to do is type in the command exit, and this will make you come out to your host operating system. But mind you guys, your container is still running. So if you do a docker ps, you can still see the container running in your docker ps space. Alright, so this is how you can get inside a container. All you have to do is docker exec -it and then the container ID space the terminal that you're working in, which in my case was bash. Alright, okay. Now again, so this I already showed you that if you want to stop a container, all you have to do is sudo docker stop and then the container ID, hit enter, and the container will be stopped. And then if you do a docker ps, you will not be able to see any containers which will be running inside the system. So as you can see, once we did a stop, there are no containers running over there in a docker ps space now. Okay.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
You can also kill a container in case a container becomes non-responsive and you're stopping the container but it's not able to exit, what you can do is you can kill a container. It's similar to that of stop, but when you stop a container, it basically gracefully exits the container. It's just like shutting down your computer or just switching off the power switch from behind the computer's power outlet, right? So if you have the stopped the container, but the container is still not stopping because of some program which is running in loop inside the container or something like that, you can immediately kill the container using the command docker kill and then the container ID. Then you have something called as docker rm. So basically I told you guys that if you do a docker ps -a, you can still see the containers which were stopped, which were in the stop state, right? But as we saw in the life cycle, there's a third stage of Docker containers, which is basically the delete stage. And to reach the delete stage, you pass in the command docker rm and then the container ID. And this would basically delete the container from your system. Now let's see how we can do that. For example, if I want to remove both these containers from the system, all I have to do is take the container ID, pass in the command sudo docker rm, and then pass the container ID, hit enter, and this would remove the container from my system. So similarly, if I want to remove the second container as well, I'll just have to pass in the command sudo docker rm, the container ID, hit enter, and the containers will be removed. And now if I pass in the command, let me just quickly clear the screen. Now if I pass in the command sudo docker ps -a, you can see there are no containers which now exist because we have just removed them from our system using the command docker rm. All right. Moving forward, now what to do when you have to remove an image? Now you guys know we already have an image in our Docker system, which is this. We have the Ubuntu image. Now if you want to remove this image from the system, the command for that is docker rmi and then the image ID. And this would remove the image from your system. So if I want to remove this, all I have to do is type in sudo docker rm. So rm was to remove the container. If you want to remove the image, just type in I as well in front of the rm command, and then the image ID, which is this.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Pass in this, hit enter, and this would delete the image from your system. So if you do a sudo docker images now, you can see that the image is not present in the system anymore. All right. So this is how you can remove image from your system. And this was it, guys. So this was how you can basically go ahead and do these are some of the common operations that you would do in your day-to-day life while you're working on Docker. And I hope you guys are well acquainted with all these operations. So what I would suggest you guys is pause this video, try to do all those commands together, and once you're done with that, let's resume the video to going ahead, right? So our next topic is basically to create a Docker Hub account. So like I was comparing it to GitHub. So if you guys have worked on GitHub, you also have to create an account on GitHub in case you want to have your own repository where you want to push your own personal stuff or your personal code for your probably R&D or whatever you want to call it, right? Similarly, you have something in Docker Hub as well. If you have created a container for your own testing purposes or R&D purposes and you want to push it to Docker Hub so that in later time probably you can pull it whenever you want, or if you want to share that container with the other people, all you have to do is create a Docker Hub account and push your container image on that Docker Hub account. Right, so that is possible, but the first step would be to create a Docker Hub account, and for that you have these steps. So first you have to go to the website hub.docker.com. So let me quickly show you that. So all I have to do is go to the browser, go to hub.docker.com, and you would see a website which will look something like this. All right. The next thing that you would have to do is you will have to sign up on this website. So just choose a Docker ID. Now this Docker ID is basically like your username, and this username has to be unique. Right? Enter the Docker ID, enter your email address, your password, agree to the terms of conditions, and just click on sign up. After this, you would get a verification email on the email address that you specify over here. Verify your email, and that's it. Your Docker Hub account is all set up, right? I already have a Docker Hub account, so let me just quickly show you that. So my Docker Hub account looks something like this. Just give me 1 second. All right. So guys, this is my Docker Hub account. And as you can see, I have some personal containers that I uploaded over here. And I'll show you guys also how you can do this. But before that, let's come back. So once you have set up your Docker Hub account, you would be able to see your Docker Hub account, which would look something like this, right? And always remember, guys, remember your user ID, because it's going to help you out in the future when you are basically pushing your custom images onto your account, that is your Docker Hub account. Alright, so always keep your user ID handy. Alright, so guys, this is how you can sign up for Docker Hub. Once you have signed up, let's go ahead and see how you can save changes to a container. Alright, so what does this basically step mean? So this step basically means that if I am on my system and say, I run my Docker command, say I run a Docker container, right? So this is basically download and run the container for me. So sudo docker ps, this is the container that I want to go into. All right, so I'm now inside the container. Now what I want to do is, let us do an LL, and you can see these are all the directories which are present inside the container as of now. Now what I want to do is I want to say create a directory, and say I create a directory called app, right? So if I do an ls now, you can see there is a new directory app which has been created inside this container. Right now, if I exit this container and say I do an ls, if I do a sudo docker ps, I can see that the container is running. But the catch here is that if I delete this container, say I delete this container. Okay, so one more thing, guys. If you want to remove or delete a container which is running, you can pass in the command sudo docker rm-f and then the container ID. The other way to do is to stop the container first and then delete it. That is a general way of doing it. But if you're in a hurry and you want to delete the container which is in the running state right now, just type in the command sudo docker rm-f and then the container ID, and this would remove your container. Alright, so I've deleted my container now, and if I now type in, if I again run the image, that is sudo docker run -it -d and then the image name, and if I go inside this container and if I do an ls, you can see the directory that I created, it is not nowhere present over here now. The reason for that is whatever changes you made to the container, they were only present inside the container, and this container, when deleted, these changes do not propagate into the image that you downloaded originally. All right, now if you want to make changes to a container and want those changes to be saved inside an image so that you can later on again launch a new container and it should have all those files or folders or softwares that you installed inside the container, you would have to save these changes inside the container, and for that you would have to learn how to save changes inside a container. Let's go ahead and learn how you can save these changes inside a container. All right, so for saving changes inside a container, the command is called docker commit. Okay, so you have to pass in the command docker commit, the container ID that you want to save, and then the new image name. So basically, this will create a new image of a container. And once you pass in the container ID space, you have to give the new image name that you want that custom image to have, right? So for example, in my case, if I create the folder, say app, I do an ls, I can see the app folder is there now, right? I'll just exit the container, I'll do a sudo docker ps. I can see this is the container ID. So I'll just copy that and sudo docker commit, pass in the container ID, and then the new image name. So the image name, let's say I say the image name is test. All right. So with this, if I now do a docker images, I can see that there is a new image which is present, which is called test. All right. And now I can run a container on the image test, and all I have to do is sudo docker run -it-d and then test. This would run the container, and if I go inside the container now, I can see that my changes would be there inside this container. So if I do an ls, I can see that the app folder is present. And this is how you can create a custom container. So I, for demo purposes, says just created a folder. You can also install softwares inside a container. Like for example, you install Apache, you install MySQL, or any other kind of software that you want. Then all you have to do is save the container using the docker commit command, and you're all set. Whenever you run that image again, you would have all those softwares installed inside that container. All right, and this is how you save changes to a container. All right, so now let's do this example. So basically what we're going to do is we're going to run an Ubuntu container. We're going to install Apache on it. And once the Apache is installed, we're going to save that container into an image. All right, so let's see how we can do this. So let's clear the screen. Let's exit this container and let us first clear everything up. So sudo docker ps. So there are two containers running. Okay, so let me show you one more command, which is basically like a shortcut. So if there are like tens or five or more than five or more than three containers running on your system, you always don't have to pass in the command sudo docker rm -f and then pass the container IDs. The shortcut to remove all the containers at once is the command sudo docker rm -f and then pipe it with another command, that is the sudo docker ps -a and then -q. You pass in this command, it would remove all the containers which are present in your system. So if I do a sudo docker ps now, you can see there are no containers running anymore. All right, so this is the shortcut that you can use while working with Docker. All right, so my next step is to basically install. So first I have to run an Ubuntu container. So I'll do a sudo docker -run -id Ubuntu. All right, so my container is now running. The next thing that I have to do is install Apache server on this container. Okay. Okay, so let's take it a little differently now. So basically, okay, so let it be like this. We'll come back to the part that I wanted to explain to you guys later. So basically now I'll just exec into this container. Okay, I'm in. First thing that I'll do, I'll just update the container. So apt-get update. Okay, once it's updated, the next step is to install Apache, and for that the command is apt-get install Apache 2, and this should install the Apache software. All right, and service Apache 2 status. would give us whether Apache is installed or not. So it says Apache 2 is not running. So let's start the service. The service Apache 2 start, hit enter. And if I now check the status of Apache 2, I can see that Apache 2 is running inside the container now. Awesome, this is what I wanted. So let me just exit the container now and let me save the container. So we have installed Apache on our container. Next step is to commit these changes to the container so that it becomes an Apache container. All right, so I'll do a sudo docker ps. This is the container ID. I'll say sudo docker commit, give the container ID, and now give the image name. So let's give it as Apache. Or let me make it a little more simpler for me when I move ahead. So whenever you want an image pushed to your Docker Hub account, there is a certain nomenclature that you have to follow when you're naming your image. So first of all, you would have to write the username for your Docker Hub account. Remember, I told you to remember your user ID, and this is exactly for that. So specify your user ID / and then whatever name you want to give to your container. So that would be Apache, right? So the naming would be specify your user ID / your container name that you want to give. All right. So sudo docker commit container ID and then the container image name that you want to give to your custom image. Hit enter, and this should basically save your images. So if I do a sudo docker images now, you can see that our image has been saved over here with the name hshr/apache. You should also notice that now my size of the container is 212 MB. Because I've installed the software, the size has gone up. It was 86 MB before, but because we have installed a software on it, it has now become 212 MB, which is fine. All right, so now we have the new image. So what I'm gonna do is I'm gonna remove all the containers which are running now. So sudo docker ps, this is the container running. So let me just remove it. Okay, forgot to do the -f. Awesome. So now what I'll have to do, to check whether my image is functioning properly or not, what I can do is I'll just pass in the command sudo docker run -it -d and then the image name, this is hshr/apache. Okay, I'll introduce you to one more flag, which is -p. Now what -p does is it basically does port mapping. So when I've installed Apache, if I want to check if Apache is working or not, normally Apache works on port 80, right? So on containers port 80, Apache would be running. But if I want to check the port of the container, or if I want to check if everything is running inside the container fine, I'll have to map the internal port of the container to the outside host operating system. So in this case, I'll have to map it, say if I want to map it to port 82 of my OS, of my host operating system, to the 80 port of my container, this is the command to do that. -p space port number that you want to specify, colon the port number of the container that you want to link it with. So I want to link the port 82 with the internal port 80 of my container, which has the image running hshr/apache. All right, I'll hit enter. This would create the container, and if I do a sudo docker ps, I can see the container is now running. So let's exec into this container. So sudo docker exec -it, give the container ID bash, and if now I do a service apache 2 start, it should basically give me either an error that Apache 2 not found, or it should start the service. So let's see what happens. So it says service Apache web server Apache. So this basically means Apache was present inside this container because we did the sudo docker commit. Apache was installed inside this container, and this now service has been started. Now remember guys, we have mapped it to port 82. So now let's check if we can access the Apache software on port 82 of this server. All right, so let me just go to the IP address of the server. So basically the server is running on AWS. So this is the IP address of the server, and I have opened it on port 82, right? So right now if I hit enter, it will not work. Reason being, I'll have to open the ports on this server. So let me just do that. Let me open all traffic so that we are on the safer side. Okay, so IP address colon port number, which is 82, hit enter, and you can see the Apache is successfully running. So mind you guys, Apache is not installed on the server, it is installed inside the container, and that software is able to access on the browser using the port that you mapped on the container. All right, so our um, for our verification, what I'll do is sudo docker ps, and I'm gonna stop this container now. Sudo docker stop, pass this ID, and now if I do a refresh over here, you can see that it says the site can't be reached. Reason being, I've stopped the container over here. All right, and this is how you can save changes to a container, install software, and create a new image out of it. Now next step would be to push it to Docker Hub, right? So I told you guys, once you are done working on your container and you've created a custom container that you want your team to access, or you want it to be there on Docker Hub for safety purposes, you can push it to Docker Hub. And to do that, the command would be sudo docker push, which I'm going to explain in a little bit. But before that, we saw the life cycle, right? We saw we can push or pull from the Docker Hub. So this is the pushing state. So we had a Ubuntu container, we installed Apache on it, and then we committed the changes, and now we have an image on our local system. The next step is to push it to Docker Hub, right? And let me show you exactly how to do that. So this is your Docker Hub, guys, and the first thing that you would have to do is you would have to log into your Docker Hub from your console, and to do that you will have to type in the command sudo docker login, pass in this command. You'd be asked the username, so pass in the username of the Docker Hub and then pass the password. So if there is any problem with your password, it will give you this error. So let me just try once more. So I'll pass in the username and then I'll pass in the password. And on a successful login, you will get this message that is login succeeded. Awesome. So I have logged into my Docker Hub. Now what I want to do, I want to push my image. So I'll have to do a sudo docker push. And what was your image name? It was hshar/apache. This was the image name, right, that we gave to our custom container image. Hit enter and it will start pushing your image to Docker Hub. And once it has pushed the image, all you have to do is you can just visit your Docker Hub repo and you'd be able to see your image listed over here. Just do a refresh and just go to the last page, and you can see this is the image that I just pushed to the repository, which is hshar/apache. Awesome. So we have successfully pushed our image to Docker Hub. So it's very easy. Just type in the command sudo docker push and that should be it. All right. So our next topic now is introduction to Dockerfile. And let us go ahead and learn what is Dockerfile. But before that, let us recap what we have just learned. So we understood what Docker is, why do we need Docker, what is Docker exactly. Then we went through some of the Docker operations, the day-to-day operations that you would be going through. We got acquainted through that. Then we saw how to run a container and then how to do some changes to the container and save it on your local system, and finally how to push that container onto a Docker Hub. This is what we have learned.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, the next step is, what is a Docker file? So, a little introduction about a Docker file. So, you just saw that if I had to make changes to a container, I basically had to run the container first, go inside the container, install whatever software I want, install whatever I want, and then come out, commit the container, and only then it will get saved. But there's a shorter version of this. When you're working on production grade environment, when you're working in a production grade environment, everything has to be lightning fast, right? And for making changes to a particular container image, you can also use something called as a Docker file, right? So we're going to discuss what a Docker file is now. So let's go ahead and start with this topic now. So a Docker file is nothing but a text document in which you write how do you want your container to be customized, right? So one example, like I just told you guys, was when I did it manually. I ran a container, I went inside it, I installed the software, came out, committed the container, and then pushed it onto Docker Hub. Now, all these changes can be automated using a script style, which we call the Docker file. Now, a Docker file is very easy to write, and there are basically some nomenclatures or there's some syntaxes that you would have to learn, but I'm sure they are very easy to learn, and once you learn them, it'll only be Docker file that you would be using rather than doing everything manually. Right, so let's go ahead and see how we can create a Docker file. So guys, these are some of the syntaxes, these are some of the important syntaxes that are relevant to creating a Docker file. Now, the first line of a Docker file is always from, right? So the image on which you want to make changes, for example, we made changes on the Ubuntu images where we installed Apache. Right, so what we did docker run -it-d and then Ubuntu. So in Docker file, the first base image that you want to work on, you'll have to specify it on the first line using the command from. Okay, so this area uh, of your presentation will basically tell you the Docker file content. So this is exactly how the content of the Docker file should look like. So the first command is from. So from Ubuntu. So the base image that I want to work on is Ubuntu. So this would be the first line. Second command would be to add all the files. So add is basically used to add files inside a container. Now, for example, say I create a HTML file and I want that HTML file to be added inside the Ubuntu container. So for doing that, the command add, the first argument would be the place where you want, where the files are present, and the second argument would basically be the location inside the container where you want all those files to be copied. All right, so add space dot, the meaning take files or take all the files from the current directory and put it inside /var /www and /html. All right, so this is what the add command does. The third is run. So whenever you want to run any command in the container, for example, I ran apt-get update and apt-get install Apache 2 inside the container, right? Now, if you want to run the same commands from the Docker file, you can do that using the command run. So over here, there are two commands that I want to run. The first is apt-get update, and the second is apt-get install Apache 2, right? The -y signifies over here the option that we get, that whether you want to go ahead with the installation, yes or no. So if you specify -y implicitly in Docker file, it would not ask that option, and it would continue the installation without any prompts. Alright, so run command is basically used to run any command inside the container on the terminal that you would have ran. Okay, then you have a command called cmd. So cmd keyword is basically used to run or any command that you want to run at the start of the container. All right, and these commands run only when there is no argument specified while you're running the container. So while you're running a container, you can also specify any command that you want to run. So in case you specify a command while so for running a container, the command is docker and -it-d and then the image name. Now after the image name, you can also specify a command that you want to run inside the container. Okay, so if you don't specify anything like we did, then in the docker file, this command will be running when we are starting the container. Otherwise, whatever command we specify in the docker run command, that would be running. Okay, then so this was about the cmd command line. So in this case, what we are doing is, what we want to do is, like, remember when we started the container, we always had to go inside the container and start the Apache service manually. That is, once the image is started or once the container is started, go inside the container and type in the command service apache to start, right? So that had to be done manually. But when you pass it using the command cmd, which is nothing but all the commands run on the startup time. Whenever the container will start, this command will execute automatically if you specify it under cmd. So cmd apache ctl-d foreground would do nothing but run apache the moment the container starts, and this is exactly what we want, right? So this is possible using cmd. So again, I'll repeat it. cmd is used to run commands at the runtime of a container, and they run only when there is no argument specified in the docker run command. If there is no argument specified, the cmd command will run, otherwise it will be skipped from the docker file. Alright, the next command is entry point. Now entry point is exactly the same as cmd, that is, it runs at the starting of the container, but the only difference is cmd will not run if you specify an argument in docker run, but entry point will run irrespective of the fact whether you have specified an argument or not. All right, so cmd and entry point can be used interchangeably, but if there are cases when you'll be running the container with an argument, so it's better to use entry point so that the command does not get skipped. cmd command will get skipped if you specify an argument after the docker run command. Okay, so in our case, we use the apache ctl-d foreground with the entry point command. All right, the next command is env. So if there are any environment variables that you want to set inside a container, you can pass it using the command env space the name of the variable and space the value of the variable. All right, so in my case, I specified a variable name which has the value DevOps Intellipaat. All right, so these are some of the commands that you can use to create a docker file. Now let us create this docker file on our system as well. So what I'm going to do is I'm gonna go to my putty software and I'm gonna specify nano and then docker file. So let me just create a directory first. So let me create a directory called docker file itself. So mkdir docker file. Let us go inside it. So cd docker file, and now whenever you are creating a docker file, the name of the file always has to be docker file itself, right? So I'll specify nano and then docker file. We went inside. So the first thing that we want to do is we want the ubuntu image to be called. Then we want to update this image. So apt get update. Then we want to install Apache inside it. apt get -y. Sorry about that. So apt get -y install Apache 2. Alright, sounds good. Then we are going to add all the files from this directory to the directory var www.html. So we're going to create this file. Do not worry, we'll just create this file. Right, once we have done that, the next step would be to run Apache in the foreground, that is run it. So Apache ctl -d foreground. So this would run Apache automatically. Okay, and you specify the entry point and say I also want to specify environment variable. Say let me create an environment variable called name, and I want to specify the value as Intellipaat. Okay, sounds good. So this is my Docker file, and I'll just save this now. And let me create a HTML file as well. So let's create one.html, and let us make it a little simple. So this would be a hello world HTML file. Okay, the body, and in the body say I have an h1 which will say hello from Intellipaat. Close the header, close the body, and then close the HTML. Alright, this is what I want to do. I'll save this, and now we are done with the Docker file, and we have the HTML page in place. So the next step would be to build this Docker file. Now let's see how we can build it. So for building this Docker file, all you have to do is docker build. Where do you want to build it? I want to build it from the current directory, and the image that it will create, I want to name that image as say new underscore Docker file. Okay, so it will be named like this. So I'll hit enter, and I forgot to mention sudo. So let me just clear the screen. Alright, so let me first teach you guys how to run a Docker command without sudo. So for doing that, just type in sudo usermod -a-n-g, and then docker, and then $user. Enter, and now all I have to do is just re-login into your session, and this should work. So if I do a docker ps now without sudo, you can see the command is running. Awesome. So what I want to do is I want to go inside the Docker file. Okay, and now I want to build this Docker file. So docker build dot -t new underscore Docker file. So you can see the Docker file is now being executed, and basically this is creating the container for me, and this will basically come up with an image which will have all the changes that we just told to the container. So now if I do a docker images, I can see that there is a new image which has been created, which is new underscore Docker file. So let us run this new underscore Docker file. Docker run -it -d. Also let us specify the port number. So let us open it at port 84, and then -d new underscore Docker file, and then hit enter. Okay, so the container is launched now. So if I do a docker ps, I can see that a container has been launched 7 seconds ago. Awesome. And it being opened on port 84. So let's check if everything is working well for us. So we just have to change this to 84, and you can see Apache is running. Awesome, Apache is running. And now let's check our web page if it's there in the container or not. So we named it as 1.html, and yes, so this is the HTML that we created, which has been added inside the container. So let me show you inside the container what exactly happened. Okay, so docker exec -it container name and then bash, and let me just clear the screen. Okay, and let me compare it with my Docker file. So the first thing that we did was apt-get update apt-get -y install Apache 2. This basically installed Apache, so this was clear. Then we added everything from the current directory to where www.html, right? So if we go inside where and then www and then html and do an ls over there, you can see that the 1.html file has been added, and at the same time docker file was also added. So inside the directory we had these two files, right? 1.html and docker file. So both of these were added inside the container. Now to not have docker file inside your container, what you can do is, instead of dot, specify dot slash and 1.html. That would solve this problem. It would only add 1.html in the container. Okay, so it added 1.html, and index.html is basically the default page of Apache that you see, right? So we added 1.html, so this was added by the Docker file. At the same time, what we did again was we defined Apache to run in the foreground. So as you can see, we did not invoke the Apache service by going inside the container. We just went directly to the port number that we mapped the container to, and the Apache was up and running. So that is awesome. And the last thing that we did was we defined an environment variable. So what I can do is I can echo the variable, which is $name, and you can see this is the value of the variable that is specified in the Docker file. I specify the variable names to be Intellipaat, and if I specify echo $name, this is the value that I get automatically. So this was set by the Docker file in the container image that I just created. And now what I can do is I can just exit this container, and if I want you guys to use it, all I have to do is do a docker push to this container on my Docker hub, and you guys will also be able to access this particular container. Alright, so for that I'll just have to change the name, do a docker push, and you should be able to use it. But I'm sure you would not be needing it, because if you pass the same commands that are written over here, you would get the exact same container that I created. Alright, so let me know if you guys face any problems in the comment section, and we'll be happy to answer all the queries for you. Alright, moving forward, now we got to know how to create Docker files. We got to know how to build images from the Docker file automatically, kind of like a script kind of thing. Alright, so now let's start with our next topic, which is introduction to a Docker volume. So what is a Docker volume? So Docker volume is basically used to persist data across the lifetime of a container. For example, I demonstrated it to you guys that when you create a container, you make some changes in the file system, you delete the container and you launch it again, and the changes are not there anymore, right? So that can be fixed. So imagine it like this. For example, you're using Apache container and you have a website inside of it, and the container stops responding because of some reasons. What do, you delete the container and you launch it again. But with that, what happens is your website content is also deleted. And if your website content is not present in this new container, it becomes a problem. So to solve these kind of problems, we came up with Docker volumes. So what Docker volumes does is it basically maps, or it basically hosts the storage outside of the container, and maps it to inside the container. That is, the storage is there on the host system rather than on the container, rather than the files being written on the container itself. They are written outside the container, and that location is basically mapped inside the container. So irrespective of the fact whether the container is deleted or started again, the container which is being attached to that volume will have the same file system as that of the older container, and that is how this problem is solved, that is of persistence of data across the container lifecycle. All right, so there are basically two ways to do it. One is called a bind mount and one is called a Docker volume. Now, what are the differences between a bind mount and a Docker volume? Let us see that. So basically a bind mount would be that, let me just come out of the directory. A bind mount would be that I mount a particular file location inside the container. Okay, for example, I created this Docker file directory, right? So what I can do is I can map this Docker file directory inside a container. Now to mount this particular Docker file folder inside my container, all I have to do is docker run -it, and then there's a flag called -v that I'll have to specify. Specify the uh, location of the directory, which is /ubuntu/ uh, home /ubuntu /docker file. Now this is the location of my folder, and then what is the mount point of inside my container. So say I say it's /app, right? So I'll specify that, I'll specify -d, and then I'll specify Ubuntu. I'll hit enter, and my container is now launched. Now if I go inside this container, I will be able to see that there is a folder called /app which has been created, right? So if I go to app and if I do an ls, you can see the folder, the files inside this container are that of the Docker file. Now these files are not actually copied inside the container, but these are actually being mirrored from the directory on the host operating system. That is, if I duplicate this session, let me just duplicate this session. So I'll just go inside the directory Docker file, right? If I do an ls and say I touch a file, say 2.html.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
Right? So if I do a ls in the container now, I can see that there is one more file 2.html, right? So it is inside the container. So whatever changes I make inside this directory will automatically or dynamically be available inside this container. Okay, the reason for that is that this directory is mapped to the directory /app in the container. All right, so this is called bind mount, but there's a disadvantage with this. The disadvantage is that a bind mount will only work when the file system is the same that you have specified, like over here in this container, right? For example, what can happen is I can specify this bind mount to be in the configuration of the container, and I can push it to Docker Hub. So anyone who is downloading this container will automatically have this bind mount on his operating system. But the problem which will arise is that, say you download this container on a Windows operating system, right? In the Windows operating system, this file path that I gave /home /ubuntu /docker file is not going to exist, and that is where it is going to give you an error, and it will cause you a problem, right? So this way of persisting data is a little difficult, or is a little I'd say complex when it comes to different environment setups, when you're dealing with different environments. For example, if I have to talk about, say, a different operating system, say I want to work in CentOS, so in that the file structure would be a little different, right? For any other operating system, it'll be a little different. For Windows, it is completely different, right? So a bind mount will not work in different environments, and that is where it has a disadvantage. But then this advantage is basically overcome by volumes. Now, what are volumes? Volumes are basically entities, or are basically storage which is managed by Docker. Bind mounts are not managed by Docker, because you create the directory, you decide which directory your data is going to reside in, right? And inside that directory you are making the changes, and that is being reflected in the container. But if you create a volume, the docker engine which has been installed on the host operating system automatically identifies where this volume has to exist, okay, and then creates that volume over there. Also, in bind mount, it is a little difficult to basically migrate the data. In volumes, it is very easy. You just take the volume up, and then just put it on some other system and it will work. But in case of bind mounts, you'll have to decide at which place you want to keep it, and then bind that place to the container. Only in that case it will work, right? Let me show you what happens in case of a volume. Right. So in case of a volume, if you want to create a volume, this is the syntax. So the syntax is docker volume create and then name of the volume. So let me show you how you can create it. So let me just docker volume create, and let us create a volume, say test. Okay. So this would create a volume called test, as you can see over there. Ignore the warning, guys. So this created a volume test, and if you want to see all the volumes which are present on your system, you can pass the command docker volume ls, and this would give you all the volumes which are present on your system. So on my system right now, only the test volume is present. I don't want to have to know where is it present, because Docker manages the handling part of the file system itself. I don't have to worry about that. I just want to know that if there is a volume. So yes, there's a volume on my system which is called test. Awesome. All right. So the next thing that I have to do is basically I'll have to type this command: docker run -it -mount. And so basically, if I were to give you the syntax, this is the syntax for mounting a volume. So docker run -it -mount. Source would be equal to the name of the volume. So in our case, the name of the volume is test. Then the target would be where do you want to mount it inside the container. So we want to mount it inside /app, right? And then -d, and then the image name. All right. So once the container is launched, now what we can do is we can go inside this container to check if everything is working fine. And we'll go inside app and do an ls. So there's nothing inside this volume as of now, right? So what we can do, we can create, say, touch, then one.html, and then touch 2.html. We can do all this, and then what we can do, we can also duplicate the session. Let me just duplicate the session, and what I'm going to do now is I'm going to launch one more container. Okay, so I'm going to launch docker run -it -mount, and then say source is equal to test, and target could be some other folder as well, but for the sake of simplicity, let's keep /app, and then -d and ubuntu. This would launch one more container, right? Let's go inside this container, docker exec -it, this, and then bash. Okay, let's go inside app. If I do an ls, you can see that whatever changes I'm making in this volume is also being reflected in this container. So say I create 3.html over here. If I go here and do an ls, I can see the 3.html as well. Alright, so this volume is basically being shared between two containers. Even a bind mount can be shared between two or more containers. A volume can be shared between two or more containers. But in case of volume, you do not have to worry where your volume is being stored. It is automatically handled by the Docker engine. Okay. The other cool thing over here is that if you delete this container and launch it again, it'll all be the container, or your end user will not even realize if anything changed. For that, let me give you an example. So let me just exit this container, and we created a image called new underscore docker file. Okay, so what I'm gonna do is I'm gonna launch docker run hyphen it, and then source say is equal to source is equal, let me create one more volume, docker volume create, and let us create a volume for Apache. Okay, now what I'm gonna do is I'm gonna launch docker run hyphen it, and then hyphen mount. Source would be Apache. Now look at this closely, you will get the difference. So source is Apache, and what I want to do is I want to target this particular directory var www and then html. So whatever would be inside this directory will automatically come inside the volume. Okay, so I don't have to add anything into the volume, and I'll show you how to do that. So you specify this hyphen d new underscore docker file. This was our image name, and let us hit enter. So it created the container. Let's go inside this docker exec hyphen it, and then this container, and then bash. Okay, so we are inside the container now. Now if I go to cd var www html and do an ls, you can see the files are still here, but these files are also now mounted on the volume, and that is evident over here. So if I exit this container and if I launch a new container with the mount as Apache, and target would be say slash app, and the image is this. Okay, so this is the Ubuntu image, right? So it should not have the files inside it, but if I go inside this container now, can you see the files over here are same as what was there inside this container var slash www slash html. Okay, now the beauty is this, guys, that if I come out, say I create a 2.html over here, right? So what I do is I come out of this directory. Okay, and what I do is I create nano do.html. I create a file, and then I specify that html body h1. This is the new html file. Close the header, close the body, close the html, come out. Okay, now I want to copy this tool.html inside this container. So what I will do, I'll do a docker cp dot slash 2.html, and then slash var slash www slash html, and then the container id. Slash var slash www slash html. Okay, so now 2.html is present inside the container. Okay, now what I will do, I'll just delete the container. I'll delete the new underscore docker file container. docker rm-f delete. Okay, so ideally if I now launch a new docker run -it -mount source is equal to Apache, target is equal to /var/www/html. Okay, and hyphen p also we specify that we want 81 port to be exposed, and hyphen d, and then the image name new underscore docker file. So what will happen now is this, that if I go on the browser, if I go to port 81, the container is running. If I go to 2.html, you can see that the new file is also there in this container, that is new underscore docker file. So it does not matter if your container has the file or not. If you have mounted the volume and that volume at some point had that file inside it will have it inside this container as well. Okay, originally inside this image you don't have the 2.html, right? And let me prove that to you as well. So if I do not mount the volume and I launch this container, right? So if I go to this IP address and but on page 82 you can see the container is up and running. If I go to 2.html, it will say 2.html was not found on this server. Reason being, the volume is not attached to this server. This file only has 1.html that we wrote using the docker file, right? For volume we have it in attached in the container which is mapped to port 81, and that has the file 2.html, which is this. So awesome guys, we have successfully understood what docker volumes are.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS developer tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you launch a virtual machine using CodeDeploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is code commit, and then code build, and then code deploy and code pipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss code commit. So the name suggests that code commit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS, and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using code commit. You can also see over here code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. For if you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS code build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS code build, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS CodeDeploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS CodeDeploy. So first is automated deployments, and then minimized downtime, centralized control, and easy to adopt. So the first one is automated deployments. Is when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds, and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched, and you will have to change your code over there. When you do that, the downtime increases, but using CodeDeploy you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console, and you can control all of the operations happening in CodeDeploy, code commit, and code build. And then easy to adopt, you can see works with any application, and same experience whether you are deploying it on EC2, AWS, or Lambda. That means whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is CodeDeploy, guys. And then finally, AWS CodePipeline. So we are going to use CodePipeline. We can use CodePipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website, or you can automate your application which is running on CodeDeploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to CodeDeploy and the change will be made. So that's how you use CodePipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS CodePipeline. And then, so you can see over here, easy to integrate AWS CodePipeline with GitHub or with your own custom plugin. So you can integrate GitHub and CodePipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like pipeline or CodeDeploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage. And then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS CodePipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using CodePipeline and CodeDeploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Appspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is we'll have to create a code deploy application. So let me click on application. So I already have one. So this is what I tried. So create application. The first thing it asks is your application name. So I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to. That is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Machine Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance. You can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys. This is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your CodeDeploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 CodeDeploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions. And here you will have to provide CodeDeploy. So you can see Amazon EC2 role for CodeDeploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created. If you want, you can create it. If you already have, you don't need to. So I have it. I chose the IAM role, and then also I'll have to enter user data. So what does user data mean? So basically, user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually, Ruby is required for CodeDeploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my CodeDeploy. After installing that, I'm just modifying my permissions, and after that I'm installing CodeDeploy, which got downloaded. After it gets downloaded, now I'm starting CodeDeploy, guys. After installing CodeDeploy, I'm going to start the CodeDeploy service. Only if it is started, then I can connect my EC2 instance and CodeDeploy. So I'll copy these and enter it in CodeDeploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here. And then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I'm creating this tag? Because I'm going to use this tag to, so I'll have to enter this tag over here so that this CodeDeploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now, I'm going to allow an HTTP rule, because I need HTTP because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now just I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1, And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values, my value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. Sorry guys. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to CodeDeploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a CodeDeploy application and a deployment group, and also how to connect a EC2 instance with CodeDeploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay, guys. So next, CodePipeline. So only using CodePipeline, we're going to connect our GitHub and CodeDeploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new CodeDeploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role, it needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts, that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built, so I don't need to worry about building. So I'm going to skip build stage. So now you'll have to deploy. You'll have to click on a deploy provider. So you can see over here there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing CodeDeploy and CodePipeline, I'm going to choose CodeDeploy because I already have a CodeDeploy application. So I'm clicking on it. You'll have to choose the region where we created. My CodeDeploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the CodeDeploy applications available in the region. You can see over here web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group, I have only one deployment group. I'm choosing it and moving on. Next. So this is again same thing, basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now let me see my instance is running. So currently if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded. My code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now CodeDeploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my CodeDeploy got succeeded. So right now if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my app spec YAML file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html, and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world, and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time, you can see there will be a commit ID. The commit, which commit it took, will be present over here. Once it succeeds, that change will be implemented in my CodeDeploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world, and you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using CodeDeploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so I'll just, okay. So whenever there is a change happening in your version control tool, that is this change when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to CodeDeploy. So CodeDeploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using CodeDeploy and GitHub. So we've learned how to do this. Let us create a CD pipeline using CodePipeline and CodeDeploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I'm going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html, destination is this. So this is where Apache 2 installs its index.html file, but we'll be deleting that file and launching our hello world application. So you can see here before install script/install dependencies and script/server start server. So I'll show that what actually is there. I'm going to scripts install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Appspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only CodeDeploy and CodePipeline, guys. So first thing we'll have to do is we'll have to create a CodeDeploy application. So let me click on application. So I already have one. So this is what I tried. So create application. The first thing it asks is your application name. So I'm going to provide it as web server and Apache 2. So web server Apache 2, this is going to be my application name, and here compute platform. This is the most important thing, guys, because here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to. That is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Mission Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance, you can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys. This is the most important thing. You will have to include a IAM role. So why an IAM role? Because the CodeDeploy agent should access your EC2 instance, and also the EC2 instance should be connected to your CodeDeploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 CodeDeploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions. And here you will have to provide CodeDeploy. So you can see Amazon EC2 role for CodeDeploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for CodeDeploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my CodeDeploy. After installing that, I'm just modifying my permissions, and after that I'm installing CodeDeploy, which got downloaded. After it gets downloaded, now I'm starting CodeDeploy, guys. After installing CodeDeploy, I'm going to start the CodeDeploy service. Only if it is started, then I can connect my EC2 instance and CodeDeploy. So I'll copy these and enter it in CodeDeploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag to, so I'll have to enter this tag over here so that this CodeDeploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now I'm going to allow an HTTP rule, because I need HTTP, because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on, and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now just I'll go back, and now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance, and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once. If you're having a lot of instances running, guys, sorry. If you have a lot of instances running, guys, you can provide half at a time. And after, for example, you have 10 instances, first 5 instances will run. After that, the next 5 instances will start. So if you provide one at a time, if you have 10 instances, first the first instance will get the website, and then the next, and then the next. So it will go one by one. After that, if you give all at once, all of the instances which you have provided, which you have mentioned, will get the website at the same time. So right now I have only one instance, so it doesn't matter if I choose any of these. I'm going to go with all at once. And I'm not using any load balancing, so I'm going to cancel that. And I'm creating my deployment group. So you can see additional settings. Actually, I don't have any alarms or triggers. So I'm just going to go with creating my deployment group. So here you can see I have created my deployment group, and also there is an edit option. Sorry guys. So you can edit it or delete it, or you can create a deployment from here. But I'm not going to create a deployment from here, guys. I'm going to create a pipeline which will do that for me automatically. So if I create a deployment from here, every time I'll have to come to CodeDeploy and click on create deployment. I'll have to click on that button, which will create a new deployment every time I change my GitHub code or code in any repository, guys. So instead of doing that, I can just create a pipeline which will do that automatically for me. So right now we've created an application and it has a deployment group, guys. So we are good with that. We've learned how to create a CodeDeploy application and a deployment group, and also how to connect a EC2 instance with CodeDeploy. So you can see it's still initializing because we've run some commands. So those commands will be running inside. Normally it doesn't take this much time. So right now it's running. So that's okay, guys. So next, CodePipeline. So only using CodePipeline, we're going to connect our GitHub and CodeDeploy. So whenever there is a change in GitHub, so it will be available in our instance. So right now I already created a pipeline which succeeded, and right now I'm going to create a new pipeline for my new CodeDeploy application. So first thing, I'll have to provide a name. I'm going to provide web server pipe. So it will create a role. So it needs a role. It needs a service role, and it will create it automatically. We don't need to create it again and again. And then advanced settings, just click on default location and default AWS management key. Basically, default location means the artifacts that is the data which will be stored while we run this. That data will be stored in this bucket. So the data will be stored in code line US East 1 and this number. So it will be stored in this S3 bucket, guys. So that is default location. If you have any other bucket where you want to store your artifacts, you can provide it in custom location. And then next, now you'll have to choose your source provider. My source provider is GitHub. So I'm choosing GitHub. And the first thing it asks is connect to GitHub. So I'll have to click on it. It takes me and it connected with my GitHub account because I have already logged in. And then repository, I'll have to choose the repository which I have to deploy. So my website is in this repository, which is also called website. So I'm just going to click on it. And branch, I have only one branch, that is master. And then next. So I don't need a build, guys. Actually, this is a website. There is nothing to be built. It is a HTML page. There is nothing to be built, so I don't need to worry about building. So I'm going to skip build stage. So now you'll have to deploy. You'll have to click on a deploy provider. So you can see over here there are various deployment options. You can choose Amazon S3 and launch this website as a static website. You can choose Amazon ECS. You can choose Alexa skill sets. You can choose OpsWorks, even Elastic Beanstalk, and then cloud formations also. But right now, as we are doing code deploy and code pipeline, I'm going to choose code deploy because I already have a code deploy application. So I'm clicking on it. You'll have to choose the region where we created. My code deploy is in North Virginia, so I'm good to go. If I click on this, it should show all of the code deploy applications available in the region. You can see over here web server Apache and a web server Apache 2. So mine is web server Apache 2. I'll have to choose that. And then deployment group, I have only one deployment group. I'm choosing it and moving on next. So this is again same thing, basic stuff. It asks you to review it. You can review it if you want, or you can just move on. So right now let me see my instance is running. So currently if I see, so there is nothing available, guys. So let me run this pipeline. So let me create this pipeline. So if I create this pipeline, what do you expect will be available? So there will be an UI with two things, that is the source stage and the deploy stage. So congratulations, the pipeline web server pipe has been created. So you can see source. My source is GitHub and it is in progress. Once it gets succeeded, then it will move on to deploy stage. And you can see over here, you can edit this. You can add more stages, that is more source over here. You can add more deployment stages over here, but I'm not going to do anything. I'm just going to, because I have already created. So right now GitHub has been succeeded. My code has been properly taken. So it took merge branch master from this particular GitHub repository. So right now code deploy is running, guys. So I'll go to details. Let us check whether this succeeds or not. Only if this gets succeeded, then my website will be available. So you can see, oh, my code deploy got succeeded. So right now if I go here, you can see all the events happened and also whether it is succeeded or not. If any of this was not succeeded, for example, if this gets failed, so you will see the error code over here, and if you click on that error code, it will take you to a log page which will show what error is available in your code. So you can use that to debug your application. So you can see over here, succeeded, before install succeeded. So before install took 13 seconds. Why? Because in my appspec YAML file, you can see before install will install dependencies, and also it will start the server. So as it already showed you in my scripts, so install dependencies will update my application once again, my instance once again. It will install Apache 2. It will also remove the HTML page, index.html page within this location, because I want to launch my application, guys. So then start server will start my Apache 2 service. So only if the Apache 2 service is started, then I'll be able to see my website. So right now, as my pipeline is succeeded, I should see my website, guys. If I go over here, if I choose my IP or my DNS name, if I go over here and hit. So right now you can see hello world to Intellipaat. This is the website which is currently running, guys. So I'll go and show over here index.html and you can see hello world to Intellipaat. So right now, as I told you, this pipeline should automatically execute whenever there is a change in the master branch. So because that is what we mentioned, whenever there is a change in the master branch in this repository, this pipeline should automatically run. So what I'm going to do is I'm going to change few values over here. So I'm going to just change to hello world and then I'm going to commit my changes to master branch. So once I commit my changes, if I go over here, it should automatically start. So it is currently in progress because I have changed my code. After some time you can see there will be a commit ID, the commit, which commit it took will be present over here. Once it succeeds, that change will be implemented in my CodeDeploy agent. That is my EC2 instance automatically, guys. You can see source update index.html because this is my latest commit. This is the latest commit ID which it took. So you can see it's running, guys. So right now, hello world to Intellipaat. So now it changed to hello world. So this gets succeeded and this changed to hello world. And you saw there was no downtime over here. So this is why you use a DevOps pipeline. This is how you create a pipeline using CodeDeploy and your version control tool. So whenever there is a change happening in your version control tool, whenever there is a change happening here, so I'll just, okay. So whenever there is a change happening in your version control tool, that is this change when it is committed in the master branch, once it is committed in the master branch, this pipeline will automatically detect the change happened in your GitHub. It will take the latest commit made and it will run it once again. Once it succeeded, once it is properly run, then it provides the code to CodeDeploy. So CodeDeploy right now will download the contents of this particular GitHub repository. It will store in some location. We do not know where exactly it stores it. It stores it in some location. It will copy the index.html file into /var/www/html. So only if the index.html is available in that particular location, it will be taken by Apache 2 server, guys. So you can see this is how you create a code pipeline and using CodeDeploy and GitHub. So we've learned how to do this.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Now what we are going to see is Terraform. So we'll have to understand few things before getting into Terraform. Now, this is my AWS account. For example, in this case, this guy is a system administrator. And this guy is a system administrator. Okay, who's handling this environment? AWS Cloud. Now what happens? He is the one who set up all infrastructures in our cloud environment. Like it can be, he is the one who architected the design, and that a cloud application, cloud environment consists of EC2, VPC, and other services like S3, database, RDS, etc. Now here, in this case, let's consider he is working for 4 years in a company. He worked for 4 years in a company. Then, if he moves out of the company or the organization, if all of these environments, whatever he has set it up, if it doesn't have any proper, if it doesn't have any proper documentation, what will happen? A new guy who is coming, a new guy, whoever is coming, will not understand what exactly it is, like how the infrastructure is being created, what is the purpose of what is the purpose of EC2 service, how many EC2 services are there, and everything will be in a mess. Basically, but the new guy will not understand how exactly the entire architecture is being designed or created. And the next thing, everything is a manual task. Everything is a manual task in the sense, here if I wanted to create 5 EC2 instances, I will have to create it 5 EC2 instances manually. The same way, if I wanted to create a VPC, I will have to create it manually. And everything is a manual process in creating all of these services using a console. So now whatever we are doing it here is all through console. So whatever I'm creating it here is all through console. Again, if I wanted to create an EC2 instances, what I will have to do? Again, I'll have to go launch an EC2 instance, and again I'll have to create it. Correct? In this case, a new tool called as Terraform comes into picture. It is not a very old tool at all. It was developed in the year 2014, if I'm not wrong. It was developed in the year 2014. Okay. Now, what this tool does, it came up with a new concept called as infrastructure as code. Now, what we do, instead of creating it manually over console, so what we do is we create it as a code and we deploy it. Now what happens, anything which you created will have a trace of the code, correct? Like whatever, if I've created 3 EC2 instances, and I'll have a code of it, like, so that, and moreover what happens is it brings reusability. Like I explain you all those things, it brings in reusability. So all you do is you write code once and you use it multiple times. And moreover, it brings in automation of infrastructure. Automation of infrastructure. And how this code is being created? So they call it as HCL language. So the whatever the code which we write to create this environment is called as HCL. It's called as HCL language. And how do we do it? How do we create it? And we will see everything step by step. Use of Terraform. Terraform is to code your infrastructure. That is as simple as that. Like instead of creating everything over console manually, so what we do is we create everything using code. And what is that code? And that code is nothing but HCL. An extension of Terraform file is called as .tf files. .tf. Like for Ansible, we save it as .yml file, right? Likewise, any Terraform script will be saved in the form of .tf files. Now, using Terraform, what are all the services we can code? There are lots and lots of services which can be coded using Terraform, like major cloud platforms like AWS, Google Cloud, Azure, IBM, and then other providers, like for example, if you wanted to manage any other softwares. In nutshell, I can show you the list of providers which Terraform supports. Terraform providers. Now, using Terraform, what all we can create it, these many services we can code it. So if I wanted to create, for example, if I wanted to create, what are we have seen here? Let's consider if I wanted to create an SQL service. SQL server. Using Terraform, we can create it. For example, if I wanted to create a chef cookbooks, I can use Terraform to create it. If I wanted to create Azure Active Directory, Terraform supports. If I wanted to maintain the entire AWS cloud or Azure cloud or Google cloud, everything is supported using, everything is done using Terraform. GitHub, GitLab. So whatever we have seen here. For example, let's consider a use case where I wanted to create a user in GitHub. Now what we do, we manually log into GitHub and then we create user and then we whatever the permission which we wanted to assign it to the user, we will be able to do it. Now using using Terraform, we can do the similar setup also. See here, if I wanted to create any GitHub repository, I can create it. How we will create it, let's see. But whatever the manual task which we do using a console, which can be achieved using Terraform as well. And the main purpose of it is to code your infrastructure. How does it benefit? It benefits in such a way that we can keep track of the every resource which we configure using Terraform, and also if we wanted to reuse the code. For example, I write the code once like function, and then it can be used later everywhere wherever we wanted. Now we need to understand few terms before we get into creating any services using Terraform. Those are here. The first one is resource. Resource is nothing but, for example, if I wanted to create an EC2 instance, let's consider I wanted to create an EC2 instance. Now, what we define? No, before resource, let me put a few things, few other things also. Providers. So providers are nothing but which one we are going to use it. For example, it can be AWS, or it can be GCP, or it can be Azure, or it can be Redis, whatever it is. So what we are going to code using Terraform. So which one it is, and the structure, basic structure remains same, but the functionality wise it differs from providers to providers. For example, in AWS we call it as EC2 service. In GCP it is called as VM. Correct? Those terminology differs, but the core concept remains same. And the next one is resource. What is resource? Let's consider we are using AWS provider. Inside AWS provider, I wanted to create an EC2 instance. In this case, what we do, we create a resource. This is called as resource. Any services inside your provider is called as resource. Whatever we are trying to create is then it's called as resource. Variables. So variables are nothing but an input value which can be defined while writing our Terraform script. Output. Now, output is the resultant value. For example, using a provider AWS, I'm creating an EC2 instance. Okay, let's consider an input value I'm giving. So, if I wanted to create an EC2 instance, what all is required? If I wanted to create an EC2 instance, now what we can do is we can input these values by creating our EC2 instance. That is nothing but variable. And the next one is, for example, after creating this EC2 instance, it will come up with some values. For example, instance ID, correct? Automatically it comes up with. Then instance IP address. And these are the output values. So whatever the input values which we are giving it, from that we will get an output value. So that is called as output. Okay. Terraform plan. This Terraform plan is a command. Okay. Terraform plan is a command. In the sense, for example, I have created all of these code using all of these all of these things. I've created a Terraform script. Now I wanted to test that script before I actually apply it. In that case, what we will do, we will run Terraform plan. So Terraform plan, what will happen is it will just do a dry run before we apply it. That is what Terraform plan. Terraform apply. So Terraform apply is a command which is used to apply all your changes. In the sense, if I wanted to create any EC2 instances, first what will I do? I create the Terraform script. Then to test it, I will run Terraform plan. Then if everything looks good, then what we will do? We will we will then run Terraform apply. Then Terraform apply will apply all your changes in the script. Then Terraform destroy. So destroy will delete all your changes, whatever is there in your, delete all your changes. And the next one is Terraform init. Here, let's consider we are using AWS provider, correct? Now here, let's consider this is your machine from where we are running all of these scripts. Now here, all we would have done is installed Terraform into this machine. Now I wanted commands which is specifically for AWS, correct? Only then AWS related configurations will work. In that case, after writing all your code, first you will have to run Terraform init. So what it does is it initializes all modules or all the required modules which are essential to run your script. That is nothing but Terraform init, which initializes all your modules which are required to run your service. Run your scripts. That is nothing but Terraform init. Then what else is required? Very important thing is TF state file. Name itself says, in the sense, TF state file is nothing but a state file which holds all configurations of whatever you have created using Terraform. In the sense, for example, I wrote a script where it creates one EC2 instance. Okay. Now, in the same EC2 instance, the same script, what I'm doing it is, I'm creating.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
I'm creating one more EC2 instance. Now, first, one EC2 instance configuration is already added. It's already there, correct? Now, I'm adding second one. In this case, what it should do, it should not create the instance which has been already created. All it has to do is, it has to create only the second one. How Terraform will know that one instance is already being created and only the second one has to be created? And in that case, Terraform statefile comes into picture. So any configuration which you run, it first checks with your TF statefile whether all of these configurations are matching your TF statefile and with the current configuration file which you have written. If anything is missed, then it will create the required services. So that is the function of TF statefile. Cool. Now, and this is one of the most predominantly or widely used tool in DevOps industry at this point of time. Till now, if like any infrastructure related activities are handled manually, now everything is being coded, and Terraform is one of the important tool which is being used in the industry, and I would really recommend you guys to go through it. So we'll use AWS for our configuration. What is the first step? First step is to install Terraform on your machine. Now what I will do, I will use one of my EC2 instance which I've created. Okay, first what we'll do, let's install Terraform on that machine. So how do we do it? All you'll have to do is download Terraform. You will get the version of it. So all you can do is whichever version you wanted to install. If you're trying it in your local machine, you can use you can download Windows and then try it. Or if you have any Windows machine, just download accordingly. Let me download this one here. Copy and then wget. Yes. Now I've downloaded the file, and you will see something called as this. Then what you need to do is you will have to move this file to, if it is Linux machine, move Terraform to user local bin. Then what you will have to do, check then cd space user local bin. Then once it is done, Terraform. Why it is not running? Terraform to user bin. So you will have to move, just download the file, just copying it and just writing it here, so that then move the file to move unzip, first unzip, second move the file to move Terraform to user bin. Once it is done, you will be able to, you can check and verify with the command terraform - and the latest version is this one. 12.24 is the latest version which is available. Now we are set with this. Now what is the next step? Let's consider we wanted to create an EC2 instance from this machine. In this case, what we will have to do is Now, one logical question, okay? If I wanted to manage, this account, what is required? For example, if I wanted to manage this AWS account using an CLI, what is required?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Here, so what we need to do is we need a credential where we can manage the account using our Terraform or whatever it is. For that, what we will have to do, first we will have to go and create one user. If somebody is new to the cloud, so what you'll have to do is go to service, IAM, IAM. IAM is the service which is used to create your user accounts. Then go to users. Then I'm creating a user with the name Terraform. So all it needs is just programmatic access. Okay? So I'm just giving programmatic access and then click next. Here, what we'll do, we'll attach existing policies directly. We'll give administrator access so that using the Terraform account, it can do anything it wants over this account. But in real time, you will have to come up with a best practice solution where we can actually give access to the console in a better way for any programmatic access. Now let me name it name Terraform, just Terraform, and then click review, create user, and then let me download the credentials out of the closet. Now here what we are trying to do, so we are trying to create an EC2 instance using this. So what I'm doing it is I'm just going to one directory, and then what I'm doing, I'm creating one directory, mkdir, and then press Terraform. And then I'm going into that. I'm creating one more directory, mkdir. I'm creating DevOps. So in this directory only, we will have all our configurations will be in this directory. Correct. Here, what we'll have to create, we will have to create one file called as main.tf. Let me create one file here. In this, let me get into this file, insert. Now, what is the first step? If we wanted to manage, we will have to define provider and mandatory. So now, first, what we will do, we will define our provider here. We will define our providers here. Version is nothing but earlier they were using 2.2 version 2. With 3 they have included so many other new services also, like ECS cluster, so many other services we also included in version 3 with new features. That's it. Now what I'm doing it, I'm just doing this one. That's it. Greater than or equal to 3 and provider AWS version region. Now it is done. Now what we will have to do, we will have to download that provider into our machine. How do we do it? Which command we use that to initialize all modules? Terraform Terraform init. So okay, now we know that we wanted to configure AWS account. Now, how AWS, I mean, how this Terraform will know that which AWS account I will have to manage? It will not know, correct? In that case, what we will have to do, we will have to configure credentials of that AWS account with this Terraform. How do we do that? In .tf. So what are the keys which we have created? Just give me a moment. Access key ID. What was that? Yes. Now here we will have to give our credentials, whatever we have created. Access key ID, shift insert, pass your access key ID, and then ask your that's it. Good. This is our configuration now. This is our configuration. Now let's create an EC2 instance. Let's create an EC2 instance. Now our Terraform is ready to configure our AWS account. Okay. Now here what we will do, we'll create an EC2 instance using Terraform. So how will we do it? You can either use main.tf, or if you really wanted, no, you can create multiple files also. At this point of time, let's not do that. What we'll do, we'll continue editing our file. If I wanted to create any resource, then what I should use? I should use a resource, correct? I should use a resource. Now let's go and get the what we are trying to configure. We are trying to configure EC2. I'm trying to make it simple so that you understand it. That's it. So this one we have seen, right? Access key and secret key. Now, access key and secret key is unique to each and every account. For example, I have an AWS account. You also have an AWS account, and others will also have their own AWS account. Now, using Terraform, how will I define which AWS account I will manage it? And that is where a access key secret key comes in. Okay. Now let's see. Now what it does. AMI is nothing but, like, for example, AMI is nothing but like when we launch an EC2 instance, what we do. Like, see, whatever we are doing it here, we are doing it there manually. Whatever we are doing it here manually, we are doing it there also. We select an AMI, right? So instead of just selecting over console, so what we do is we give an AMI ID. Every image as an ID. Every image as an ID. and that is what we are giving it here. Okay. Now, what are all the features it supports? Let's consider if I wanted to create an EC2 instance, these are the arguments which you can pass in the sense which availability zone you wanted to pass, like US East 1A or US East 1B, everything. Now, at this point of time, what else is required? As mandatory, what else is required? We need key, correct? We will create key name. So these are the arguments which are being passed to the script so that we can create an EC2 instance. Now let's consider key -name, which is nothing but I have one key which is DevOps, and tag is nothing but the name which we generally give while creating an EC2 instance. Now name equal to, let's consider Terraform first instance. Terraform instance. Terraform instance. Now our first script is ready. Now what are we are doing? See, this AWS underscore instance is the keyword. Which resource is what which we are creating? Which resource which we are creating here? We are creating AWS instance. This is the name of the resource which we are giving it. Okay, and for this AWS instance to launch an EC2 instance, what all is required? We can pass. See, anything which is given required is mandatory. These arguments AMI and instance type is mandatory. To launch an EC2 instance, these two parameters are mandatory. Other than that, we can customize all other configurations. All other configurations we can customize it. Now, till here we are done. A resource AWS instance, Terraform, AMI we have given, instance type we have given, key name we have given, and then we have given a name for this EC2 instance. Okay. Now, what is the next step? We will have to Terraform plan. Correct. So why do we do Terraform plan? So we run Terraform plan to check whether all our configurations are done properly or not. Let's do it here. Now here, see, it is asking in which region we will have to configure it. You remember? So while configuring providers, there was one option here, region, correct? Which I have deleted it. Region. Now here you can define your default region. US East-1 is Virginia. I have defined it here. Now if I run Terraform plan, US East-1. Wait, it is showing error. Because key underscore. Now what will I do? Terraform. Now what it says? It says new mission will be launched. So this will be the configuration. Now what will I do? So how will I create a new mission here? I mean, if I want to apply these changes, what will I do? What will I have to do? Terraform apply. Which command? Apply. Terraform apply. Now you will have to give yes. The moment you give yes, it says error. No subnets found for the default VPC. Please specify the subnet. Now what happens is, since whatever we have given it here, it tries to launch it on the default subnet. Now what? Deleted my default subnet deleted when you look at here VPC. See here, I've deleted the default subnet and I've created my own subnet. With that configuration, what it does is, so whatever we have done here, it tries to create this EC2 instance in the default subnet. Now that is what we got an error. See, for launching source instance missing no subnets for the default VPC, please specify the subnet. Now what we will do, we will go configure main.tf, then include one more configuration, which is nothing but subnet. Let's check whether it is right. Subnet underscore ID. That is the argument which we will have to pass. And this is the subnet ID. Now again, what we will have to do after making changes, Terraform plan. Okay, now if you look at here, it will say that subnet ID is this one. Correct? Earlier, when you look at, you would have not seen that. Now Terraform apply. Cool. Now we can see that one resource is added. Let me go to my EC2 instance. Earlier it was one instance running. Now it is two instances. Second instance, this instance is running here, and whatever configuration which we have given, it has come up. Now you can see one thing here. It did not have any public IP address. Correct? It did not have any public IP address. Now in this case, what we can do, what is required, if I wanted to connect to this machine, a public IP address is required. Correct? Now let's create a public IP address for this machine and then attach it to it. Now in this case, Terraform apply is already done. Earlier you will not see one file called as terraform.tf state. After you apply your first change, this file will get created, terraform.state file. What is the purpose of this terraform.state file? It maintains all the information about your configuration. This is your instance ID. See, this is your instance ID. The state file maintains all information about the resources which are configured using Terraform. Now let's see. Now what is our second requirement? If we wanted to attach any public IP address to that machine. Okay. Now in this case, what we wanted to do, any guesses? If I wanted to create a public IP, there is a resource called as AWS EIP. Correct? There is a resource called as AWS EIP. Just go there. Here, what will I do? Create and so this. Now what we are doing? We are creating one more resource, which is nothing but AWS EIP, and let's name it as Terraform instance EIP. Now, this is nothing but getting a value of, this is how we get value of other machine. So whatever we got it here. See, the whatever we are getting it here, what is this? Syntax is the older version syntax. Here we don't need that. This all of these things are not required. Now what I need, to which machine we are attaching this elastic IP? To this machine, correct? And what is the resource name? Which is AWS underscore instance. And what is the name of the resource? What is the name of the resource? Which is Terraform. It is Terraform. And ID, to understand that, we will have to understand a bit about what are all the values it results. Let's consider, where is it, EC2 instance, AWS instance. See, attribute reference is nothing but what are all the values it can result. In the sense, see, what are all the values you get it in your TF state file. Terraform.tf state file. Here, what is that? ID, correct? See, this value, it results from this configuration. What is that configuration? This value holds this machine. Now what we are doing it in this configuration, I'm creating one more service which is nothing but EIP, and this will after creating that elastic IP, it has to be attached to this EC2 machine. How do I know that to which EC2 machine I will have to attach? Using this configuration value, AWS instance.terraform.id. This ID actually holds what? The value of that machine, which is nothing but this one. This one, the value, this one, let's consider, if I run this value, what will happen? Terraform plan. See what happens. It creates an EAP and then attaches and gets attached to that EC2 instance. Same way, what will happen? Let's see if I give that value. I'm replacing it with, so these are dynamic values which we can get it. How do we get it? AWS underscore instance underscore dot terraform dot id. Now again, if I run terraform plan, see, we got the same value. Now let me apply it. Terraform apply. Ask for check, select yes. Now you don't see that public IP, any public IP is being attached here. Now if I refresh it here, see, one IP got attached to it. And this is how it works. Now, if using the same concept, what we can do is we can create any number of services which AWS provides with bit of fine tuning that is required. That is required according to a configuration, the best practices which we follow and everything. Now, let's talk about something called as variables. Now, the same concept is same. Variable is nothing but if you wanted to input any variable, then we use concept called as variable. Correct? If you wanted to pass any values from the user or get values from the user, then we define variable. And how do we do it? There are multiple ways to do it. One, what you can do is you can create a file called as variables.tf, whatever it can be. I'll give it as inputs.tf. Inputs.tf. You can create the same method also. I created with the name inputs.tf. So what we can do is, let me get some values from the user. Why do we have to give this value automatically here? If I give, everybody can use it, right? So what we can do is, we can define it as a variable so that it doesn't being exposed. Now what I will do, I will define it in such a way that give var dot access underscore key and then var dot secret underscore key. So in this case, after defining it here, so go to inputs.tf file. We will have to define that variable. So how do I define that variable? Key name is variable and give the name variable. Let's, what is the name I'm giving? Access underscore key. Then open bracket and then go close bracket, and then name is, we will have to define which variable type it is. Now what variable type it is? That is string. And there are different types of variables also, like list of string, maps of string, tuple of string, lots of other things are also there. At this point of time, let's not get into that level. So the value which we require there is string. And how do we do it? Type equal to string. That's it. The same way, we have one more variable also, secret underscore key, type equal to string, and then close it. Now with this, what happens? Now let me check the configuration, whatever I've done, Terraform plan. See, now here it asks for the value. What is the value? var.access key, which I will have to give it from. And then secret value. And that's it.
So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay. So first of all, you'll have to sign up on AWS. Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do
I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service. Just click over there. And this is the management console that you will get. Okay. Now my job is to deploy a server. I will do that. But first I need the network that we were talking about, since the past 15-20 minutes. We need the network ready first where we will be deploying our servers. Okay. So the EC2 service is for deploying your servers. Now for getting a network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it. And here you can deploy the kind of network that you want. Okay. So now let me, brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, the word network is can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges. So your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay. So first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to, uh, uh, define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay. So first, let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay. This is where all my resources are going to be. So I'm going to name it as Netflix, and let me give, an address. So everything that you deploy on a network has, an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay. So now what we're going to specify in this IPv4 CIDR block is the range of IP addresses that I'm going to have. That is, let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create. And what you have now done is you have created an office network, or you've created a network for your application. Okay. Now inside this network, I'm going to create subparts. Okay, because some resources I want to give internet access, and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, so let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay, so right now what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create, a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20. If I specify something called as /24, that's a smaller part of a range which is /16. Right? For example, if I specify, so just assume it like this: if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay. Now, when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. So I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center, right? Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
2 subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly, and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnet will have internet access, and the private will not have internet access. Okay. So what I'm going to do is, first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? Let me go ahead and tell you. So for example, if you need a Wi-Fi at your home, or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi, you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is, first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now you'll see it in a list. So I've created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attach to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it, and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is, whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So in a simpler way, if I were to tell you, you have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay, so what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table, right? And let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay, so to this non-internet route table, let's go ahead and attach the subnets which will not have internet, and to this internet route table, let's attach the subnets which are going to have internet. Okay, so first let's attach subnets to the internet route table. We'll click on subnet associations, and here, as you can see, there are no subnets attached to it as of now. We'll click on edit subnet associations, and we will attach all the public subnets where we need internet to this route table. Okay, so now the route table have been attached, the subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay, so let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay, so all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay, so now that we have one network which is going to have internet with us and the other network which is not going to have internet with us. Now what I'll be doing is, so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay, so now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. Click on enable auto assign public IP for address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay, all the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in my public 2A will have a public IP address, and even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service. And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay. So the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay. So let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here which says free tier eligible. Select that. It will give you 1 core CPU and it will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay, so I am going to deploy it in the public subnet as of now, and what I'm going to do is rest I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work. 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall which is called security group, and I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay, so we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay, and who can connect to this firewall? Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here in the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon, so I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo. This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download key pair. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay, and I've launched it inside a public subnet. Okay, so now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server. Right, it has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default, so we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configuration you can see for your server over here. Okay, now what I'll be doing is I will be selecting the security group, which is the default security group, and let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I click on edit inbound rules, and now first of all, let me tell the server that only I can connect to it. So I will specify my IP, and as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay, so any kind of traffic from my IP address will be allowed to this server. Okay, so this is the setting that I'm specifying right now. I'll click on save rules, and this setting is done. Now this will be changed later when we will be deploying our full stack application, but for now this is the IP range that I have specified. Okay, now I'll go back to my dashboard, go back to my server, select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay, so this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay, now here is something that will be different, that can be different on your system. What is different on mine? So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay, now when you might be on a Linux, sorry, you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay, so there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download putty over here. Just click over it. And here you can download, the putty version. So you have to download the 64-bit version in case your processor is 64-bit. If you have 32-bit architecture, then you will be selecting the 32-bit version. Okay. Once you download it, there is one more software that you have to download, and that is called Putty Gen. Okay. Download this as well on your system. Now, once you have Putty Gen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file. This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your Putty software. Okay. So what you have to do is you have to convert this PEM file into PPK, and that can be done using this PuttyGen software that you will be downloading. Okay. So how you can use the PuttyGen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your PuttyGen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded, click on OK, and then click on save private key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay. So with that done, once you have the PPK file, next you will be opening your Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay. So once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay. So if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay. So this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the PuttyGen software. Put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is, let me pass in the command. So this is the command that you will be using when you're on Linux. Okay, so people who are there on Linux, first you have to go to the folder which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. Sorry, the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It will ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu @ now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username @ of IP address of your server, and then hit enter. Okay, so it will ask you whether you trust the server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning, which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and this should do the trick. Now pass in the same command, and there you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay. Now that we have connected to our server, what I'll do is I will basically make it a web server, and then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay, so when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine, first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes. Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I'll just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay. Okay. So now what I'm going to do is, guys, I'm going to basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay. So what I'm going to do is, this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. One second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay. And if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which are probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. One second. You have connected to netflix.com/watch in order to get to this page where you can playing this video. Okay, now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force. Can you still see? It's still netflix.com/watch, and then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if you remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have routed me to something else because they do not want me to just access the web the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page which says, let's say, welcome to home page. So I will create an HTML page which will, this is a very simple HTML code that I'm writing over here, which will says welcome to the home page. Okay, so this is what I've created, and if I refresh over here, you can see it says welcome to the home page. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the home page. Now our web page, our web server, our home page is now ready, and now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard. and this is the server that I created. So let me create a copy of this server first, and then that copy I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions, then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times in. So we'll create an image. Let's call this image name as homepage, home, Netflix -home. Let's specify this. Right? Let's click on create image. And now my image is getting created. Okay. And that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIs. So if you go to AMIs, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the elastic load balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same. And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just / or just no URL at all, in that case it will be routing my request to the home page. So this is possible using the elastic load balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within our Netflix network will be able to interact with each other. Okay, so in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access, public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands, as I did on this terminal. Okay, so if you want your load balancer to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay. And even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content and from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks, which were public and private. Public had internet access, private did not have internet access. Okay, so all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Now imagine this rectangle is my private subnet. Okay, and this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay, so if I connect to a server which is there in my public subnet, right, because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this, and then in this server which is there in the public subnet, if I enter the SSH command again, and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I be not be able to connect to it? Okay, if I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html, and this time let's say welcome to the streaming page. Save it. Okay, and now if you go to this IP address, you will see it will now say welcome to the streaming page. Okay, and now let's create an image out of this as well. So again, we'll go to EC2.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job. Now, let's continue with the session.
So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. Let's see how we can do that. So I click on launch instance, and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier, just that now I will be selecting a private subnet which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay. So we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances. And with this, my streaming page.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets, and as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have let's name it as proxy server. So I have a proxy server which is running in the public subnet which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called SCP, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. and I want to copy it in this particular file location, which is /home/ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully. So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? The next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the pen file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now, what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if we check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to if some maintenance is required, how to do maintenance on your private machines. Right now, what I can do is once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my private machines. One thing that I forgot to show you was, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to. right? This has internet connection. How do we know that? First of all, we are able to access it from my local machine. At the same time, if I type in curl google.com, you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Let's create a load balancer. So I'll just scroll on my EC2 console and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer. And I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, that which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. And let's click on next again. So this is the target group that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is, now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is, so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener, and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream, or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. So let me first save it, right? And let us add one more rule. So if the path is /home, okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay. So now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And so first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs. Okay. So just sign up on Freenom. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain, check it out, continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS Management Console, click on services, type in Route 53. Now, once you're inside Route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.tk. Give the same name over here, click on create, and this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this, copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in Route 53, you just have to do one small change. Click on create record set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the Route 53 service that you have. Now this Route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your Route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk. hit enter, and it will now route you to the home page directly. And now if you go to the URL/watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well. So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it'll take you to the home page. If you type in netflix.tk/home, it'll take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS.
Just a quick info, guys. Test your knowledge of DevOps by answering this question. Which of the following is a DevOps tool? A. Git, B. Jenkins, C. Docker, D. All of the above. Comment down your answers in the comment section below. Whoever gets the correct answer will win 5,000 points in Intellipaat wallet. Subscribe to Intellipaat to know the winners. Now, let's continue with the session.
Okay, so we've seen that. First of all, before going into the certification details, I'll explain what is AWS DevOps. So AWS is a cloud platform, fine. DevOps is a methodology to automate the software development lifecycle. So how does these two come together? So first of all, to create software, to build software, you need tools. To release software, you need tools. For every single process, you need certain tools. So using AWS, you can launch servers in which you can build your software, you can test your software, you can push your website into, and you can host your application over there. You can do every single operation in AWS. So now an AWS DevOps engineer will specialize in using AWS for DevOps. That is, this particular person who is an AWS certified engineer will know how to use AWS, how to use DevOps, and also other tools. So under DevOps, let's say tools like GitHub, then there will be tools like Jenkins, there will be tools like Nagios for monitoring, XDeploy, and then there is Chef, Puppet, Ansible. So this particular person should know all these tools as well as AWS services. Only then he can or she can clear the examination. So that examination's code is DOP-CO1. So this is the code for the AWS DevOps certification. So I think you would have understood. So DevOps is basically automating the software development lifecycle. Now, if you're doing that with the help of AWS, then you can go ahead with the AWS DevOps certification. Okay, so first of all, what is it? The AWS Certified DevOps Engineer -Professional. So this is DOP-CO1 exam. This is intended for individuals who perform a DevOps engineer role with 2 or more years of experience provisioning, operating, and managing AWS environments. So I'll tell you this. First of all, you cannot directly become a DevOps engineer because you should have worked in the IT profile. Only then you can move ahead with DevOps engineer, because every single role in DevOps engineer requires certain experience on using GitHub or other DevOps tools which that particular company is using. Okay, so that's what I wanted to convey over here. Then, so to clear the DevOps certification, what should you go through? So they have content domains and their ratings. So there are 6 main domains which you'll have to concentrate on. So this is not randomly taken values. These are taken from the official guide provided by AWS. So for the AWS DevOps certification, so you can check that out online. You can just type in AWS DevOps certification and you'll get the official site. You can go in and download the guide and check it for yourself. So under this, there is SDLC automation, there is configuration management and IAC, which is infrastructure as code, monitor and logging, policies and standards automation, incident and event response, high availability, fault tolerance, and disaster recovery. So that percentages are the weightings of questions in the examination. So if there are 100 questions, there would be 22 questions from SDLC, 19 questions from configuration management and infrastructure as code, and the others. So I think you got the idea of how this works. Okay, so first of all, SDLC automation, which is basically software development lifecycle automation. You should know all the tools required to do that. Maybe in AWS as well as other DevOps tools like Docker, Kubernetes, Jenkins. Then configuration management and infrastructure as code. So configuration management basically deals with tools like Chef and Puppet. So you use this to manage the configuration in all the servers. So let's say you have 10 servers having the same application. So all the 10 servers should have the same configuration, right? So you can use a tool like Chef. So you can create a master and all the other servers will be your slaves. So what you can do is, this master should be connected with all the other slave servers. So once that is connected, you can upload the configuration file to the master. So the master will take care of master will take care of making sure all the servers connected to that are having the same configuration. So this is what configuration management like simply is. This is not the whole thing. And then infrastructure as code, where you can create a JSON file which you can use to create a complete architecture. So if I go deep into this will take a lot of time. I'll give you a basic idea about this. So first of all, SDLC automation, configuration management and infrastructure as code. Then monitoring and logging does not come third. Third comes incident and event response. So I'm saying third in the percentage, that is the weightings. Okay, so incident and event response in the sense there would be a lot of troubleshooting. So because you will have to, whenever there is a bug, whenever the application is down, you should know how to respond to that. You should know how to solve that. So that comes under. And then comes high availability, fault tolerance and disaster recovery. So first of all, high availability in the sense the application which you are hosting online should be always available for the customer. It should never go down. Even if it goes down, it should come back up immediately. Fault tolerance and disaster recovery. So when you have an application hosted in a particular availability zone, if there is a, let's say there is a calamity happening over there, let's say there is a huge storm and the data center is completely off and you cannot host your application over there. So you should have a replication of your entire application in another availability zone for this particular issue, so that when the application goes down over here, we can start off the application over there. So basically recovering from a disaster. So once this availability zone comes back up, you can go back to using this. And then comes monitoring and logging. So you need to know how to monitor all your essential tools required for SDLC automation. You should know how to monitor your complete software development lifecycle in a single go, and also logging. And then comes policies and standards automation. So this is mostly theoretical. You should understand the policies and the standards of automation of the company you are in, as well as the regulations. So the thing is, to automate any software, you will need certain policies that this should happen and this cannot happen. So you'll have to figure out what is that, and then you'll have to work towards that. Okay, so these are the basic content domains and their weightings for the AWS DevOps certification. So now the recommended AWS knowledge you will need to clear this particular certification: 2 or more years of experience provisioning, operating and managing AWS environments. So to clear this particular examination, the recommended AWS knowledge given by AWS themselves is you should have at least 2 or more years of experience working on AWS. And then comes experience developing code in at least one high-level programming language. So only if you know to program and create applications using it, only then you can easily understand the SDLC process. So that is required. Experience building highly automated infrastructures, that is creating let's say again an SDLC lifecycle which is automated, or a DevOps lifecycle. Then experience administering operating systems. So this is basically monitoring when there is an issue, when there is a problem, troubleshooting it, and understanding of modern development and operation processes and methodologies. So this is, let's say you're using a certain tool, and in the market there is a new tool which will make that process much simpler, but if you don't understand how it works, then you cannot take that up. So let's say you're using Jenkins and suddenly there is a new release called Jenkins 2.0, which makes the CI/CD process much simpler, and you're still using Jenkins for SDLC lifecycle, and sometimes that might not be appreciated because you should adapt to the modern development. And if there's a much easier way of doing something, you should move towards that. Okay, so this is the recommended knowledge. Now the DevOps learning path to attain the AWS Certified DevOps Engineer Professional Certification. So the thing is, there is no prerequisites to take this up. You can directly take up the AWS Certified DevOps Engineer Certification, but it is not recommended because it's a very advanced examination, and the recommended path to get the certification is provided by AWS. So you can check this path out. First of all, you can take up Certified Developer Associate or the SysOps Administrator Associate certification by AWS and get that certification by clearing those exams. So you can do this in your first year or second year of your job. So once you did this, you can either take up a DevOps engineering on AWS or advanced developing on AWS courses, so you can learn how this actually works in the real-time industry. And then you can take up a practice exam on DevOps engineer before taking up the actual exam. So DevOps engineer exam readiness exams are pretty cheaper than the actual exam, so you can take that up. And if you're confident enough, you can give a go to the AWS Certified DevOps Engineer and you can get the certification. So this is a simpler path, but this will take a lot of time to achieve if you're going to take up this particular path. Okay, so you can take this up. Next, the examination details for the AWS DevOps certification. So you can see here the examination is multiple choice, multiple answer. It is a professional type. Then the delivery method is you can take it up in a testing center. And right now, as you know about the COVID situation, there is an online proctored exam as well. You can take that up. And then time 180 minutes to complete this particular exam. Cost 300 USD if you're taking it up. If you're taking the practice exam, it is 40 USD. You can also, as I told you, this is for professional. If it is an associate certification, which is AWS Certified Developer, the cost of the examination would be 150 USD and the time would be 130 minutes, and practice exam cost would be 20 USD, and the languages available will still be the same, which is English, Japanese, Korean, and simplified Chinese. Okay, so these are the exam details and this is the learning path. Let's move ahead to AWS DevOps Engineer, roles and responsibilities. So first of all, so let's say you have learned everything you need to know about AWS DevOps Engineer. Then if you want to become an AWS DevOps Engineer, you should understand the roles and responsibilities of one. So first, who is an AWS DevOps Engineer? So an AWS DevOps Engineer will design and develop automation using AWS and other DevOps services to support the CI/CD workflow or the DevOps workflow. So to be very simple, an AWS DevOps Engineer will create an SDLC, that is a software development lifecycle, using AWS and other DevOps services together. Okay, so we saw this, who is a AWS DevOps Engineer. So I think you would have understood that point very easily. Now coming to this, now let's check out some AWS DevOps job descriptions. So these are two job descriptions which I found and we'll compare this. First of all, this is an AWS DevOps Senior Engineer job description. So at the very beginning, you can see, don't process any profiles without the below must-have skills. So these skills below, which are must-have, so not must, good to have is not a problem. It's not required that you know those tools, but in any job description, you should know the tools which are provided in the must-have section. First of all, code repositories, GitLab is must. Runner, Bitbucket configurations tools. Then you should know Docker, you should know Chef, Ansible, so Bash scripting, Groovy. Then under AWS services, you should know ECS, Fargate, Lambda, SNS SQS, CloudFront, Code Build, configuring CloudWatch, Secret Manager, Active Directories, Serverless Application Model, Service Catalog, Kubernetes. And then comes Jenkins, Maven, npm automation, and then rundeck. So these are for CI/CD. Those are AWS services. Those are Docker and code repositories. So these are some of the must-have tools, and you can see there are a lot of AWS services and DevOps tools involved together for an AWS DevOps senior engineer. And then this again is an AWS DevOps architect. So under this you can see the job description is pretty simply provided. First of all, implement and stay abreast of cloud and DevOps industry best practices and tooling. So this is basically theoretical. You should know how the cloud industry and the DevOps industry is moving ahead. And then also you should be an expert in these 3 tools: AWS Code Commit, AWS Code Build, AWS Code Deploy, as well as AWS Code Pipeline. So these are developer tools provided by AWS. These are not separate DevOps tools. So I just wanted to show 2 different JDs to show how much it varies. So basically it is dependent on the company you're applying for. So in this company, right, if you want to take up, you should know all of these tools. If you want to take up in this company, which is GroupSoft, they have provided you should be an expert in 4 main tools: Code Build, Code Commit, Code Deploy, and Code Pipeline, and also good communication skills. Obviously that is needed for any job. Okay, so we've seen the job descriptions. You can go ahead and check out job descriptions in various job portals like Indeed, Glassdoor, let's say Monster. You can check that out. You can figure out what tools you know and what you'll have to learn, and then you can register for an application. Okay, so you've seen that. Now, what are the companies which are hiring DevOps engineers right now? So before taking up this session, I looked into companies who are currently hiring for DevOps engineers. So it's pretty simple. Just go to Google and type AWS DevOps engineer or Azure DevOps engineer or just DevOps engineer, because any DevOps engineer would require to learn cloud tools. So if you are just searching for a DevOps engineer role, even then you should understand the basics and know how to work with AWS. So these are the top companies which are hiring currently for DevOps engineers. Anyone who is aspiring for a DevOps engineer job, you can go ahead and apply for those jobs and go ahead with the interview. So there is SAP, there is Paytm, Amazon, Oracle, and Dell who are currently looking for a DevOps engineer. But you should remember this: all of these companies require an experienced DevOps engineer. So do not apply if you're fresh. Sorry, don't apply if you're a fresher. Just take up a developer post or any other software engineer post, then move ahead with DevOps engineering. That would be a better career choice. Okay, so now we've seen that. Now you might also have a question of what are the services should I learn, because we saw various different job descriptions and it had contrasting tools which you'll have to learn. So let's see what are the main tools you'll have to learn. First of all, in AWS DevOps, these are the top developer tools provided by AWS themselves. So you learn Code Commit, Code Build, Code Deploy, and Code Pipeline thoroughly. So learning these tools is important. Then comes the AWS services and the DevOps engineer tools. So under AWS services, learn every single tool if you want to, but there are hundreds of tools and you cannot learn all of them. So take up 10 or 15 services which are extremely important for a DevOps engineer role, such as EC2. EC2 is basically a server creator. You can create servers, maybe Linux or Windows. And then Amazon RDS is a relational database service where you can create databases. That is also required for any company who develops software. And then Amazon EBS is for volume. Amazon Direct Connect is for connecting the cloud, the cloud architecture with your on-premise setup. Then there is S3 for storage, Elastic Load Balancing for balancing your website's load. And then Route 53 for routing. It's basically a DNS server. And then Amazon VPC is more of an AWS concept in which you can create virtual private cloud. That is creating a network within the cloud so that all the resources within that particular cloud is not available for the public. And Elastic IP address is basically an IP address which you can use to locate your server, which is the EC2 server. Okay, so these are the services in AWS. And you can see the DevOps engineer tools. First of all, you'll obviously need to know a source control tool. Either it's GitHub or Atlassian's Bitbucket. So let's say that company is using the Atlassian ecosystem, go ahead with Bitbucket. If not, GitHub is the most commonly used version control tool. And then configuration management, Jenkins is a CI/CD tool as well, and Jenkins and Puppet, Chef, you can take that up. Ansible, learn all these tools. For cloud, learn both of AWS, Azure. If you want, you can learn GCP as well, or take up any one of these cloud tools, either AWS or Azure, and go ahead with that. And then comes Docker, LXD for containerization, and for orchestration comes Kubernetes. So containerization, again, you'll have to go ahead and learn DevOps, only then you can understand these concepts. But just remember this, you'll have to learn Docker, very important. Kubernetes is very important. Okay, so these are the services which you'll have to learn if you want to become an AWS DevOps engineer. So AWS, given that, you should learn the AWS services as well as these 4 tools. And then you should also learn other DevOps tools like GitHub, Docker, Kubernetes, Jenkins, Puppet, Chef, Nagios, and there are so many DevOps tools which you can learn from. But again, don't learn all of those tools. Take up certain tools and learn them thoroughly.
Just a quick info, guys. If you want to make a career in cloud and DevOps, then Intellipaat provides an advanced certification in cloud computing and DevOps by ENICT Academy IIT Roorkee, and it is taught by IIT Roorkee professors and industry experts. This course is designed to help you upskill and land in your dream job.
So now we have come to the end of this session. Please subscribe to our channel and hit the bell icon for more updates.